All right. Kicking things off on the last day of Modular Summit, I'm Zaki Munyan, and first up we have Jim from Catalyst talking about sort of modular AMMs.
Thank you, Zaki, for the kind introduction. Good morning, everyone. Last day of Modular Summit, last day of ECC in Brussels 2024. Hope everyone is still lively and pepped up. I'm excited to get the morning slide and get everyone energized to talk about modular liquidity today. So today we're going to talk about the bridge endgame. I think everyone is kind of working towards the same kind of outcome in terms of a mechanism design perspective, from a liquidity perspective. And we're going to see what that endgame looks like when we're building for the scale that we're going to see in the future, which I think is infinite chains, or millions of chains. But quickly, just a quick intro. I'm Jim. I'm the co-founder of Catalyst, which is a cross-chain liquidity protocol. I've been a PM in crypto for about 7 years now in various organizations. And I'm also a really big bridge enthusiast, which means I read all the bridge articles, I talk to all the bridge people, I live it, I love it, and I breathe it. And then Catalyst is effectively a liquidity engine for all chains. It's purpose-built such that we can expand to any execution environment and connect them together and eventually share all the liquidity between them. So the future, like I said, is infinite chains, right? Millions of chains. And this is something that I've talked about on Twitter for several years now. And then other folks like Nick on the Celestia team and now the Axelar team and other interoperability teams are starting to feel the same way. And so I think we're going to see a paradigm shift or a mental shift where we think of rollups and we think of chains as equivalent to apps. App teams are going to be launching their own rollups and chains because it's just so easy to do, right? Basically a one-click, simple and as easy as deploying a smart contract as enabled by something like Celestia as an underlying DA layer. And so with this upcoming future, we basically have a choice, a fork down the road, where we can enter utopia, which is modular enlightenment, ample block space and a perfect user experience built to onboard billions of users and all the transaction flow that's going to come with it. Or we're going to go down kind of a very, very terrible route, which is modular dystopia. Effectively chaos that ensues when you have all these millions of chains all fragmented in terms of liquidity, in terms of UX, and in terms of social alignment. And really the only thing that's actually keeping us on the left-hand path as opposed to the right-hand path is interoperability. And that will bring us towards this modular alignment path, which is why I personally feel like it's so important to be building interoperability in order to ensure that we stay on that road. However, it's really, really easy if interoperability is kind of faltered in a certain piece for this modular chaos to kind of unfold. And so this is kind of the Thanos that we're kind of facing in this modular endgame that's blocking our way towards this modular alignment future that we're seeing. And so to quote my favorite person, Steve Rogers, Captain America, this is the fight of our lives, and we're going to win whatever it takes. And so the good thing about modular chaos versus modular alignment is that we're assembling the Avengers team. We're working together collaboratively with a lot of different folks in the team, right? We're not doing this alone in order to ensure that we're taking down modular chaos and that we're building towards the road of modular enlightenment that we're kind of seeing in the future of millions of chains. And so just to quote John Charb a few weeks ago, we're all building the same thing. And what that looks like in terms of modular enlightenment is basically what we call the modular mullet. And so we have chain abstraction in front, which is a way in which we can basically abstract away all of the blockchain complexity for app developers and for users. And on the back end, we leverage the millions of chains or the infinite chains they're going to see in order to have all that ample block space and all that customization that chain developers really want and desire. And so what that looks like from a more kind of technical lens, is basically cake. It's basically the chain abstraction framework that Frontier Research pioneered, where we have all these different pieces coming together. These are the Avengers coming together in order to ensure that we're fighting Thanos and moving towards modular alignment. And so what does that look like from a bridge endgame perspective? And so, like with anything with modular blockchains, we go modular, right? And so Across, we kind of pioneered this idea of what the endgame bridge looks like with their V3 announcement. And so with that is intents. We have kind of intents that are flowing through all these user intents and all this order flow that's happening off-chain. We have solvers, effectively these middlemen or middle organizations that are fulfilling these intents. They are off-chain agents that are able to bundle these intents together and actually form transactions to execute on-chain. And then we have settlement, right? And so settlement is basically a way in which these intents become a reality on various blockchains. And also the solvers are able to repay in order to continue executing intents for these users. And so what that looks like is that we're assembling the Avengers, right? From a modular bridge perspective, effectively we have all these different organizations that are effectively filling in these different pieces of the modular bridge stack. And so we have the permission layer, or said differently, we have the intents layer of all these organizations that are building off-chain intents and off-chain permissions. We have the solver layer, where Across also fits in, but effectively a way in which we can onboard more solvers and also decentralize more solvers, such that there are more of these off-chain agents that are able to participate in this endgame stack. And then lastly, we have the settlement layer as well, which is where Catalyst fits in, actually. It's a way in which solvers can be repaid, and then the actual transactions can be fit into the necessary blockchains. And so that's all great and dandy, right? Thinking about all of these different frameworks and all these different ways in which existing players are fit into it. But what does that mean when you actually take all these frameworks and push it towards the limit, push it towards what it looks like to scale to 1 million chains? And so what I'm going to do is I'm going to walk through kind of what a flow looks like of onboarding a new chain. And then what we can do is take that n=1 example and scale it to 1 million and see how much it can actually hold up. And so let's take the perspective of a new chain launching. Mind the analogy, it's basically like the Big Bang, right? It's an explosion, it's something that's created from nothing, and it's kind of the start of the new chain life cycle. But the issue about this is that there's no life, right? When you create a new chain, there's nothing really there, right? And that's kind of what we see as an issue with founders right now that are building new rollups and chains, is that they make it, they're really excited, they can use all these different modular frameworks like OP-Stack, like Arbitrum Orbit, but then what, right? It's kind of in its own planet, and there's not a lot of life really breathed into it. And so what they can do is effectively 2 options, right? The first option is injecting resources into the chain. And so what you can do is, if you are a new chain or you are a new rollup and you need to inject resources into it, this is where the modular bridge becomes really helpful, right? You can take the intent of onboarding these new assets into this new chain, and there's effectively these solvers that are able to bring these assets onto there, and it's kind of analogous to importing goods, right? And so in this picture, you can kind of see that there's 2 projects that are working towards this. There's Hyperlane and there's Stargate. And so what Hyperlane does is they have something called Warp Route, where you can effectively wrap assets on any chain and permissionlessly bring that to a new chain. So you can bring things like ETH and USDC if you want that to be injected into this new chain's economy. And the second thing is Stargate, which is conceptually similar, and so Stargate is a cross-chain AMM where you can effectively, wrap the assets that are in these different chains that Stargate is deployed on, like Optimism and Arbitrum, and you can bring it onto a new chain using their omni-chain standard that they call OFT. So again, this is analogous to effectively importing goods into a new planet. And so what if you're a new chain and you don't have necessarily the business relationships or the liquidity or the financial ability to actually import all these goods, right? It's not like people are doing this out of the goodness of their hearts. You have to, set up business deals in order to inject these chains. And so you can do something else, which we call basically forming a trade deal, right? And so if you're a chain, if you have something that's desirable, right? If you have a natural resource, for example, for a planet, but in this case, let's say you're a gaming chain and you have access to all these new users that are performing, that are pretty adjacent to crypto, that's something that's desirable for other chains and they want to access that, right? And so what you can do is effectively form a bilateral agreement in which you're working with those chains. And so that's effectively the mindset that Catalyst takes when we think about new chains. And so what Catalyst can do for these new chains is effectively form ways in which there is an equal kind of agreement of moving value between two different chains. And so let's say that this gaming chain has a native token, right? And this is something that powers the entire gaming economy. And that's something that another chain wants to get access to for their users, right? And so there's effectively an AMM that's spun up for the native token on the gaming chain, and then let's say for ETH or USDC or what have you on another chain, and they're able to actually perform cross-chain swaps together. And so the interesting about this is that it's actually an equal agreement of value transfer. And so at no point is there kind of an imbalance in which more value is being injected to one chain or another. It is two native asset pools they're able to swap against each other, right? And so that's really powerful for a chain that might not want to have a trade deficit, basically, right? There's equal exchange of value, which we think is really important and what we try to enable for these new chains. And so behind all this is basically solvers expediting the whole process, right? They're the kind of the space suits wearing spaceship crusaders that are able to actually transfer all this communication between all these chains as they coordinate their economies, as they inject or export different resources, right? And so that's kind of what it looks like on an n=1 example. And we can actually do this at scale, right? As we add more chains, we can inject more resources, or more chains can form different trade deals with one another. And so it really doesn't break. And so this is how modular bridges are really able to scale into the world of millions of chains that I think is about to happen really soon. And so with that, we achieve modular enlightenment, right? It's a way for us to ensure that all these millions of chains are connected to one another, feel like they're one chain, and abstract that experience using all of the permission projects that I was talking about in order to ensure that app developers and users are able to use them at scale without any sort of added complexity. And so that's all good and dandy, but even as we achieve modular alignment, there's a bit of a bottleneck that we need to address, and that's the solvers. And so, like I said, in this process of coordinating between millions of chains, we have solvers expediting the whole process. Unfortunately, and this is a research paper that I cited previously this week from the Li-Fi team, Arjun Chan, the researcher at Li-Fi, said that a few solvers win nearly all of the order flow, right? A significant percentage of auctions involve only one bidder. And so what that looks like is, even though we think of this huge ecosystem of solvers that are actually fulfilling these intents across all these different chains, it looks more like Wintermute doing it, right? And so it's not solvers expediting the process, it's Wintermute or other large market makers that have the financial resources in order to actually move these communication methods. And so with that, we kind of have a fork in the road where a second dystopia emerges, right? On the right-hand side, we still have Thanos, we still have modular chaos. That happens when we don't have strong interoperability primitives. But on the second hand, we have strong interoperability primitives, but they're ruled by our solver or overlords who are puppeteering everything. And so, is that worse than Thanos? Up for debate, but definitely something that I personally don't want, and that we're working really hard with Catalyst in order to ensure that that doesn't happen either. And so we need to break this hegemony. We need to find a way in which it becomes easier to be a solver such that it's not Wintermute that's coordinating all of the cross-chain activity in the future, but it's actually a decentralized open ecosystem of solvers that can do so. And so how we do that is going back to first principles, looking at the solver flow and looking where the bottlenecks are and seeing how we can help with that, right? And so these graphics are actually from the Everclear team, but I think they're incredibly helpful in showing what happens in the current solver state. But what we can basically see, well, not basically, but a bit complicated, I can say it at a high level, is that solvers need to have cross-chain inventory in order to enable solving to happen, right? And so on the left-hand side, you could see that users' intents are being fulfilled cross-chain, but it's actually the solver that is holding different assets on different chains in order to facilitate that, right? And so what needs to happen is that even though the user is moving funds to different chains, the solver needs to hold these assets on different chains and then eventually rebalance back to the origin chain based on the flow that they're seeing. And so you could see that this is quite arduous, requiring a lot of different chains that need to be managed, and of course, there's latency required to rebalancing. And so from a research paper that came out earlier this year by Chithra et al., you could see that it's actually really difficult to become a solver, right? You have multi-chain rebalancing, you have congestion costs, you have to pay more if different chains are more expensive, you have cost of source liquidity from centralized exchanges, and of course you have the always looming legal considerations, right? And so to quote Arjun again, but this time more simply, running an agent, a solver, is not easy. And so the question becomes, how do we make it easier? And so the solution that the Everclear team is talking about is lowering the barrier by netting. And so instead of having all this rebalancing happen on chain and happen, n number of times that becomes quite inefficient at scale, they basically have a netting method in order to streamline that, right? Is there a way in which solvers can be repaid using the net balances of another solver? And this is conceptually really similar to what TransferWise does for cross-border remittances. And so that's a way in which we can streamline the inventory needed from solvers. The second approach that Catalyst takes is, let's not do netting. Let's just ensure that there's a way in which solvers can always access assets on different chains such that there's no arduous need to rebalance between chains, right? And so our hope is that solvers don't need to hold cross-chain inventory because there's an underlying liquidity layer that they can always access assets towards. And so if they're moving assets from Ethereum to various L2s or from Ethereum to the Cosmos space, is there a way such that solvers can always just access the assets on the solver on the destination chain, such that they don't need to hold cross-chain inventory? And if that doesn't make sense, I'm sorry, I'm abstracting away a lot of details. Feel free to ask me after the talk, and I'm happy to explain that more in detail. But basically, what I'm trying to say is there are various ways that we're thinking about ensuring that we go down the path of modular alignment. There are various ways that we think about breaking down the barriers to become a solver such that we're not beholden to Wintermute and the other solver overlords. And that's the beauty of crypto, is that we're all building towards the same thing. We all want to achieve modular alignment. And in the interoperability space, there are a number of teams like Catalyst, like Everclear, like Across, Hyperlane, Li-Fi, and Stargate, and a bunch of our logos that I didn't add because they didn't fit into this Avengers picture that I found on the internet, that are working towards this. And as a result, it becomes a beautiful canvas of perfection. And so that's the beauty of working in crypto and in interoperability. Thank you, guys.
All right. Next up on this chain abstraction tack is Arjun from Everclear. We heard a little bit about Everclear from Jim's talk, and now we'll go deeper.
Thanks so much, Saki. And yeah, thanks, Jim, for the plug there. I really appreciate it. I'm Arjun. I'm one of the founders of Everclear. We were previously known as Connext. Everclear is what we call the first clearing layer. Over the course of this talk, I'll be kind of explaining what that is and how it fits into the modular space. So, fragmentation. Fragmentation is the big, scary boogeyman for modular today. And it makes sense, right? Like over the course of history, we've just seen like this acceleration of TVL moving to other chains aside from Ethereum, except for that kind of minor blip over there in 2022, which was Terra, RIP. And this problem isn't really getting any better. There are 61 Ethereum-based rollups live today. That kind of blew my mind, by the way. I had no idea that number had already gotten so high. And then there's 79 on the way, according to L2Beat. But I actually went and I talked to a bunch of like roll-up as a service projects and a few other ecosystems. That number is way, way higher. There are multiple roll-up as a service projects claiming to have hundreds in the pipeline by the end of the year, which is kind of insane, right? Like, we are really, really accelerating modular expansion. And of course, that means that this fragmentation problem is about to get so much worse for this entire ecosystem. So, what do? Last year, Connext started talking about this idea of chain abstraction, and it's something that's been kind of really picked up by the broader community, which we're really, really excited about. Chain abstraction is this vision for the future where users never really need to care what chain they're on. And from our viewpoint, we think that we can achieve this using a technology called intents. Intents have obviously been a super hot topic at ETHCC, so I won't dive into them once again, but a really, really awesome breakdown of how intents work is to look at this really fantastic diagram that was built by one of the most popular intent protocols out there today, Uber. So when you use Uber, you're effectively expressing your desire to get from point A to point B, and Uber fulfills that desire. And you kind of see this mirrored in the way that like chain abstraction works, right? You have at the very kind of top of the stack, you have your permissioning layer. Oop, that's not the laser. You have your permissioning layer. This is where you kind of tell Uber, hey, I need to get to ETHCC on time. And then Uber auctions that off, that intent off, to find you a driver that can get you there. It quotes you 5 minutes, though of course because it's Brussels, that is actually 25 minutes. Then you finally get a driver that takes you to ETHCC, and then at the end of your ride, you settle with the driver, which means you pay them. This flow obviously makes a lot of sense, right? It has analogies both in all over Web 2 and TradFi and in this space. It makes sense to kind of separate out actions that you're doing on chain and delegate that complexity to third parties that can specialize in doing that for you on your behalf. But there are challenges. Jim started to touch on this, which I really, this really, really big challenge, which I think everybody's starting to think about today, which is solving for chain abstraction, solving for intent protocols is just a really, really highly centralized activity today. And until we can fix this, you kind of have this paradigm, where if you are a solver with a large amount of inventory and sophisticated actor like Wintermute, you are really making the vast majority of volume revenue in the space. And then if you're an individual solver, you are unfortunately all the way out here. Until we fix this, we really can't scale solving, right? This should be a straight line. Your returns should scale proportional to the amount of liquidity that you have, not multiplicatively proportional to the amount of liquidity you have. So a couple of years ago, we started to encounter this problem, and we encountered it because we were building an intent-based bridge, working with a bunch of solvers, though we didn't really call them solvers at the time, that were largely passive actors. They were like staking service providers, and those staking service providers, despite having lots and lots of liquidity in the system, were not actually routing transfers. So when we dug into why, we realized that there's this weird paradigm that exists today, right? Like we kind of talked about the first couple of steps of the intent. So user says they want to do something on Arbitrum, solver goes and fulfills that request on Arbitrum instantly, right? So from the user perspective, this is a fantastic experience. But it's what comes afterwards that is still unsolved. Really the third step, which is how do you do settlement? And most importantly, when you do settlement, solvers go and unlock funds on the source chain. And so this creates a need for solvers to rebalance. Rebalancing is actually one of the most challenging parts of solving today. This is like inventory management is kind of what this is called in like financial or market making terms. And solvers don't want to be market makers, right? Only if you make solvers market makers, then the only people that can be good solvers are market makers. And the reality is, like, every single solver has to deal with this today. Every single solver has to spend lots and lots of time and energy building an operational team and paying money to go and bridge their funds back to where it needs to go in order to be able to continue solving transactions. We went and we talked to a bunch of solvers in the space about this, and the solvers said, hey, we're actually going to, we use these bridges to rebalance, and we use market makers to rebalance. And we went and we talked to the market makers, and the market makers said, oh yeah, we use like centralized exchanges or canonical bridges to rebalance. And we went and we talked to centralized exchanges, and they said, oh yeah, we're hiring a team of 20 people that just go hit the button on the Arbitrum bridge. And they just do this all the time, right? Everybody is dealing with this problem. It's just not going away. It's a fundamental issue with the fact that we live in a world where it just takes time to get between chains, right? The minting rights of these bridges are consolidated in these extremely, extremely secure bridges, relatively speaking, which is fantastic, but they take a long time. So how can we fix this? A really interesting breakthrough for us came when we realized that 80% of the volume that actually moves between chains today is nettable. What this basically means is that for every, I guess for Binance Chain, for instance, right, for every $1 that you send into Binance Chain per day, 85 cents moves out. So this kind of brings up an interesting question, which is, why are we sending 85 cents into, or $1 into Binance Chain to begin with? Why not just send 15 cents? This insight is at the core of what we call netting. Netting is something that is quite established in like traditional financial systems, where you take a bunch of obligations that people have, financial obligations people have to each other, and reduce them down to one kind of final sum obligation. So for those of you that are from North America and use Splitwise, the Splitwise is effectively a netting application, right? You pay your friends when you go on a trip. You kind of like have IOUs to your friends because they're fronting to buy plane tickets or to pay for food or whatever. And rather than having to pay each other each time and spending additional money to actually do that, you can just register your obligations in Splitwise, and then Splitwise at the end of your trip gives you a final amount of funds that you actually need to sell. So you're basically turning $420 worth of transactions, by the way, not at all intentional, down to $10 worth of finals, like just a final $10 transfer. To harness this insight, we want to introduce this concept of clearing to the space, and really Everclear as the first clearing layer. Everclear is a system that negotiates the relationship, basically negotiates the global funds, movement of funds between different bridges that are moving funds between chains. So for example, if I have funds on Polygon, I'm a solver and I have funds on Polygon because I've just filled a transaction going from Polygon to somewhere else, and Jim is a solver on Arbitrum who has filled a transaction going from Arbitrum to somewhere else. But we actually want to end up in, like I want to end up with funds on Arbitrum and Jim wants to end up with funds on Polygon. Instead of both of us having to bridge, we can just atomic swap with one another, right? This is a coincidence of wants, effectively like a cow swap. And instead of creating yet another system, yet another bridge, which has liquidity within it, we can create this different sort of system that actually allows bridges to negotiate with one another. It sort of removes this like perennial trap we've been stuck in, where we continue to build new bridging standards, we continue to put liquidity into further and further into new systems, which just fragments things more and more instead of making things better. How does this work in practice? Well, Everclear is a rollup. It's actually a fairly straightforward system. Different users of the system, so this would be solvers, market makers, centralized exchanges, deposit funds into Everclear and register their desire to kind of rebalance to another chain. The system basically purchases those deposits effectively and issues invoices, which are like IOUs from the protocol back to the user, and then it auctions off those invoices against available liquidity. It will decrement, the kind of notional price of an invoice if there is no available liquidity. So there's always like an incentive for someone to come and arbitrage it. Everclear sits at the bottom of the chain abstraction stack that we talked about earlier, right? It's powering this seamless liquidity backbone for solvers that are then able to go and continue participating in auctions much more efficiently than they could otherwise, right? They're basically cutting out 80+% of their cost bases because they're not having to go and continuously rebalance. And instead, they are able to get their funds back to where they need to be faster so that they can continue solving transactions, right? It's like, as an Uber analogy, this allows for an Uber that's driving from here to the airport to go and pick up somebody at the airport and come back, rather than having to come to drive all the way back to Brussels to get another ride. And this also allows us to scale out the number of Ubers, right? The more people are able to solve in a way that's very, very cheap and cost effective, the more people can just be independent solvers, right? The kind of goal here with the combination of Everclear and other kind of infrastructure like Catalyst and Kalani and other solver infrastructure that is simplifying the process of being a solver, we can ideally get to a point where we have achieved this like outcome that we need to achieve, where we move from from the monolithic stack over to modular, and then move from modular over to abstracted. And where abstracted here means a stack where users just never know that they're on multiple chains. We think that this is maybe one of the most important sort of technological transitions that crypto has ever faced, where we can work towards this outcome where you have scalability solved by modular, and then this front end of abstraction that is solved by the chain abstraction stack, or as it's referred to in academic terms, the modular mullet. For the past 10 years, just about, the space has been thinking really, really deeply about how do we actually scale out blockchains? How do we get to the point where every single chain every single application is able to build in a way where it's unfettered by the kind of usage of other applications, where you can build truly like billion user scale applications, right? Where you could build an actual Uber on a blockchain. And every single time we've sort of hit the same bottlenecks, which are limitations around how the trade-off space around scalability versus security. With this transition, we think that we're actually finally in the place where we can solve this problem. And I think that that's how we get to this next step. I have personally been very, very interested in getting to a point in the space where I can move beyond just building infrastructure and go towards building some of the things that we've talked about that really, really change the world, right? Like coordination platforms that allow us to work on rebuilding the incentives around climate, mutual credit systems, peer-to-peer lending and insurance programs, right? These can be fundamental internet native public goods that can scale to every single user. And we're close. We're actually now finally, for the first time, very, very close. This is, in a nutshell, what Everclear is doing. We are trying to build, we're trying to kind of accelerate this outcome, where we can get to the point where every user can build in a way, every user can use any application regardless of what chain it's on. If you're interested in building that, or if you're interested in this outcome, definitely come and talk to us. We want to talk to everybody that is building in this space. So, thank you so much. Do I have time for questions? Do I have time for questions? Awesome. Any questions? Even if you don't have questions about Everclear, I just want to talk to you. It's stressful. I got rugged by Uber this morning, so I got to the event like approximately 3 minutes before the talk started, which is why, earlier in this slide deck, I had a lot of shade about Uber. I really regret using them as my canonical like intent-based example. Now I should have switched to something else. Maybe Lime? Not really the same. You're your own solver in Lime. Well, awesome. Thank you, everybody, for listening to my talk.
Hello. Awesome. All right. We have a set of illustrious panelists doing the chain abstraction panel. We will learn more about chain abstraction. I won't bother to introduce everyone. I think we'll do that during the panel. Thanks.
Yeah. Water. Thank you very much. This is the panel. This is the layers. Okay.
Is it on? Cool. Good morning, everyone. Appreciate everyone coming out Saturday morning here. I know it's been a long week, mostly for everyone. I'm Yuri from Signature Ventures, and guys, I have with me the Fabulous Five. And guys, you could just introduce yourself quickly and also your company.
Hi, my name is Stan. I'm from Inisha. I'm currently one of the co-founders. And what we're trying to do at Inisha is trying to re-envision the roll-up world and how multiple applications on each roll-up interact with each other and the general user experience. Yeah, I guess I'll keep that simple.
Hi, I'm Rishabh. I'm one of the founders of Socket. We're the first chain abstraction protocol. What we're really building is, as this fragmentation kind of like emerges in the stack with so many chains and applications and tokens spread across chains, instead of a user caring about 500 different variables like RPCs and gas tokens and whatnot, we want to kind of like provide this way for users to interact with all of these chains in like a global block space point of view, where they just care about 2 or 3 things that they care about the most, like speed or cost, and everything else is abstracted away from them. And we use like this mechanism called MOFA to achieve that.
Hi everyone, I'm Marco. I've been running marketing for Leafy for 2.5 years, now running Jumper on the B2C side. In short, Leafy has been doing chain abstraction since 3 years ago by aggregating all of liquidity in DeFi, and super happy to now move it to the next step with Socket.
Good morning, everyone. I'm Karel, founder of Union. We do zero-knowledge interoperability. Our testnet recently went live. We passed about 90,000 users and almost 400,000 transfers on our public testnet.
Wow. Good morning. Thank you for coming. If it were me, I would be sleeping if I were you, so I'm very impressed. You have more fortitude than I do. As you can tell by the hairstyle, I'm very underqualified for this panel because I don't have a modular mullet. I also I feel like to be modular, they have to be multicolored, so I'm not really buying this yet, but we'll see. Yeah, did I say? My name is Christopher, and I work on Anoma.
Perfect. Maybe take a minute or so to define a little bit what chain abstraction actually is, because if you take it literally, if you abstract away the chains for the users to be everything more easy, any centralized exchange can be a chain abstraction, right? So from your point of view, what is basically chain abstraction for you, especially from the point of view of your company potentially?
Sure, so I think there's 2 things to really consider when you're looking at chain abstraction. One is, I guess, like the end users, the actual users who use the application itself that you're trying to build, the people you're trying to, try the application. And the second is the users, or like the developers who actually make those applications, right? So what are their experiences like? How difficult is it for them to attract liquidity? How difficult is it to actually build on the chain or whatever infrastructure that you've made? And so when you're looking at chain abstraction, I think there's like 2 categories to consider. The first is like the user experience, and that kind of, can be split furthermore into 2 categories. It's like the infrastructure itself, how interoperable is the infrastructure, how easy it is to be able to allow different application developers to build on top of that. And then the second is like the UI UX. Like how do you envision a multi-chain world or like a very modular world? I think like when you look at a modular world, everything is like split into different parts, and you kind of optimize along each vertical or each horizontal in the stack itself. And so that makes everything, let's say, 100 times more complicated, more difficult. And so how do you kind of retie those pieces together and make it really easy to use? And I think like chain abstraction is one of those things that is very complicated and kind of wide, but really just touches, the end user experience, whether it's the developer or the user itself.
Yeah, I think going back to my intro point, right? I think today there's like too many variables that a user needs to care about. The user almost needs to be a scientist to be able to interact on chain, right? Like, if just a small example, right? A user who needs to swap from one chain to another, they need to care about two gas tokens, two RPCs. The cost is gas cost of like one chain, and then the bridging cost, and then the gas cost on another chain, and then the swapping cost. These are like, and then like latency also is finality of one chain, finality of the other chain, bridging, and so on and so forth, right? So the number of variables basically are exponentially increasing, or the number of variables that users needs to care about are exponentially increasing as the number of chains increase, right? So chain abstraction is not about, it's still about like having all of these fundamental rights for the users to interact with on-chain, but without having to care about so many variables, right? Like they should just care about what are the one or two or three most important things to them, which might be different for different users, but they don't have to interact with on-chain, interact on-chain directly and see these variables in action and just care about what's really important to them.
Yeah, I mean, I think in short term, everything is UX based. I think one of the best examples from what we need to do is just move what we're doing into Web 2 level of usability. When you use internet, whatever, you don't need to know that there's like satellites and cables and how shit works in the back end or in behind. And our industry needs to get there, and chain abstraction allows that to happen. I think just in short term, it's going to be purely UX fixing, not like bridging chains. Everything's going to happen in the back end still, right? We're not going to abstract that part away, but fixing the UX for users to actually make it simple for a boomer to come in and use an app, not a chain, is the chain abstraction.
So I feel at least that just delegating like chain abstraction to being good UX is kind of the most lame answer, just because I feel like in the UX side you can already do a lot of stuff, and we've been doing that for the last 5 years, right? Like we can try to hide away a lot for our users. The problem is when you hide away a lot for the end user, they lose a certain competitive edge compared to others, and obviously they start having worse trade execution, etc. Right? So actually, if we give them all of the knobs to see what fees they're paying, what protocols they're using, that's what gets them good prices as well, or early access to ICOs, or early access to pools. And so I think with chain abstraction, like if you just focus on making it simple for your grandfather to use, do you really build a good DeFi product? Not really sure.
Yeah, but there should be both, because with the fees, with the issues, that's what puts people away, right? And so,
but we've had those UIs before already. Like they've existed. Like there has never been like an issue where we couldn't write like a new front end in React where we just compress all of those numbers into once or do some simple calculations for the end user. I think the real issue at some point with all of this chain abstraction is that actually for developers building all of these UIs, it turns out that it becomes very hard to port them across different chains. And that those semantics are completely different, even though every single chain exports approximately the same functionality, right? Like if at a very high level we look at what apps we're building, it's always swaps, it's always lending, it's always staking, right? Like the core functionalities are the same, but then for move-based chains, for SVM-based stuff, it's then completely different and semantically very strange to operate with. So for me at least, chain abstraction starts actually at the backend itself, and realizing that perhaps we want to indeed only export those core functionalities to the end user, right, and give them all of the knobs necessary to interact with those core functionalities without needing to know necessarily about the underlying backend chain. But that's still perhaps a complex UX, because in the end, like, finance is complex.
Yeah, like just adding on to this point, right? The true reality is that fragmentation on-chain, like the on-chain fragmentation will always exist, right? Like there will always be 100 chains. It will always be complex to kind of like navigate this, but like how do you kind of like give these users these knobs in like such a way that is like understandable to them, right? So it starts with the backend, but it also kind of like is at an intersection of like the front end and back end in some sense, where these knobs basically are like the front end sort of things, and then like at the back end, there are these actors that really kind of like are, let's say, performing all these actions in a complicated way.
Yeah, and I think one thing is in crypto, if you actually look at a lot of the dApps on Ethereum and Solana, most are forked. some React starter template by Uniswap, right? And so actually the power of having some sort of default across the industry is like very strong, because in the end, like the early standard that you set then happens to be used by everyone, right? Like every single swap page looks exactly the same, right? It also has little rounded corners, it has the same buttons, same inputs, and that's because everyone forks the Uniswap UI. And so I think for chain abstraction itself, that's why you have to start at the back end and kind of at the root foundation, because then it propagates everywhere else later on.
Chris?
Well, as I said, I was underqualified for this panel, so I have a confession to make. I don't know what chain abstraction is exactly. I mean, interpreting it literally, blockchain's a data structure, a linked list of blocks, and that's already an abstract data structure. So it seems like chain abstraction's kind of a tautology. You know, in social practice, it seems like what people mean is something like these blockchains, like these actual instances of things that exist in the world and produce blocks and store data. There are too many of them, and like users don't care, and they want to do something with their application, so maybe we should like abstract that in some way. Now, to me, a central question when you're trying to abstract something is, what are you trying to abstract, and what are the essential properties that you want to capture in the abstraction, as opposed to like the properties you don't care about. Now, as we see them today, blockchains typically couple two services. They couple the service of ordering transactions, and they couple the service of storing data. And sometimes they store that data forever, at least by default. If you write to Ethereum storage, that's the assumption. Sometimes that they store that data only for a little while, so-called data availability. If you write to blob storage or you write to Celestia, that's the assumption, right? So to me, it seems like there's sort of two distinct services here that we could potentially abstract. And users might want them in different ways for different purposes. The other question which comes to mind, to your point on, well, just good UX is not enough, is that I think we might want to think about what it is that users want to do and how to ensure that some of what they want, maybe their intent, is somehow translated through this network of like peer-to-peer nonsense, and that whatever ultimately happens, they have some way to measure it and create some feedback process where, you know, if some solver or some place they're sending, they're like very abstract intent or kind of less specific specification of preferences, even if it's not formally an intent. Users need some way to measure, is the system ultimately satisfying this in a way that they are happy with or not? So I think those two aspects, separating out what kinds of promises for different services are being offered and figuring out how to create feedback mechanisms so that users can you know, interact with the systems in a way that is in their best interest in the long run, are the aspects that are interesting to me.
Cool. I think everybody mentioned at least users once. And if we take visually this cake framework, right? If you don't know what the cake framework is, just Google it from Frontier Research. And there are all these elements on these 3 layers, right? And on top of all that is applications. So if we take it for granted, those things are all built now, right? All these layers are built now. How would an application look like in this framework? Is it just a front end with a prompt, or is it always a financial application then? How would you imagine the application to be? How would you imagine the user to want, actually? So for whom you're building something?
How would I imagine an application to be? Right, that's a good question. I think to touch upon my previous answer a little bit, what you want to capture in abstraction, you want to capture the right things. You don't want to abstract everything. Like if it's just send my you know, transaction to a blockchain, you know, send it to one of them. This is about as specific as like send my packet to a computer, like one of them. You know, we don't use the internet like that. When we use the internet, we specify, say, the IP address to which we want a packet to go. What we don't specify is exactly how to get the packet there. The internet doesn't do pre-routing. It does like just-in-time or on-demand routing. When we're talking about blockchains, again, there are kind of 2 services which I think we need to differentiate here, ordering and storage. And ordering really has, these 2 services are different in part because the user will care about different things. When you care about ordering, you care about mostly that like these validators aren't going to double sign, maybe you care that they have enough economic security. You also care a lot about what other intents or transactions are also being ordered in the same block, because maybe you want some kind of composability, even atomic composability with other intents and other assets. Whereas when you're talking about storage, you care about, you know, it depends a little bit, maybe with optimistic rollups or something. There are different models, but typically you care about data being retrievable in the future and data being retrievable efficiently in the future. You don't want to store it in a super expensive place if you only need to retrieve it every so often. So it seems to me like from the perspective of an application, we should build abstractions that allow application developers to reason about who they need to trust to do the ordering and what assumptions they're making and what kind of storage services they're buying, but not to reason about any of the internal implementation details of those things. Developers should be able to reason about what promises are being made and a little bit about kind of how those promises would be enforced, but not needing to know, for example, maybe the internal details of how, I don't know, validators are sending data around to each other on the network. That's not a relevant criterion.
I'm going to put my dev brain on with this question. I think if you look at a lot of the UIs right now, especially on the Ethereum side, then the UI will almost exactly resemble the smart contract. And for like every button that you're clicking, there's usually a one-on-one function that's being called. And the downside of this is that usually this is not actually a good mental model for how you should model the financial application itself, like the smart contract. And this leads to pretty high gas utilization because you cannot really batch user transactions together. Usually users need to submit multiple interactions with the protocol. For example, you do separate approve and then the actual interaction. And so overall, we lose a lot of money on gas by modeling our applications this way. And we have a very one-on-one connection between the UI and the smart contract, which means that it becomes harder to kind of aggregate them. And this is where I think actually originally kind of the chain abstraction / intent stream came from, this idea of how about we have sort of a layer in between here that's maybe a bit more machine friendly, more backend oriented, where we think more about batching, gas optimization, where we realize, hey, these apps are all the same, and then the front ends actually go against this shared interface. And that way, at least, like we have a lot more straightforward applications for the backend developers. And overall, that's also this move for Ethereum to become more of a settlement layer. Then you really get this separation of, hey, smart contracts really are not intended for end users to interact with directly, and apps themselves really provide like a 360 experience for the user with this platonic abstract world.
I realize also in our answers that maybe we should answer a more basic question, which is what is an application?
So for me, an application is always like kind of a single smart contract with state that might manage some funds or users or whatever, and that can have like a UI associated with it. But since we're all in blockchain Web3, for me an application has to kind of live on a chain or be its own chain, like its own state machine. I think for you it could be much bigger or smaller as well.
So if I have a Uniswap contract on Ethereum and a Uniswap contract on Optimism, would you consider those the same application or different ones?
I would say that's quite hard right now, because if they could independently work, then we'll consider them just two separate applications that interact with each other.
Fair.
I mean, UX might be a weak answer, but the problem is we're building a lot of cool infra and not inviting new users into the market. So we're basically circle jerking each other with super cool infra being built. And so you asked about the financial stuff. So this is one of the first things that's actually going to invite people. People want to make money, people want to know about finance, but it's really actually hard to get into it properly and make money in it, right? And so with intents, with chain abstraction, and especially AI agents later on, like shared keys and stuff like that, we're going to be able to have applications that learn based on your behavior, give you recommendations, execute for you basically, and make it super simple for you to interact with stuff without you knowing basically what you're interacting with. You want to see a product, and you want to see how much money you're going to make, and you want to see, how much money you're going to save maybe by something. So from a financial perspective, there's a lot of verticals where that could be super helpful. From suggestions perspective, or just actually executing on your money, right? But this is something that can invite new people. Building more dev tools, building more, I don't know, intent-based protocols, whatever. We're there. We have good tech that we can join together and create good dApps. We don't have good dApps. And second thing, maybe a hot take, but at least from my circle of people, everybody, Coinbase Wallet is maybe a good example of like a first chain abstracted wallet, or at least a balance abstracted wallet, right? You try it, you're like, oh, this is cool. And you go back to Rabby or MetaMask. Because for us that are in the industry, it's simple. Crypto UX doesn't suck, right? And so we need to invite new people in it, because we're not going to use like these new models that easy.
So do we assume then at least financially educated users in the first place?
Sorry?
Do we assume that all the users will be, or at least the first users will be financially educated people because they want to make money, they know at least some sort of...
Well, maybe not financially educated, but want to be, right?
I think right now we have financially educated users, right? I think like no one can be more educated in some sense than what we have today. And now we only need to kind of decrease the bar of education needed to kind of like interact with things on chain, right? And I really agree with like what Chris mentioned, where like we need to think about what is the right kind of or what right level of abstractions, right? There are, like I said, there are 500 variables that users need to care about. What are the 2 or 3 most important variables, right? And these variables might be different. The important variables might be different for different users, right? I might not care about security as much as, like you do, right? And I might care more about cost, but someone else might care more about the speed, for example, right? So at an application level, like, or like whoever is building a protocol application, they kind of like need to think about what are the things that I really want to optimize for the most and really have that on chain, right? And going back to the Coinbase smart wallet, right? Like I think the smart wallet right now, especially with Magic Spend, is one very good example of this, right? Where they just allow you to interact on-chain with base applications with your balance on Coinbase exchange, right? Like in some world you can consider, to your first question, that as a chain, right? But users don't really need to know about base or anything, right? Like they just need to know, yeah, I can earn, like a higher yield on something called Aave. So let me just use my Coinbase exchange balance to earn yield, right? And that's all they should care about from Coinbase point of view.
Yeah, I guess specifically, I think when we're talking about financial applications, all the users, or whichever these imaginary users are, have different levels of knowledge of finance or whatever domain-specific knowledge, right? Like I come from a trading background. I don't expect somebody who doesn't know how markets work or that has no experience to trade to know how to deal with these complex products, right? But I think the interesting thing about Web3 is that you are exposed to these things, right? There's like volatility products, different types of swaps, different types of very interesting stuff that are made by people who are presumably, hopefully, familiar with what they're doing. But that doesn't mean like the end user actually understands what they're touching, right? A lot of times you just see a really high APY. You're just like, okay, let's put some money in and let's see how it goes. And so I think like you shouldn't expect all users to be the same and to have the same level of knowledge. And so as Chris kind of mentioned, when you're trying to abstract different things, like what are really their needs, right? Like who are you really trying to target? Maybe it's institutions, maybe it's like the end user. In some of these lending markets, as an example, like do you really want the average retail user to be lending in something that's potentially risky? And maybe that is something you want, maybe that's not something you want, but those are things you kind of have to consider when you kind of look into chain abstraction. I guess like on the developer side of things, like same thing as well, right? Different levels of developers, front end, back end, whatever developers. You want to have different types of tooling, whether it's like SDKs, APIs, things like that, to really kind of fit your solution to their needs, right? Like maybe your front-end developer doesn't really need to understand the underlying smart contracting language, or maybe they are a smart contract engineer, but they don't understand a different language, right? Maybe you're familiar with Solidity or whatever versus Move. And so when you're kind of like building these applications and doing this so-called chain abstraction, yeah, there's like a need for a segregation of the type of user that you're targeting.
So it feels, at least to me, it feels like we do assume some sort of finance in the application so far right now, right? Does that mean that there is still work to be done? We're right now abstracting infrastructure level stuff away. There is still a need in the future to abstract the financial part away, maybe on the application level, or is our intents, for example, might take care of that because they just can interpret human language and then transform it into financial language and then move it all down?
Yeah, so I actually disagree that most of this is finance. I think a lot of it will be finance, and I think the majority will be finance because, like, just in general, the frameworks really fit well for these types of products. But that doesn't necessarily mean, like, most of this will be finance in the future. Like, a simple example is like you have a game, right? I don't know, maybe you play MapleStory or RuneScape or like whatever other game, and you want to pay somebody or have like an intent for somebody to do something every 6 hours, right? Like that's not necessarily financially related. I mean, you could pay for a service, but I wouldn't argue that's like, like traditional finance in any sense. And so like some of this stuff I do think can be solved with intents, right? Like you kind of say like, I want somebody to chop my tree every 6 hours or farm my plants every 6 hours or something like that. And that's like something that I do think if you have an on-chain game or like some game that can be connected on-chain, is something that can be solved with some of this new type of infrastructure that was originally meant for finance.
Chris, you want to say something?
Intense for RuneScape, grinding, I love it. I mean, you asked about intense in natural language and kind of how users will give inputs to these systems. And I think we can find a lot of inspiration by just looking at what exists in the world today, even in sort of Web 2 or in, a typical example of an application where you have a clear intent is something like Uber or Bolt booking a car where you want to get from A to B. That's a constraint. You have some preferences about getting a car quickly and perhaps at a lowest price as possible, given enough trust in the driver or something like this. And I think that the interface offered there is not natural language. Like it could be, like Uber could offer you a bot that you chat with to book your car. They don't because it helps to have a visual map. So I don't think that everything will switch. I think some things, to me, it's important to segment like. It's one thing to try and train a large language model or something like this to convert natural language descriptions into precise, data structures, mathematical descriptions of an intent. That seems to me like it's something that's very useful. You can display a visual confirmation to the user of exactly what's going to go on. Expressing an intent in natural language that you actually send to the distributed system and try to match using natural language, this is a very different and very interesting, but like that's a research problem, I would say, because verifying that intent was matched correctly turns into a problem not of syntax, but of semantics. It actually turns into something like the Oracle problem, like do we agree on the state of the world? I think that's an interesting research direction, but probably not something to be productized anytime super soon. I think I don't come from a financial background. To me, part of the interesting effect of crypto has been to maybe at least catalyze some reinvestigation into the question of what is finance. To me, the boundaries are a little unclear. Is Uber a financial application, for example? Well, there are financial transactions going on. They ended up also giving out loans, but maybe that's just weird, like capital market structure stuff. So I think it's a little bit tricky to draw the boundary. And also certain communities probably will want to limit the degree of financial interoperability in their systems. An example of this is RuneScape. If everyone in RuneScape just uses farmers, somehow it kind of loses, like the game loses its purpose, I mean, it may be dull and boring and kind of terrible to spend 6 hours clicking your axe and clicking the tree. But at least when I played the game, somehow this created a certain kind of camaraderie, like, shared sacrifice, shared hazing by the dumb rules of RuneScape tree farming was part of what made the game like a place that people wanted to hang out. And if all of that just becomes financially interoperable and you can buy it, then it's not like it loses its separation as a space. I think now it's just someone with a lot of money can buy a RuneScape account, and I don't know if people would want to play anymore. So I think there's some interesting questions about that.
I actually like this game as an example here too, because if you chop trees every 6 hours, for example, you're not doing it because you love to chop trees. You do it because you maybe exchange it for something else, another resource to build something more, right? So in the end, there's a marketing behind it, and there's again finance. So might it be that this application layer in social chain abstraction is just a translation layer from normal people doing something, and then translates to financial means, and then it all goes down basically to blockchain? Is that a way to think about applications?
I think in a lot of these cases, that is true, right? Like maybe you want to sell these logs that you chop to some place called the Grand Exchange maybe, or something like that. But in some other cases, maybe you just want somebody to like move your assets somewhere, right? Or like maybe move your NFT somewhere. Or maybe like, as we, I guess like some of these panelists kind of mentioned already, like I have an NFT on one chain or like one application, and then there's another application, but I'm not really sure how to like move this asset myself, right? So maybe you just specify like, I want it to be moved to this stage, to a different place, or like this application in the cheapest way possible, or like maybe the fastest place possible, or like some combination of those two, and then you just submit that intent. So I don't think that it necessarily has to be financial. You could say like, NFTs have some sort of value, you're moving a financial asset, but I think like that probably is like a little bit too pedantic in some sense, and I think like the average user is just like, I just want to move it to this application to do something with it.
I think any application that has in-app purchases, or to be honest, any transfers of assets internally is a financial application in the end. And if we look at applications, a lot of them do. Trading coupons, for example, you might think that's something cute that your mom does, but then Raise.com, I think, makes 500 million a year of multiple billion-dollar markets of people trading coupons on the app internally. And then the question becomes, do you believe that these apps become better if they're open financial markets or if they're closed financial markets? Obviously, they have some type of internal order flow going on. Coupons are being traded back and forth. Do they give that order flow to Citadel? And does Citadel start arbing coupons and make hundreds of millions of that? Or is this something that you settle on-chain, allow anyone to have access to? And that's why I think overall, like, especially GameFi too, is if you look at a lot of games, they are indeed financial applications. There's so much trading going on, so much order flow, so much potential value, that the question is, do we have the game companies keep that themselves, or do we open that up to everyone out there? I don't think in the end users interested with actually interacting with this, like they actually don't want to really know that they're gambling on a financial app, but does the app become cheaper for them if it's opened up to any trader out there? And that, at least for me as a libertarian, I do believe that if you make it an open market, it becomes more efficient for the end user.
I think like open markets are very interesting, and I think in general having higher competition is good for the end user itself. I just like question whether, like, for example, large, somebody who makes something that's worth something or has an IP, for example, let's say Starbucks, right? They had a partnership with a chain, and so for example, like every time you buy a drink, you get an NFT or some sort of thing on chain. I think like that is leaking a lot of value from the perspective of Starbucks, and that's why I think like these partnerships don't work out, is because like you have all this data about these users, and do you really want to make this like publicly available to all your other potential competitors, right? Like for example, if I start issuing, instead of those like frequencies that you collect on Starbucks, and you start making them on chain, like you can get civiled, right? Or like you can get sorry, not civil, you can get like vampire attacked, right? Because I could be another franchise or another coffee chain or whatever, and be like, if you have one of these NFTs, like you get a free drink from me, right? And that's probably something you don't want. And so I think like there are certain applications where you don't want to share that. Like as the person who develops the application. As the end user, it's very good, right? You get a free drink. But yeah, I think those are just some like application choices that like the teams that make these applications have to make.
At a high level, like there are like two types of, like, just to summarize maybe, right? Like there are two types of use cases, right? Like financial is like everything quantifiable, I would say, right? Like money or like funds are quantifiable. So whenever there's like something quantifiable, you have like parameters which are quantifiable, like cost, for example, right? Like becomes a very direct component. And then on the other hand, games, or let's say Farcaster, right? It's again like another example of like a very nice chain abstracted sort of an application for me, where, okay, yeah, we have to set up a wallet and everything to onboard, but like once you have that, there's no difference to use like Farcaster versus Twitter, right? And then like you can then start embedding these on-chain, these financial primitives or these financial interactions on top of it, which is where things will become more interesting on like what does that look like. But it still starts with like this non-financial, completely abstracted sort of an experience where users do not even need to know that there's some chains exist under the hood, but they still can farm airdrops.
Sounds good. So if we just switch a little bit to how much for an application developer, how might the tech stack look like? So we already see with solvers, for example, we have a tendency to centralization because only a few solvers are basically taking most of the order flow. Do we expect that on the, let's say, the permission and also the settlement layer, and at some point having just like a standard vertical tech stack and that's it, and that's what the app developer uses then? Or do we actually have some modularity kept there and can keep it more modular, right, in that sense?
Yeah, no, I think like when we talk about solvers, I think like while like centralization is like one thing that people have started talking about, I think like the real reason why solvers or any off-chain entities are introduced in like this transaction lifecycle is for efficiency gains, right? So the right parameter to kind of like talk about these off-chain agents, in my view, is like efficiency gains, while ensuring that they don't have this capability or mitigating this capability for them to kind of like misuse any kind of like potential, let's say, monopolistic centralized powers or whatever, right? So for example, the most simplest way, and like this is something that people talk about a lot, is like while you're kind of like firing, let's say, a swap transaction, you can say I want at least XYZ amount of stuff, right? And then the worst case execution that you'll get is this, right? So in some way you can kind of like cap, or in some way you can basically always be ensured, that these entities can't kind of like misuse, even if like they're like even if there's like some amount of centralization in there. But I'm very curious to hear Marco, Chris, like what do you guys think? Because
I mean, the centralization comes from not having a standard, and you have players like One Inch Fusion, you need your unicorn power. You have another place, it's a different system how you compete to solve in a way, and so there's a high barrier of entry, basically. It's either infrastructure cost or actual capital cost, or you need like a lot of money on different chains to actually relay if you're doing bridges. And so I think like the across the ZIP, for example, super great move to solve that. Kalani, super great move to solve that. So once the barrier of entry becomes way smaller, the centralization problems will start going away bit by bit, hopefully. If we don't stay in the North American regulatory framework with all the solvers, we'll be solved, yeah.
Keep it short because you know more about this than I do, but I think at least as a solver, from an off-chain perspective, you always want to combine as many competitive advantages as you have. So I don't understand why, as a solver, you would modularize and only focus on one component, because ideally you have as many edges and you go as vertical as you can to get the highest yield that you can do. And that seems to be what happens in TradFi as well.
But isn't that actually more centralization? Because if one just gets better, they just eat all of the order flow in the end, right?
That's what we observe in TradFi as well, right? That seems to be the natural gravitation of solving off-chain agents.
Like, how do we fix that? Like, what's your, what do we do to fix it?
It's about efficiency, right? Like, if efficiency is there, like, you should just think about mitigating it. But if you get efficiency, it's great.
I don't actually think like a lot of this is like that big of a problem personally. I think like if you have open access that anybody is able to access this order flow and kind of compete in this environment, sure. But obviously the person who provides the most efficiency and the best price is the one who's going to take most of the order flow, right? I think that's natural, right? Like the best person wins, especially in like a market that has perfect competition. And so that naturally in some sense leads to centralization, as you guys kind of mentioned. But I think like that is less of a problem, and I think it's more of a problem that anybody is able to access this market itself. Like the barriers to entry should be low, not necessarily winning should be easy.
I mean, I think there are sort of different sources of superlinear returns to scale, which is sort of what we're talking about here. And one source is barriers to entry caused by protocol incompatibility. So standards help with this because they just reduce the switching cost, and anyone can start a new solver, start a new chain, whatever. And if it uses the same standard, no one has to rewrite their applications for it, which makes it much easier to switch. There are other sources of superlinear returns to scale, though. One of them can just be currently owning liquidity. Like if there is one big solver, matchmaker, they have most of the liquidity. Absent some coordination amongst the users, they will probably just continue to have most of the liquidity because users are going to send their intents, where the liquidity is already. So to me, the other part of this question is actually like a dynamic systems question. It's not just a can we design this architecture question. And that latter part of the question is how do users share information amongst themselves to determine whether or not some big central operator is like screwing them or not. And if they're not screwing them, like, okay, whatever. I mean, a kind of altruistic or at least like minimally extracting monopolist is a pretty efficient configuration of the system. But in order to bound them to minimal extraction, you need a credible threat that if they start not to minimally extracting, you can leave and switch. And I think that's an interesting question.
Nice. I think it's a good note to end on because the clock is ticking down to now 0. Do we have any questions from the audience? Also, I can't see you all that well because of the lights. So if you just shout a little bit. Okay. No question? Okay. So then, thank you all guys. You've been beautiful.
Thank you.
Thank you.
Thanks, everyone.
Right. Hello, I'm Zaki. I've been your MC. I'm going to give another talk on chain abstraction. So I guess what I'll try and do in this talk is sort of kind of pull together a lot of the things that we've heard from the other talks, though I think we've had a relatively good interaction, sort of aggregation of this. I do think in many ways, like this whole industry sort of consolidation around chain abstraction has been a little bit of a psyop that I have been conducting for the last few months. I sort of came to this conclusion that chain abstraction would be a good framework for getting the industry to sort of focus on what seems to me to be the last remaining problem towards sort of mass adoption. And so we are doing a bunch of chewing glass right now across a number of different projects, many of whom have been speakers, many of whom participate in the CAKE framework, maybe lots of working groups, et cetera. But like, there is a destination, there is an end goal. So the point of chain abstraction is to make these sovereign infrastructure usable. So easy to use app experiences across sovereign infrastructure. So so people ask, where are the applications? In my mind, and from sort of my experience working in this industry for the last decade, we have basically 5 use cases. Payments, volatile assets, leverage, yield, 4. These 4 assets, payments, leverage, yield, and volatile assets. These are our sort of 4 key things. And I'm always excited about the possibility that our industry will find like a 5th thing or a 6th thing or a 7th thing. And maybe chain abstraction helps us get there. But one of the big points that I've experienced a lot is that in the current world, delivering those 4 products to end users is still really hard. We still provide massive barriers to users when they want to. And one of the problems is that developers frequently find themselves in a situation where, as long as they are operating in sort of the paradigm of user control, self-custody, et cetera, developers can't really express using the current set of tools, smart contracts, bridges, intents, et cetera, actual solutions to the problems that their users are facing. So this is what we're trying to do. We're trying to make developers more expressive. So what are we building? And by we, I mean largely, like, I'll take this in like the most expansive set. Like basically every blockchain dev, every app dev, what are we all trying to solve? So one of the most sort of persistent problems has been dealing with asynchrony. So an example of an asynchronous sort of experience, let's say take Sommelier. So Sommelier is an app. Users deposit into vaults. They deposit into vaults. Once they deposit into vaults, their assets start earning yield. Eventually, they may want to change their capital allocation. They withdraw funds from vaults. What do we currently present to users? So in the first generation of, you have this asynchronous interaction where users deposit, the strategist comes in, sends a set of transactions, interactions with the Sommelier protocol, and that results in assets getting deployed. Users don't really have to deal with that. The sort of deposit workflow, because we went out and made our deposit workflow integrated into all of the native chains, reasonably good. We can talk about some of the other challenges there. But what we've had as a sort of persistent problem is when users withdraw. So first generation withdrawal was if the strategist would maintain a buffer that could be instantaneously withdrawn. If you wanted to make a larger withdrawal, because all the capital is deployed, you would like join a Discord channel or send a message on Telegram, and we would let the strategist know, hey, like a user wants to withdraw this much, can you make the buffer bigger? Huge coordination problem, super terrible user experience. People hated it. So then we came up with this idea of, hey, like, what if we actually recorded the intent on chain for a user to withdraw. So we actually came up with a simple intense framework, and we deployed it. Then users have this simple intense framework. Well, users typically want to, when users want to withdraw funds from Sommelier, they typically want to do something else with it. They might want to go deposit another protocol. They might want to withdraw to a centralized exchange, et cetera. And the current user experience is, well, you have to keep going back to the site and check, or like looking in your wallet, checking whether or not your intent has been fulfilled. And it might take up to 24 hours, sometimes longer. Sometimes you have to ping someone because your intent didn't get filled. This sucks. We do not really have today a solution across the entire space for, this thing, this intent, this transaction, this thing took, X number of hours to settle. And now we want to do step 2, step 3, step 4 of a user's workflow without the user coming back in and having to interact with the chain again. This is, I think, essential. So I think of like the work of teams like Agoric and their ability to, and like Agoric is like extremely focused on this idea of asynchronous smart contracts. They have this new idea called orchestration. There are other potential solutions like Capsule is another team that I work with. They're working with on this idea of sort of scoped permissions for the wallet. So like you can delegate to your wallet the ability to do something limited. Agoric is like you delegate to a smart contract the ability to fill the rest of the workflow. In Cosmos, we've had a very limited version of this called packet forward middleware, and honestly, it's like really nice. There's a huge difference between it takes 20 minutes to wait for Ethereum finality, but it's a huge difference if you want to bridge from ETH and then swap to be able to sign one message and then have your bridge and swap take place, and then you don't have to look at your computer again, your swap got executed. But it doesn't really help you when you want to do something more complicated than a swap. So yes, we have this problem pervasively. And I think one of the big efforts of the chain abstraction group is to solve this. So another problem is coordination. So we have this problem of making credible commitments across multiple chains. Blockchains are super good at making credible commitments inside of one chain. Something like pump.fun couldn't exist without this. Basically, it's the ability to make a credible commitment that a user will the proceeds from the initial sale of the tokens will go into a bond or into a liquidity pool, and the LP tokens will be burned. Super great, but we can really only do that across one chain. When we want to do we want to do all of these other kinds of credible commitments, it gets a lot harder. So what we're seeing is protocols like Near. Near has this chain signature concept, which is basically sort of embedding a custody function accessible to the smart contract platform within the chain itself. That sort of enables you to have wallets that can make credible commitments. Frontier is working on this protocol called One Balance. Same idea, wallets that can make credible commitments. Cross-chain state proofs seem to be getting better and better on a regular basis. And again, provides a mechanism for making credible commitments. Routing, I mentioned that the Sommelier deposit flow was designed to be pretty good. You can think of it as an early form of chain abstraction because while we have an app chain and sovereign infrastructure underneath, the user interface that we provide is an Ethereum smart contract or an EVM smart contract across a number of L2s. So you don't have this experience of bridging or anything involved. But one thing that's genuinely still terrible is expecting the user to route their interactions. Now I think teams like Jumper are doing a good job of improving this, but there's still huge gaps in sort of in the overall crypto ecosystem across basically routing users to apps and to interactions. So you have money on Coinbase, you have money on a number of chains, you have a portfolio of financial assets. You want to transform that portfolio of financial assets in a way that you own an NFT, or you deposit into a protocol, or you buy a meme coin, or anything else that, or you help pay for dinner. It continues to be shocking to me, and it does seem to be one of the biggest usability challenges of the industry that we are still in this place where it is like really, really hard to route users across. So like simple, easy to use routing APIs, I think are probably a thing that will emerge out of the work that like Socket and Jumper and Across are all doing, so that application developers don't have to think about this, don't have to invent their own systems to make this possible. Another problem is custody. So when you're a user and you have assets across multiple chains, you end up having like this proliferation of wallets, right? You sit there and you go, I have like 15 this like standard screen that everybody sees where they're like, oh, I have like 15 different wallets. I have a wallet to interact with Solana. I have a wallet to interact with ETH. I have a wallet to, and I have to I have my own, they all have their own mnemonics and key storage and ledger apps. This again is profoundly user unfriendly. I saw that Coinbase made an announcement recently of a sort of new omni-chain wallet standard. I haven't checked it out. It sounds really cool. We also have things like Capsule and Privy that are providing like a single MPC backend that can support a variety of different chains and custody. I'm really bullish on also just like embedding agents in the custody infrastructure. So things that whether or not it's an agent that tells you you're about to do something really risky and dangerous with your assets, whether it's an agent that can like advance like an asynchronous workflow for you, but ultimately we want users to have sort of one custody system that they can sort of go wherever they go, rather than having to sort of spin up a new custody infrastructure every single time. It's like you join a new infrastructure, you have to like learn how multi-sigs work, you have to learn how Ledger works, it's like, as a person who like uses a lot of different infrastructures and like a lot of different ecosystems, this is a huge form of like brain damage. So what are the other sort of big pieces? So incentives and governance. One of the most powerful things that we do in cryptocurrency is like pay people to use our apps. We pay people to provide liquidity. Like this ability to distribute incentives at scale is one of the most powerful things about cryptocurrency. It's also one of the most painful things to do to deploy across many or multiple chains. Right now, there's like a series of multi-sigs that are frequently necessary, or you have a points program. It's a really painful process, like just deploying all of these moving pieces, super difficult, super hard for application developers. And if you can't take advantage of the like most powerful capability of sort of blockchains, this ability to like direct user incentives at scale, we're not going to be able to like sort of achieve this like sovereign multi-chain modular future. So what does this look like when we bring it all together? So in my mind, what the future would look like when we sort of achieve our sort of modular, like chain abstracted apotheosis. Yes. Like sort of the perfect chain abstracted world. Users have a single system for managing keys. Maybe wallets, transaction formats will always be changing. There will always be unique and different formats. I don't think that ever goes away, but like ideally, multiple forms of custody support a single sort of key storage back end that uses sort of multiple forms of recovery. Most apps can see users' balances across not just potentially just like self-custody Web3 infrastructure, but also centralized exchange accounts, et cetera, and provide you like really good routing. Like this is the easiest way for you to get assets here, just sort of in the standard app interface. So the idea of like an app interface, it becomes more like Plaid for Web3. And finally, you kind of end up in this world where incentives are just as easy to deploy on just one chain, and like governance is just as easy to deploy and sort of extend across multiple chains and multiple ecosystems as it is to have on one chain and one ecosystem. So I think we can get there. I think we're like 1 to 2 years away. I think that if we get there, we end up in a place where the core things that we have product market fit for in crypto, volatility, leverage, yield, and payments, are actually accessible to like billions of people. And then Hopefully, this is an infrastructure in which the discovery of like the fifth, sixth, seventh thing that people love to speculate about where will the apps be becomes possible and achievable. So thank you very much. I have 3 minutes for questions. If anybody wants to chat about anything.
Do you think apps should have their own wallet infrastructure internally, like to be cross-chain, or you think that you need the wallets to fundamentally be cross-chain first?
I fundamentally think that, so like we're right now in this like weird balance, right? Where like there isn't an API provider that will just give you like key storage, like that's widely adopted yet. There aren't like standard APIs for just like storing keys and providing self-custody. You do need, and then you have these like sort of intermediary layers of processing a transaction, like what gets displayed to a user, et cetera. I think, we've seen experimentation in the Ethereum ecosystem with this like embedded wallet concept where you get rid of the entire wallet completely and it's entirely owned by the app experience. And I think that there might be that seems like an interesting component, but what you really want is to be able to like have like essentially key material transition between those two environments. Like so you can use the same keys in an embedded wallet that's like extremely sort of optimized for this particular app experience, and the same keys inside of a sort of standard wallet interface that's doing sort of multi-chain things. And if we achieve that world, it like gives people a lot of flexibility for optimizing their experiences, rather than like the current world of where you have to have like sort of different key hierarchies and sort of different custody notions between these two worlds.
What do you think about apps having the user like make a custom hotkey for the app, or NPC share the seed with the
Yeah, I mean, like this like custom hotkey for an app thing can be quite usable, but then it results in like sort of meaningful frictions, right? Like, when we were doing the Penumbra airdrop, for instance, like we ended up one of the airdrop criteria was effectively people's like DYDX like hotkeys, and they had like no idea how to import those into Kepler, how to like access them to like claim their airdrops. Just like a little friction like that, but like these are challenges. Thank you very much. Oh, okay. You're next. All right. Dev Oja from Osmosis. Yep.
Hello all, I'm Dave. I'm going to be talking about how we can lower consensus commitment times. So what's the goal here? When you make a transaction, let's make your front end update very quickly. So why do you want this? It's kind of obvious, I think. When you go do a swap, you want to see what happens instantly. You don't want to wait 15-second block time. You don't want to, a lot of the reason why rollups are being so popular lately is one, low fees, but two, they're really quick. So the roadmap of this talk is going to be first chatting about what are we improving in consensus today, and then I want to tell you a bit about Tendermint and how it's actually really good, and I think people have kind of forgotten about this. Then a little bit on pre-confirmations, some stuff on short-term censorship resistance. I'm going to skip the bull shark Mysticetti stuff today, just due to time. And then what I think will be really interesting is there's been a lot of discussion on solver networks, or like having a lot more work being done in the mempool. And we can fix, there's a lot of problems there. These are actually solved as with what I call provable DA ingestion, and we can make this really quick with geo-distributing DA. So I think that'll be really exciting. So let's dive into it. So what are our big problems in consensus? It's actually like kind of the same problem. Give low latency commitments to users, get high throughput, and achieve short-term censorship resistance guarantees. They're the same problem because I'm a user, I want to get a transaction quickly. If there's many other users, I need high throughput. if the next validator is offline, censoring me or whatever, I need some short-term censorship resistance guarantee. I guess one other thing on here that's a big problem is decentralized validators, but shut up that separately. So in this talk, I'm actually only going to be parameterizing around trying to make decentralized validator sets. So I think that's our interesting goal in crypto, to be make something a financial layer for the whole world. So yeah, what's a commitment? Well, okay, I've committed to something when I think that either the thing will happen or some security assumptions violated. So for consensus, we're concerned mostly with two things. Inclusion commitments. I know my transaction will be included on chain. This is sufficient for many things like limit order placements or just payments. You only need inclusion. Your execution guarantee is pretty simple. But then there's also execution commitments where not only do you know your transaction will be on chain, but you want to know the result of it. So this is like, if I do a swap, what's the result of the swap? Typically, this will depend on being in a block, but we'll discuss a bit about how you can do better in decentralized environments. Okay, so warm up, like what is the traditional commitment times? In Cosmos, it's the time to get into a finalized block. As a user, you've got no guarantee when you'll be in a finalized block. You kind of make a transaction, it floats around in the mempool until a proposer includes you. But if you have enough fees, in principle, you should get into the next block. And a block's finalized in one height. So in practice today, this is like 1.5 to 5 seconds, depending on how your favorite blockchain parameterizes the network. But what about censorship resistance? And for context, censorship is the word we use, but this includes like a validator denying they saw your transaction, legitimate network delay preventing them from seeing it, or like software bugs, or economic incentive attacks. But we say censorship, and it doesn't necessarily mean active malice from the validator. So this is going to matter a lot. I'll go into the next next slide. But the strategies we have for solving this is, one, faster block times. The second biggest one is break up the proposer's monopoly on block space. So what we're doing with like Tendermint vote extensions, DAG-based BFT is doing this. Most recently, Ethereum's considering multi-proposers. Then we have encrypted mempools. I'm not going to talk about that today, but you can see Fervio or standardized threshold encryption talks. In general, these solutions depend on either breaking up the proposer monopoly, having a centralized trust assumption, or very cool cryptography called witness encryption that has not seen the light of day yet, and app layer incentives. Okay, so why do we care about short-term censorship resistance? Well, anything that has a challenge period depends on you being able to include transactions on chain. So and being able to include transactions on chain quickly needs short-term censorship resistance. So every optimistic fraud proof needs this. If you have intent layers or like mempool solving networks, and they want to give a user a guarantee that you'll settle within 5 minutes, you need this as well. Lending markets need to be sure they can get on chain pretty quickly. And something I think a lot of people haven't realized is that on-chain TWAPs are only as good as your short-term censorship resistance. So like in Ethereum, you have Coinbase routinely proposing 8 blocks in a row, which is about 2 minutes of data. So now people have stopped using on 5-minute TWAPs because it's basically a centralized Coinbase assumption. To fix this, we need to build this back into our protocols. So yeah, I guess if you look at the I'm gonna skip this. You need to parameterize around what will be safe, even in like the tail cases, like 0.1% of the time. So the simplest protection you have is make faster blocks and design blockchains that get you all your decentralization with this preserved. So in Ethereum, if you lower block time from 15 seconds to 2.5, very standard across Cosmos now, then 10 Coinbase blocks in a row takes it from 2 minutes of downtime to 20 seconds. Coinbase being like Coinbase the company. That's a huge improvement. So where are we with Tendermint today? Tendermint as a protocol is actually amazing. You have 3 internet latency trips. So going from like Eastern North America to Japan is about 150 milliseconds, mostly bound by the speed of light. So we can get globally distributed like broadcast one way in say 100 to 150 milliseconds. So that means Tendermint can get consensus to happen in like 450 milliseconds. So if you're a user, you want to talk to the next block proposer, that's okay. You have to talk to them, which is maybe another 150 milliseconds. So so that gets you 600 milliseconds. And then the closest validator can then tell you once there's 2/3 of votes, or once you're finalized. So This means the Tendermint baseline for a user guarantees 650 milliseconds by just optimizing the algorithm. No like new consensus tricks. So if we just did this, that would make our censorship resistance for all these protocols go from 2 minutes in the ETH example, well, now to 5 seconds. This is a qualitatively different world. And if we pipeline consensus, that's you can get a new block every 200 milliseconds, gets you down to 2 minutes to 2 seconds. So Tendermint alone gets us very far. You interlude here, you may say Tendermint takes you 1.3 seconds, but as Zaki's aptly noted on Twitter, all this is all low-level bugs. After spending a bunch of time in this, these are all very fixable. We've done actually a tremendous amount of work the last 2 months. Shout out to Evan if he's here. Evan's around somewhere. From Celestia, Anton, Casson, and myself. And so I think, I imagine the next few months we'll be able to hit this platonic ideal of 500 millisecond global Tendermint blocks. Okay, so now next thing I wanted to hit on is that Tendermint is actually better than 2 rounds of voting. This is maybe a minor optimization to folks, but I think it's cool. I said there's 2 rounds of voting. There's pre-votes and pre-commits. Once you've seen 2/3 of pre-votes on a block containing a transaction, it's almost certainly going to be finalized. There's only 3 cases where it won't. There's double signs. Okay, people getting slashed. Another edge case is 67% of validators are being Byzantine, but in a way it's unaccountable. But why would they do this? Like, what do they gain? Or you have the communication graph between all of the honest validators is partitioned. But that's actually a crazy assumption. That's like saying that you can control the flow of stopping North America from being able to communicate to Europe or Asia. This is, I think it's safe for a user to have their limit order or have the limit order be preemptively confirmed in this case. So we could give users confirmation at 2/3 pre-votes. This is a much stronger guarantee than pre-comps, for instance. And then you'd have a user delay of like 500 milliseconds. Gossip to the next proposer, 2 rounds of gossip, then closest validator back to the user. So, okay, great. Our baseline of Tendermint is 500 milliseconds. Can we do better for things? There's this common idea in Ethereum for proposer commitments, or otherwise called pre-comps. So what's a pre-comp? Imagine the user can gossip their transaction to the next proposer. The proposer can sign a promise saying, I promise I'll include you in the next block at position number 5, and if I don't, I get slashed. So this helps you improve inclusion time if you trust the next proposer, but this has a lot of reliability issues. Rollups are getting away with this only because they're centralizing other things. Like they've basically centralized MEV rights and censorship with a single sequencer. If you don't want that, like if you want to be a decentralized thing, you care about censorship, then, which is a core property, I hope, as I noted earlier, then this won't be speeding up execution guarantees. So we need to be more clever for that. So yeah, trade-off of this, a pre-comp just to the next proposer gives you no censorship resistance. You get even better latency, 1 internet round trip. I guess Mega ETH is now saying if you're in a single sequencer chain, they can actually geo-distribute their pre-comps, so maybe that's 50 milliseconds. But yeah, this won't speed up execution. So here's one idea. Let's get people faster execution pre-comps, not from consensus, via intent networks. So let's say that a user publishes some intent. Hey, I want to buy Bitcoin at 50,000 USDC. They post this into the mempool. If there's a market maker who sees that, the market maker can pick it up instantly and say, okay, I will fill you. User, here's the signature saying, I will fill you, and if I don't, you get, if I don't fill you within 5 minutes, you get, I will get slashed. So the user can see this in the mempool layer before a block's been proposed and feel like they've gotten finality or been confirmed. If the market maker doesn't do this, the market maker gets slashed and the user still gets paid. So this gives the user a 50 to 100 millisecond confirmation, but this can also fail safely, that if there's no market maker, it just goes back to the chain and the user gets a 500 millisecond guarantee. So now, as long as we have short-term censorship resistance, like as long as the market maker can feel confident that they will be able to get onto the chain, then we can build a system like this that can give users faster confirmations if someone's willing, but otherwise fall back to the chain. Yeah, and this actually matters a lot. This is going to be a big failing in a lot of intense networks if they don't fall back to the chains, because it actually turns out it's hard to bootstrap market makers. You're going to need to tap into on-chain liquidity first, and once there's a lot of order flow, then market makers will come. So yeah, and this will generalize not just for swaps, but to many actions people want to do. So this means that you can get external actors to give you effectively pre-comps with 50 millisecond timings, or just local to your own continent or geographic distribution. And what's even nicer is this won't overload consensus at all. We just need the guarantee that the intent solver believes they can get into the chain quickly, which just depends on short-term censorship resistance guarantees. Okay, I see I have 5 minutes left, so I'm going to kind of skip through this. We can get censorship-resistant pre-comps via vote extensions. The idea is every validator can contribute votes. I want to shout out to Barry and Skip team for basically building this in osmosis for the top of block auction. And but I'm going to skip through this to go to the next thing. I'm going to skip the bull shark study as well. Here's the thing I think will be exciting for the audience here. There's this idea right now if you want to do a lot in the mempool or intense layers or like the Suave solver. So I'll tell you a little about this idea from DYDX that they're calling memclob. And it's a unique scaling improvement that's kind of being pioneered in Cosmos right now. The idea is that in DYDX, they're running an exchange. So they want every validator to just run an order book in their mempool. Well, and they just want to post the finalized transactions to the chain. So the idea is that if you can place and cancel limit orders with no gas and much more cheaply because these are only in the mempool. But this has some pretty clear massive problems. Every validator gets full MEV rights. So this means that every validator can basically kind of rug any user because you place a limit order and it should be filled. They can just kind of pretend to not see it. You cancel a limit order because you think it's bad. They can just pretend to not see the cancel and still get it filled. Or if you want to do a market buy, they can kind of pretend there's no limit orders there and give you a terrible execution price. So right now, this gives you very little guarantees. It says you get much better throughput, but your censorship resistance is actually kind of worse than normal chains because nothing's getting posted to everybody. And as a user, you have no reliable confirmation. Your UX update is arrival into a mempool that could be ignored. And we just kind of assume things will work out due to social consensus. But there's a way to get this property using data availability and get our throughput win. So we can fix this by having every validator prove that, hey, here's some DA layer. Here, I promise that I have seen everything in this DA layer. Why do you need a DA layer? It's not good enough that a validator promises they've seen something. You need to know that all the validators are seeing things. So a DA layer is fundamentally kind of giving a shared view of what data has been posted to all the validators. So what you need censorship resistance as well. Let's basically get your DA layers to have censorship resistance. We can achieve that basically by doing vote extension tricks at the DA layer as well. So your latency to the user is going to be a DA layer latency. But here's a problem. Why would your DA layer be faster than Tendermint? Like, it's still just going to be 500 milliseconds if you want globally distributed DA. And here's the cool idea that we can do as well. We can just have geo-distributed DA layers, one in North America, one in Asia, one in Africa, one in Europe. And you can have every validator promise that, like, before I said that every validator promises they've ingested everything from one DA layer. Instead, you could have a North America validator promise to ingest data from the NADA layer zone. So they'll include everything that was included in the NADA layer. And then you can have these DA layers sync with each other. So the NADA layer gets consensus in, like, say, 50 milliseconds. And then with a 200 millisecond latency, we'll get all data from Asia and Europe. So now, as a user, if you get posted into, say, the NADA layer, you can get there in like 50 milliseconds. Basically the speed of internet to you and the closest data center in the region. And then as time goes on, as like the speed of light delays goes on, this gets automatically propagated to Europe and Asia for the next validator that will post there. So now, so in this example, let's say that the NAD layer finalizes every 50 milliseconds. As a user, it's pretty instant to talk to your NAD layer. Within 50 milliseconds, you know you'll be included by the next North America validator. Then after, say, 150 milliseconds, you'll be included by any subsequent Europe validator. And after, 200, every subsequent Asia validator. This is a really strong guarantee that kind of strengthens with time. So I think this is going to be, this is the future for how we should get really fast inclusion guarantees with globally distributed networks. Okay, yeah, I think that's it. Maybe I'll end with some of my takes for what should Cosmos do here. I think we should get tenement block times down to the platonic ideal of 500 milliseconds. And we should just keep iterating on vote extensions for encrypted mempools and short-term censorship-resistant inclusion. Let's switch to getting user state execution results after 2/3 of pre-votes. And let's go to this world of fast geo-distributed DA. And if you want to implement a new consensus algorithm, either pipeline tenement or implement Mysticeti. But I think the fast geo-distributed DAs should be our main goal. Thanks everyone for your time, and let's chat about how to improve any of this stuff.
All right. Next up, we have Barry from Skip.
Test. Can you guys hear me okay? Thank you. Zaki gave this to me. I don't really know why, but I am wearing it now. It's the modular mullet. Okay. I showed this talk to no one, so I'm gonna try to tell the story that I think kind of defines sovereignty and modularity, kind of the hopeful part of it, and the challenging part, and how we are trying to add a little bit more hope and help sovereignty win. So the first part of this story is that building sovereign is like going to space and settling the galaxy. In traditional crypto ecosystems, your ecosystem is your ceiling. If you let another protocol project team define your relationship with your users and decide where they come from, that will be as large as you can be. And maybe that works initially, it's a great way to start, but over time, folks' ambition grows beyond that. We've seen that with a number of the projects that have migrated from Ethereum to Cosmos. And the problem here is that those limits are a lot lower than people think. So let's take a look at like Arbitrum, Optimism. The most successful ETH-L2s that exist are both worth $7 billion today. And that might sound like a pretty high limit. You might be thinking, oh, Uniswap is $6 billion, $1 billion outcome is extraordinary. But in practice, the limit is a lot lower than that. Let's take a look at the Uniswap example, right? $6 billion sounds epic. It uses 50% of block space on Ethereum. It controls billions and billions of dollars of liquidity. It is the most successful decentralized crypto protocol that exists, hands down, but it is built in an ecosystem that is worth $400 billion. It is a tiny, tiny fraction of that ecosystem, despite that massive level of success. And so your ceiling is not $7 billion building in someone else's ecosystem. It's much, much lower. It's 1% of that. So the problem is that if you are building in a traditional ecosystem, you are just mathematically not traditionally venture backable. Your best outcome is $100 million. And compare that to building sovereign. Let's take a look at the Cosmos ecosystem. Everybody kind of thinks of Cosmos as Atom and as that potentially being the limit, but look at Celestia. Celestia showed up, built a Cosmos SDK chain. Today it's worth 3 times that. Atom didn't impose a limit on Celestia. And that's the difference between building sovereign and building in someone else's ecosystem. You don't have this kind of limitation because you are establishing your own relationships with your users. You are not reusing and rehypothecating someone else's. And I'm not one of those people who's like, oh, building L1 is the only way to be sovereign. I think there's tons of different ways to achieve this. And I think the way folks go about it depends on what they're looking for. But this is the really exciting thing to me about sovereignty, that you have no limits. It's like going out, settling the stars, and building in someone else's ecosystem is a lot more like walking down the road and establishing a corner store. It is maybe a good business to start with, but you can't raise venture funding for that, and you're not going to be able to grow. So why don't we all do this, and why isn't this the way everyone is building? First of all, I think many folks are building this way now, but there are a ton of problems. And the main one is this idea around public goods. So these are going to be like our sovereign chains. They're all special and different. Everybody's kind of like a snowflake. There's some similarities between some of them. We got 2 pink chains, we got 2 yellow chains, we got 2 blue chains, but everybody's their own shape. There's very little commonality, and that makes shared efforts, that makes public goods really hard to build. It becomes very challenging to get anyone to focus on that. Cosmos knows this, so the Cosmos SDK is used by 130 chains. Massively successful open source project, secures billions and billions of dollars of capital. And there are only 6 chains that have developers that contribute back to it. 6. And there's only 1 chain that helps to fund it. And that's Atom. Shout out Atom. Whatever you want to say about Atom, but they actually do help to fund it. This is an enormous problem. Ethereum is finding out that this is really hard too. This is one of my favorite examples. Last year, there was kind of a unified call for action from a bunch of bridges working in the interop space. And they all kind of got together and said, interop in Ethereum is getting much harder. All these different kinds of chains are being built, all these different kinds of bridges. Like, we need standards. And nothing came of this. It's completely fizzled out. And that's because when you aren't unified around a single token, public goods are really hard. This is very much most deeply felt in interop. So these are our chains again. Now we have these little lines between them. These are bridges. All the bridges are also different. And it's really hard, yes, because it's the space between chains, but it's also really hard because every chain secretly, deep down, just wants to be a liquidity black hole. We all want it to be easy to get money into our chain and extremely hard to get it out. And that creates a really bad system from the perspective of someone who just wants to move around, to use applications. I think one thing that is worth noting is that Ethereum mainnet has been excellent at this, has done this tremendously well. The fact that it is extremely expensive to transact on Ethereum has made routing assets through it very challenging. The fact that there's a 16-minute finality time has made getting out really challenging. You need to rely on market makers. You don't have a choice. So Ethereum is an excellent black hole, but everybody else wants that. Everybody looks at that and they're like, that's good. They're worth $400 billion. They've figured something out. I know this is like the chain abstraction track or whatever, but chain abstraction does not solve this problem. Chain abstraction potentially helps us get better user experiences, but the way that we get those user experiences is by building these kinds of protocolized middlemen and enshrining them and letting them have relationships with the users. And we're doing that in a situation where there's extremely strong network effects, there's strong economies of scale, there's strong switching costs, and that leads to an enormous opportunity to monopolize this kind of off-chain closed space. This is a picture from a 1907 magazine about the telephone industry depicting AT&T as this growing, grasping octopus spreading out across the United States, giving all of these cities connectivity, but also massively constricting them and massively overcharging users. So this is, from my perspective, deep down secretly what all interop protocols want. They all emulate AT&T. I know we at Skip do. And I think The challenge here is that connectivity to users and connectivity to liquidity is so important that we can't let this kind of thing happen. And this is an enormous threat to sovereignty. I'm going to run through just a few examples to kind of prove this point. So the token bridge octopus wants to become canonical money, and that's how it performs rent extraction. So it connects you to everyone else over these kinds of standardized bridges that seem really nice, and that's all great. And then the money makes its way into all of the DeFi protocols and all of the chains, and then all of a sudden the transaction fees can go up, and the money that's on your chain isn't actually yours or your users. It belongs to this third thing. Solver networks are the same way, though they operate differently. Here, the solver network shows up and says, you know, don't worry about trying to find your way around this like complicated route of bridges that's far too complex. You could never possibly figure that out. We'll give you just the one direct path. You don't have to worry about it. Like, don't worry about how it happens. And that sounds pretty good. And then we start to have a nice network effect around more solvers showing up and them offering better prices and that attracting more order flow. And pretty soon the fill cost is much lower than other folks' fill cost. And everything is great, but that difference becomes the rent. Balance abstraction, chain signatures, all that stuff is really hot right now. These things are also just octopuses seeking to cut off users from protocols. So the way this works is we say, okay, you know, it's really hard to figure out how to move assets between these different chains and how to sign for all of them. They've got different kinds of signature algorithms. So let's just move the users over to this other thing. Let's store their assets in this other thing. Let's have the permissioning layer move over here. And then there's one kind of standardized way that you can sign on all these things. But pretty soon, that thing also becomes the octopus says, okay, now you want access to your users, you're gonna have to pay more. So in each of these scenarios, we have a situation where the applications, the things that we're trying to build that are supposed to be useful, that are supposed to provide value to users, are being disintermediated from their users and from their liquidity by a middleman. And it can be a protocolized middleman, but because we're off-chain, there's so much complexity here, so much of it gets pushed into the dark edges and pushed off to market makers that this becomes a real threat. So I think there's a lot that we can do to fix this, and this is really what Skip is dedicated to, is trying to make sure that we can have sovereignty without these kinds of protocolized middlemen. And there's kind of 4 steps that I'm just going to walk us through. The first one is permissionless interop protocols are a great start. So Hyperlane, IBC, things like that that don't require anybody to show up and say, you know, fine, yes, you can launch. And I think Axelar and a number of these other bridges are starting to work on permissionless interop too, which is super exciting. That means that we can have these 2 sort of separate sections of chains that don't have bridges between them, and somebody can just plop one down without asking anyone and connect them and create kind of global connectivity. Now, this is not the whole story. This mess on the left is still really quite hard to navigate, and there's a lot of steps between I'm imagining I want to move from one chain to another to actually making it happen that the permissionless interop protocols do not solve. So the second step, and this is what we're working on at Skip right now, is to create a fully open sourced end-to-end platform to actually handle all of these off-chain pieces and aggregate over all of these routes. So we start from the user saying, I have token A on chain B and I want to go to, you know, lazy chain and buy a sloth, and we end with actually relaying their data there after searching over all of the different paths that we can do that. Solver networks, traditional token bridges, DEXs, combining them into one single user action, one single click, and then wrapping that into an API that developers can use. And this being open source is incredibly important for us being accountable to our integrators. It means that if we start any of this kind of octopus behavior, They can fork it, run it themselves, extend it, do whatever they want. They do not have to rely on us. Now, that's still really quite hard to do, but now we can go anywhere, right? We don't have to turn to these complex off-chain systems, and even if we want to, now the logic by which they operate can be brought into the public and can be made accessible for anyone to use and access, and we'll have more fair, more open, cheaper solver networks that are accessible to anyone. And now this whole complexity of I need to go through 3 different bridges, I need to figure out where to swap and what to do, it's all just automated and it all just works. Skip offers this today, but we're not yet open source. We're working on that. The next step though is that, like I said, it's still really hard to run that thing. So our aggregation platform is almost 200,000 lines of code. It's spread across 6 different microservices that all take care of one of those individual parts that I was showing before. And it's really quite challenging to run and keep up, and that is another source of centralization. So what we need to do is make it actually verifiable that we're running it correctly, or whoever is running it correctly, and ensure that the user's privacy can be protected when people are interacting with this thing. There's a bunch of different ways to go about that. This idea of putting it in a TE is one that we talk a lot about on the team, and we're starting to explore, but we're excited about exploring others too. What this gives us is it guarantees that when we are optimizing over these different bridges and these different routes and solvers, that we're doing it fairly, and it ensures the users are actually having their preferences respected. If they want the fastest route or they want the cheapest route, they know that that's exactly what they're going to get, and that we're not cutting side deals with anyone to change that. So we're pretty close now. We have permissionless bridges that we can deploy anywhere. We've got an open system that allows us to navigate those permissionless bridges, and now we have a mechanism that makes it such that anyone can run that system, and we don't have to trust that individual entity or that person. But the problem with all of the octopuses is kind of none of these things. Many of them are open, many of them are on chain, or they could try to become more that way. It's actually governance. It's actually accountability. It's ensuring that after you've built that network effect and after you have that scale economy, you remain aligned with your users and your integrators. And so the last step, again, we are trying to answer questions about how to do this, is that you need to make the platform actually governable by the people who make it valuable, which is something we talk a lot about in crypto. We think a lot about this. We talk about read, write, own, and things like that. But in practice, almost every protocol is governed by its token holders, not its users, not the people who are making the network valuable. And those folks' incentives and what they want is different. They want the token to go up. And if at some point that means rent extraction, that's what they're going to do. That is the same problem that we're having in Web 2 with these traditional large networks. And it's the same problem that we're going to have in the sovereign web if we don't kind of solve this problem. And what we're really excited about is trying to think about how we can create governance systems that give integrators and users who create the order flow the opportunity to govern the system, to help set the fees, to help elect operators to it. Same for the protocols and the solvers and the LPs who are actually filling those orders, and same for the developers who are submitting contributions to the system for the paths and the routes that are most used. We don't know how to do this yet, in the same way we don't yet know how to make the system verifiable. We're starting, like I said, today with working on the open source component of it. But we want to invite everybody to come and help us answer these questions. We're going to be building in the public. We're going to be building with a bunch of Cosmos teams, a bunch of roll-up teams, folks like the Celestia team and the Astria team, trying to answer these questions so that we can have an open and fair system, and that to ensure that access to liquidity and users remains something that isn't a barrier to sovereignty and isn't something that other protocols can abuse. So, thank you.
All right. Next up is Heart from Across.
Good. Got it. Forward. All right. Thank you. Backward. All right, guys. I'm Heart from Across Protocol. I'm here to talk about intents. People in this audience might understand intents well, but I think a lot of people don't. And at this conference, there's a few people that have come up to me and been like, hey, I'm finally beginning to get this intents thing. And I'm specifically going to focus on cross-chain intents, what that means, what that looks like. And my goal or thrust here is to try to pill you on why this architecture is important for interop, and why I think it's the best, quote-unquote, best architecture for most use cases of what we need to do to connect blockchains. Okay, so what we want, and I think everyone generally agrees with this, is we want cheap, fast, and secure interop that is so seamless you don't know you're dealing with blockchains. The you don't know you're dealing with blockchains part is called chain abstraction. People like talking about chain abstraction right now. I think that's great. But here, the general point is we want to connect this modular ecosystem. We're here at Modular Summit. How do we connect the modular ecosystem so that it feels like one unified platform? Users just click buttons and do things. That is the goal. And I think the problem here is most people think interoperability looks something like TCP/IP. You have a bunch of servers, and you want to connect them with pipes and send messages between them. And this is how the internet works, so it makes sense that this is how we'd connect blockchains. And I actually think this is a misnomer. This is what gets us in trouble. If you think about this kind of naive version, let's see if I can use the pointer thing. Yeah, okay, so I have blockchain A, blockchain B. I want to send value or send money, send an asset, send 1 ETH between A and B. Let's just send a message, right? That seems easy, makes sense. But there's some problems with this. Problem is, blockchain has some sense of finality on blockchain A, so I can't really send this message until I achieve some sense of finality on blockchain A. And then sending a message between blockchains while being secure is hard. I have to be fast, cheap, and secure all at the same time. That's an extremely difficult thing to do. There's a lot of three-way pyramid things about why that's hard to make happen. So, yeah. This is a hard thing to do. And basically, if we go back here, we got time for finality, time to send message. That's slow, and it's probably expensive, and it might be insecure. So the solution here is very simply, let's just stop sending messages, at least not in real time. And this is where the intents concept, the cross-chain intents concept really comes in. The core observation that I think we've made is in the internet, in TCP/IP, you're moving bytes, you're moving messages, you're moving data. But for 98% of blockchain use cases today, when we are connecting between blockchains, what we really care about is moving value. And I say mostly because there are use cases where I need to move messages. We can maybe talk about that later. But most of the time, I'm just moving value. I'm bridging, I'm swapping, and maybe I'm calling. So on the destination chain, maybe I'm doing some action. And that further extends to this concept that, okay, value is fungible. If I'm a user, I don't care which dollars got to the destination blockchain. I just want dollars. They're the same. And I think this is like the core insight that unlocks in this cross-chain intents concept. I don't care how the money got there. I don't care which money it is. I just care about it being there. And I think this is our mental model for why we think cross-chain intents work so well. So we'll redo this bridging concept where I want to move value from blockchain A to blockchain B. but we're going to not send messages. So no message sent. Instead, we introduce a third party. We're going to call them solvers. In Across, we call them relayers or fillers. Some people call them market makers. All the same concept. It's a third party that is going to observe the user's deposit transaction on blockchain A, and then going to fill them with their own capital on blockchain B. And the core trade-off here is with their own capital, which we'll go into. So the solver fills them with blockchain B, and they can fill them extremely quickly. If this solver trusts, say, a pre-confirmation from a centralized sequencer or decentralized sequencer, whatever it might be, if they trust what blockchain A is telling them, these solvers can take risk with their own capital to fill the user near instantly. And the fun thing I could do if we had a computer and I could do demos, I could give you guys a demo of this. Our median fill time, L2 to L2 on Across, is about 4 seconds right now. When we're going from Arbitrum to Base or Optimism, it's about a 1 or 2 second fill time. It's extremely quick because we have a solver network that is trusting the Arbitrum sequencer here, but they're trusting it with their own risk capital. It's not the user's money that's at risk here. And they're giving an extremely fast fill, which we'll get into more. Okay, so idea here. With cross-chain intents, solvers are using their own capital. I'm repeating myself here. Solvers are using their own capital to quickly and cheaply fill users, and then they get repaid later. So, okay, we'll zoom out a second here. This is what the Across view of what cross-chain intents looks like. This view is shared by a lot of other people in our ecosystem. The Frontier Research guys, the Cake framework looks like this. What Socket's doing with their MoFo framework looks like this too. A bunch of people are kind of independently coming to a similar looking architecture where we have 3 layers. We have the intent layer, where what the user wants to do is created. This you can think of as the application. User says, I want to move A to B, or maybe it's move A to B and do a deposit function, or buy an NFT, or execute some bit of code. We have the solver layer that is competing to fill that intent, and we have the settlement layer. The settlement layer here is going to escrow user funds on the destination chain and not release them to the solver until we verify the intent was repaid. So the general order flow here, intent gets created, user funds get escrowed, solver fills user extremely quickly with their own capital, then wait, delay, verify the intent was filled, release user funds from escrow back to solver. Okay, so I want to walk through just sort of why I think this architecture works well and what the trade-offs are. So intents, as I said before, they can be really, really fast. This is data from our own internal systems where we're looking at L1 to L2 bridge times, L2 to L1, and L2 to L2. And Across, we really do have a median fill time of about 4 seconds. The 90th percentile fill time's under 10 seconds now, and we're pushing hard to get this down. What's cool about this is we don't really do anything. We just incentivize solver competition. And the solvers themselves are the ones that are competing to fill users faster. As some of you may know, I sometimes war with Stargate on Twitter. This is our data, not Stargate's data, but this is our data that you can verify yourselves on Stargate v2. They're a lot slower because their general framework is this: let's send a message from A to B, and they have to wait for a sense of finality. It's a different architecture. It has some trade-offs, but it's certainly not as fast. And for comparison here, I also included Circle CCTP protocol, which I think is very cool, very useful, and is actually integrated with Across under the surface. But the way Circle works is if they're going to burn and mint USDC, they need absolute certainty around finality guarantees. So Circle will wait for full finality of the L2 checkpoint to be finalized by Ethereum. It means it's going to take them about 20 minutes to bridge transactions. And that's something that they're not going to change because that finality guarantee matters so much to them. Okay, so too much text on this slide, but the high-level context here is I think intents can be extremely secure. And the observation here is that we are separating the urgent part, that the user wants a fast fill, from the complex part, which is how do we verify that fill did happen? How do we send messages between blockchains? And by separating these two things, the complex part we can take our time on, which buys us more advantages for how we would actually verify or send messages between blockchains. And we have in this intents framework, it's not wed to any one messaging technique for how we would verify intents. We can do what we want here. And different architectures are gonna use different mechanisms. You could imagine verifying fills using canonical bridges. This is somewhat how a cross works today. We kind of use a combination of an optimistic system to verify a batch of solver fills, and then we use canonical bridges to move that message from Ethereum mainnet to the different chains that we support. But you can also imagine that we use ZK proofs to do this. You can imagine we use native interop. So when you see the Optimism superchain building native interop, could we use the native interop that Optimism has to verify intents and repay solvers more quickly and more securely? Yes, definitely. Polygon egg layer, all the above. We can use these systems, kind of abstract them into this intents framework to enable more secure relayer repayment. And intents can be really cheap, and this one takes a little more nuance to think through how this happens. But the reasons why we can be really cheap with this architecture involve batching and using messaging techniques that are extremely secure but cheap. So basically in the trade-off spectrum of sending messages that are cheap, secure, and fast, we can give up on fast and focus on cheap and secure. This is data, again, from our own internal systems. We're not always the cheapest. To be fair to my friends at Stargate, sometimes some of their bus stuff can be extremely cheap, but it takes about 3 minutes versus 4 seconds. And so there are trade-offs here in our architecture, and we are gunning towards this idea of speed matters more than very, very marginal price improvements. Okay. So why can intents be cheap? I'll keep this as like a high-level kind of conceptual example. But let's imagine we're bridging $50 million in volume over 50,000 transactions. Let's assume that both bridges, both the kind of messaging architecture and the intents architecture, have the same gas costs for deposit and fill transactions, which is like approximately true. What's the difference between doing this batched verification of intents versus sending a message for each bridge fill? And the trade-off here on the intents architecture is that solvers are making loans with their own capital. There is a cost of capital for a solver to fill a user with their own capital and get repaid later. And as an example, if I'm loaning $50 million for an hour at a 10% interest rate, that's $500 for an hour. And if I can batch together my hour's worth of solver repayments, I can then verify these 50,000 intents for like 10 messages. I'm putting a hypothetical cost here of $1, but it's some fixed cost that's low. And so your main cost is the cost of this loan. But you compare this to if I'm gonna send 50,000 messages, I'm actually saying these messages are super cheap. I'm putting them at 10 cents a message. But sending 50,000 messages is extremely expensive relative to sending far fewer. And I think this is the other insight that I don't know people have totally grokked yet. I look at this intents architecture as a compression of messaging. So in this example, 50,000 cross-chain actions are compressed into 10 messages to verify those 50,000 actions versus 50,000 cross-chain actions, 50,000 messages. And in my view, this compression gives us extreme cost and security advantages. We can then send fewer messages. They could be more expensive, but still in aggregate cheaper, and they can be much more secure. So I think this is an underlooked aspect of why this cross-chain intense architecture can work so well. Okay, so here's a concept, or just a slide of in Jumper, Leafi's Jumper. A cross can actually be significantly faster and even cheaper than Circle's CCTP, which is Circle's native bridge. And like, how's that possible? This isn't possible at huge values. If you're bridging $1 million of USDC, you should use CCTP if you want to minimize costs. But for small sizes, we're actually so gas efficient, this architecture can be so gas efficient on its deposits and fills that we can actually be cheaper than what Circle costs for bridging modest amounts of USDC. And we can, of course, do this far faster, given that solvers are fronting this capital and filling users quickly. So what's the TLDR here? We look at a cross as this settlement layer for cross-chain intents. I believe this architecture can scale to transfer billions of dollars a day of value while sending very few messages. This is this message compression idea. Non-intent-based designs that are sort of messaging-centric, need to send a lot of messages if they're going to send a lot of value between blockchains. And my observations, just intuitively, that feels expensive. That feels like something that's going to cost a lot. Okay, so our vision. At the intent layer, we want to cross, and we increasingly, I'm going to go into a second in this standard for cross-chain intents that we've been developing. But we want to cross to promote this intent-centric architecture where we help aggregators, dApps, wallets, protocols like Skip, create and route intents through a solver network. We want to help develop a solver network that is not specific to a cross. We think this solver network needs to be generic. I don't want to say a public good, but it needs to be accessible to many applications that can all benefit from a positive sum, like a not zero sum advantage of increased liquidity at the solver layer. And so we're working to help establish a standard for cross-chain intents that I'm going to get into. And lastly, there's this settlement layer where across what we are trying to do here is define a best-in-class settlement layer that will escrow user funds and release them to the solver after we verify the intent was filled. Okay. So, yep, we've sort of, in the course of this year, we've relaunched across V3 as a settlement system for cross-chain intents. And we've been working hard with Uniswap, and Uniswap X's cross-chain design in many ways mirrors or has many similarities to what we're doing. We've worked with Uniswap to develop a standard for cross-chain intents. It's been assigned the ERC number 7683. And you guys should go check out erc7683.org. We are actively looking for feedback on this standard. This is still being developed, but we want this to be an open standard that has no concept of vendor lock-in. We want this to be a standard that helps define a common layer of abstraction for how intents can work. And actually, I'll go back here for a second. There's a slide that I didn't quite have time to make before I had to send these in. And it goes to sort of think through how we create a unified Ethereum in a world where we have more and more types of ecosystem interop. So I wish I had a visual for this, but you can kind of imagine we have the Optimism superchain that is working on their version of native interop to connect superchain chains. We have Polygon Egg Layer that's working on their version of native interop to connect egg layer chains. We have ZK Sync doing the same thing with Elastic Chain. Arbitrum Orbit, a little bit less clear what they're going to do here now. They've got some cool stuff coming out, but they're going to connect their own chains too. And so you kind of have, if you zoom out, you've got 4 ecosystems that are building their own versions of interop that might work pretty well. They might not still be that fast. I actually think most of these technologies are not going to be 2-second fill times, which is what we're aiming for. But there's now this kind of fragmentation around how ecosystems in Ethereum might communicate. And I'm not even including Cosmos and Solana and all this other Alt-L ones. And now from just Ethereum's perspective, there's something very cool about fostering this experimentation and this innovation within these different ecosystems. But now you have this splintered and fragmented world. And I don't think that's very good. We want like a unified Ethereum experience. And I think this standard, this thinking of an intent, a cross-chain intent, as a very thin, very lightweight layer of abstraction that specifies how a user can move assets from A to B and maybe execute some code on chain B, it becomes a unifying layer that helps connect these native interop ecosystems with a common standard. And if your intent happened to be, let's say, for example, between 2 Optimism superchains, well, then it would just be better. It would just be cheaper. It would be just as fast, but it would be cheaper because the intent protocol would be able to repay the solver more quickly, more cheaply, using the native interop that the superchain offers. Okay, so I'm going to run out of time here, but we're bringing intents to some new chains. We are also have this concept of a cross plus, where it's just using the same ERC-76 intent standard, but allows you to execute code on the destination chain. So you could bridge and buy an NFT, or bridge and deposit into Aave or Morpho. And the only other thing that I wanted to show you guys, because I think this is super cool, Denkun has changed the game. Denkun lowered costs by so much that what we actually saw is the median size of an L2 to L2 bridge transaction was like $500 before, literally before March 15th when Denkun came out, and it's dropped by a full order of magnitude. So the median L2 to L2 bridge size is now $50. We actually have consumer applications, people using L2s to do real things, which I think is super cool. Okay, that's me, Hal2001 on Twitter. Thank you guys very much, appreciate it.
All right. Last talk before lunch, Bo from Polymer Labs.
Hello? Hey everyone, my name is Bo. I'm here to talk about Polymer as the network layer for interoperability. Before I get started, this is my 3rd Modular Summit now. It's good to be back. Thank you everyone for listening in to this talk, and thank you for the hosts and co-hosts for putting together this event. The goal of this talk is to motivate a higher level understanding of what virtually networked or interoperable blockchains could look like. A little about myself. I'm a technical co-founder at Polymer, where we're working on initially bringing IBC to different L2s on Ethereum as an L2. I wanted to start with a few definitions. On the internet today, we have clusters of devices connected to routers forming local area networks, or LANs, and these local area networks are then connected to each other over a wide area network, or a WAN. LANs form clusters of intranets, while WANs span large geographies forming the internet. WAN protocols require or operate over more than 2 degrees of physical distance or separation, and LAN protocols operate with 2 degrees or less of physical distance or separation. On the verifiable internet, or Web3, we have layer 2s connected to layer 1s, forming clusters of intranets or virtual LANs, which are connected to one another over a virtual wide area network, or WAN. Once again, these virtual WANs protocols operate over 2 degrees or more of virtual distance, while virtual LAN protocols operate with less than 2 degrees of virtual distance or separation. So now that we have some definitions down, I wanted to take a look at history and see if we can find some inspiration there. The internet was born in the late 60s with the arrival of ARPANET. The first message was sent between 2 computers on the ARPANET network in '69, the first email was sent in '71, and the foundational concepts for TCP/IP were introduced in a paper called A Protocol for Packet Network Intercommunication. In the diagrams above and in the drawing, we can see what the early ARPANET looked like and how it grew over the years. Following ARPANET demonstrating the power of connectivity for horizontally scalable network computers, we saw businesses adopt these LAN protocol technologies in the 70s and 80s due to the rise in business use of various devices, electronic devices such as computers, printers. It's important to note that this is not a comprehensive list of all of the LAN protocols that arose during that time. But the important thing to note is that a lot of these companies decided to create their own LAN standards or protocols instead of initially adopting a universal one such as TCP/IP. Additionally, these LAN protocols could technically work over a wide area network, but they were used primarily in a LAN setting due to poorer scalability, efficiency, routing, and security than their WAN counterparts. The modern internet was born in '83, when ARPANET adopted TCP/IP. In '84, the OSI model and protocol suite are officially published. In '85, NSFNet adopts TCP/IP from inception. And by the late '80s, TCP/IP sees growing market share at roughly 70 to 80% adoption. X25 comes in second at 10 to 15% adoption. And while OSI protocol did not see meaningful practical adoption, it was influential in its conceptual concepts and theoretical concepts. In fact, the OSI model today is still used to describe networking architecture. Let's draw some parallels between the early internet and the early verifiable internet. The verifiable internet could be said to have been born in March of '21 with the launch of IBC and the Cosmos. In the same month, the first IBC transfer was sent between Cosmos Hub and Osmosis. The IBC network is reminiscent of the early ARPANET network. The major difference being that ARPANET ended up adopting TCP/IP years later, while Cosmos and the IBC network adopted it from inception. And in the diagrams above, you can see the growth of this network over the years. And with the launch of IBC and the Cosmos and the launch of DeFi across many different L1s in 2020 and 2021, this motivated the need for virtually networked or interoperable blockchains. And starting in 2021, we start to see the launch of many different interoperability protocols, which formed various intranets. These protocols, similar to their predecessors in the 70s and 80s, ended up creating their own LAN standards and for their network devices. Many of these interoperability providers and layer 2 ecosystems ended up creating their own virtual LAN standards and protocols instead of adopting a universal one like IBC from inception. These protocols all require less than or equal to 2 degrees of virtual distance or separation to work. Currently, the verifiable internet is in the process of moving on to a modern phase involving virtual WANs. IBC is the first interop protocol to transition to a virtual WAN. In September of 2023, Polymer's multi-hop channel spec is officially merged into the IBC specification, And in March of 2024, the first multi-hop IBC channels are created on Polymer's testnet across various L2s on Ethereum as a demonstration of WAN properties. And currently, the multi-hop IBC channel implementation is in the process of being upstreamed to the reference IBC implementation in Go. So why do we need virtual WANs? Are virtual LANs not enough? There's 3 key problems motivating the need for virtual WANs. We have a rapid pace of growth in both the number and size of virtual LANs or intranets. We have scalability issues with the architectural model of existing virtual LANs, such as point-to-point protocols or hub-and-spoke protocols. We also have verifiability issues in the routing over short and long virtual distances. Intranets, intranets, intranets. In the diagram above, we can see that each layer 2 ecosystem and each shared sequencer forms an intranet. And both the number and size of these intranets are growing at a rapid clip. If we zoom out, we can see that this rapid pace of growth extends beyond just Ethereum and its layer 2s and shared sequencers. We can see that third-party interoperability protocols overlay their own intranets on top of existing blockchains. Additionally, we see that competing settlement layers also create their own intranets. Besides the rapid pace of growth, we can see that we have scaling issues with existing virtual LAN protocol architectures. Point-to-point systems, or P2P systems, require a virtual distance of 1 or direct connectivity to work. These scale poorly in the number of connected chains, or n squared in the number of connections, or increased interoperability bandwidth required. Hub-and-spoke solutions represent the other most popular category of interop protocols today. These require a virtual distance of 2, or 1 hop connectivity to work. While this scales better than point-to-point systems in the number of connected chains, the hub then becomes a bottleneck for interoperability bandwidth. This solution is also suboptimal for connecting modular rollups within existing L2 ecosystems, or intranets. In addition to the scalability problem, we also have a verifiability problem. A string chain identifier is not meaningful as an identifier for source chain and destination chain identity. This is not uniquely enforceable on-chain. And to motivate this problem, we've included a diagram in the slide. So we start on Ethereum, emitting a message intended for Solana. A malicious relayer then picks up this message and sends it instead to Monad and Berachain. Neither Monad or Berachain have the ability to uniquely enforce that the message was only sent once from the proper source destination to the intended destination. This means that you have to rely on trusted third parties and off-chain coordination or off-chain routing, making it extremely difficult, if not impossible, to decentralize the relayer set of an interoperability protocol today. So how do we build this virtual WAN? Let's use IBC building blocks. IBC connections help establish the virtual topology of a virtual WAN. Connection IDs can uniquely identify a connected chain. A pair of connection IDs can form an IBC connection, and connection IDs are enforceable on-chain. This verifiably enables compressed data flow over the network. IBC channels express application layer connectivity over a virtual topology, or virtual WAN. Channel IDs uniquely identify an application in the network, and a pair of channel IDs forms an IBC channel. Channels can then be established over any number of connection hops or any virtual distance. This also allows for optimized interop bandwidth to flow by leveraging compressed connection-level data flow. Polymer then leverages these IBC building blocks to create a virtual WAN over the virtual LANs on Ethereum. A Polymer hub can be deployed and run within each intranet on Ethereum, sharing the settlement infrastructure with its connected peers. Multiple Polymer hubs can then be interconnected together, combining these virtual intranets into a verifiable internet. On-chain is the new online, and on-chain networking is enabling verifiable routing over virtual LANs and WANs. And Polymer is building a scalable on-chain network layer for the on-chain era. Let's build towards a world with infinite connectivity and beyond. Feel free to contact us at our socials, try out our testnet, or you can reach me at 0xshake on Twitter. Thank you.
All right, I believe we are breaking for lunch now. So see you guys in, I think, an hour.
Hello. Hi. Hi. All right. So I think some folks expected a talk from me, but that was a bit of a miscommunication. I have no slides. I have nothing to present. But I am here actually just to introduce the ZK track at the Modular Summit. And this was put together, oh, there's my face. Okay, this was put together actually by the ZKV, which is one of my companies. So I thought that what I might just spend a second doing is describing the 3 projects that I do, just to make them clear, and then maybe talk a little bit about how this program came together. So as I'm listed here, I'm the host of the Zero Knowledge podcast. I've been doing that since 2017. And it wasn't originally called the Zero Knowledge Podcast. It became the Zero Knowledge Podcast, I think, in like January 2018. So yeah, I've been running that a long time. And from there, I do something called the ZK Summit twice a year. And we have ZK Summit 12 coming up in October in Lisbon. So check that out if you've heard of it or if you're into it. Okay, the other project I do is called ZK Hack. And that's an amazing place to learn about ZK if you're just getting into it. It's kind of like an educational hub. We also do hackathons out of that project. So look up zkhack.dev if you're interested. And then the last project I want to mention is ZKV. And ZKV is actually the team that's put this schedule together. ZKV is a validator. We run on 12 networks live, I think, now. We've been around since 2019. And yeah, we're a validator on proof-of-stake networks, but we also invest in ZK topics and teams. We run events, like more network-specific events. We used to have a series called Privacy and Cosmos. I think we've evolved this now. It's ZK and Cosmos, or ZK and the interchain, but the series continues. And last year for Modular Summit, we did also program a track. And so when Yaz asked if we could do another ZK track, I thought that would be great. And that's what you're actually going to be seeing today. So after this, we're going to start with our awesome program. And I think I'll share a little bit about it. So we're going to be starting with Connor, who's going to be sharing a little bit about light nodes everywhere. He's from Celestia Labs. There's actually 2 talks today from the Celestia team. And there's a ZK working group that's been running. Actually, Connor, do you know how long the ZK working group's been around? Like 3 months? And I know we've been part of it, and a lot of it is centered around which proving systems, kind of pretty low level stuff. But this time around on this stage today, we're gonna hear from we're gonna have 2 talks which at least touch on that. And so we're gonna find out a little bit more what's come out of that working group. So I'm excited for that. After that, we're gonna be hearing from Stephen Lee from Risk Zero. There is a small chance there's a bit of a schedule shift, so just just join the stage to see who's exactly speaking there, but we're supposed to see Stephen at that time. After that, we're hearing from Ismail from Lagrange, who's gonna be giving a talk about verifiable databases. Giving a verifiable database to every smart contract. Following that, we have Nebra, which is like a verification aggregation layer. And so, yeah, I just wanted to introduce those talks. If there's something you want to check out, please do come. And then after the break, we have another set of, I think, 4 talks and a panel. Oh yeah, wait, there is a panel also in this block, I almost forgot, which is a private, it's like a, basically it's looking at shielded assets in the modular stack. So if we're used to very transparent systems and things moving around, the Cosmos ecosystem and the interchain ecosystem, but what happens when you add shielded assets? And what does that actually unlock? So there's gonna be a panel looking at that. Cool. So I think I'm almost at time. I think it would be great then to introduce our first speaker actually, Connor from Celestia. Do you wanna join us on stage, Connor?
Hello. Good afternoon, everyone. my name's Connor, and I'm a solutions engineer at Celestia Labs. Most of what my job entails is trying to fill the block space by building integrations with rollups. But also sometimes I get to work on research prototypes in my downtime. And today's talk is eventually going to get to one of those research prototypes that I am working on. But first, we got to talk a little bit about the light node. The light node has been run all over the world. Many different countries, many cities, probably most of the continents, maybe not Antarctica, but all the other ones are pretty believable that they've been run there. And on a bunch of weird embedded devices like the winner of the light node contest who ran this on some weird Android device. I'm not familiar with the Odroid, but it looks cool. It's been run on the Solana phone, and it's been run at Chili's, which is a restaurant that the Europeans in this room would not be able to comprehend. We teach workshops on how to run the light node. Here's Josh showing people how to run the light node at Modular Summit. But I have some bad news. The excitement has to die out if we want to win. It's sad that we have to move on from this early stage of us taking all these pictures and celebrating it so much and showing it everywhere. But once it becomes a boring and ubiquitous thing is when we know we've won. People don't celebrate the calculator app. They don't celebrate the notes app. And that's where we need to go. We need to get to the point where it's something we don't think about, we don't need to celebrate because it's just everywhere. Like the padlock symbol in the web browser, it'll just become a reassuring thing that protects people from attacks they don't know about using cryptography they don't understand. And everyone will take it for granted, which is good. We will have won when we start to take it for granted. Okay, to change the subject a little bit. This is a question that I constantly get asked. Like everywhere I go, online, at conferences, there's always people who are like, what's the incentive to run a light node? You guys need people to run light nodes for the chain. What's the incentive? What do I get for doing this? And I think the misconception comes from all the content we have out there that says the network scales with the number of light nodes, which is pretty true. But people get the idea that it's like, oh, Solana scales by making the nodes bigger, and Celestia scales with the number of light nodes. No, Celestia also scales by making the nodes bigger, but we need more light nodes to do that securely. Anyway, I think that's where the misconception comes from. But I want to talk about why this question drives me so crazy. So when I first started using crypto, the way that everyone used to use it was with this application here. This is Bitcoin Core for Windows, and it's a wallet and a full node. When you want to look at your balance or send and receive Bitcoins, you have to wait for this thing to synchronize. And you can see down on the bottom, it shows you the sync status of the node that's running in the application. And this was by far the main way that everybody used Bitcoin at the time. And so you had everybody running nodes. Not running a node was not really even an option when this was the primary way to use crypto. This app is from 2011. This is a Bitcoin wallet for Android, and we talk about users running light nodes like it's some kind of science fiction, but this is 13 years old. The first ever front end to Ethereum was this thing called Mist, and it's like a web browser thing, and it also ran a full node, and you had to wait for it to synchronize before you could click buttons and interact with Ethereum. One of the first dApps was called Augur, and it didn't have a hosted front end because when the Augur client-side app came out, the idea of a hosted front end was ridiculous. People would laugh if you suggested that. They would say, oh, isn't that centralized? Of course the app needs to be a full node because it's a dApp. Then a little bit later, web wallets came out and they shipped with remote RPCs. And what's really funny is now people ask me what's the incentive to run a node, but if you were on the Ethereum subreddit when MetaMask came out, there were a lot of commenters who were saying, what is this? Where's my node? What happened to the node? Didn't Mist and Augur have full nodes running? What is this? Are we just trusting Joe Lubin? But nodes in end-user software has not completely died out. Privacy-focused apps require them. It's actually not possible to make a wallet for a shielded blockchain without doing this, without syncing the blocks and syncing nullifiers out of the block, or notes out of the blocks and trying to decrypt them. This is a screenshot of YWallet. It's one of the Zcash mobile wallets. This is the Penumbra wallet. It also does the same thing. You can see at the top, it has a worker that syncs blocks in parallel, and it displays this to the user, and there's just no way to do it without it being some sort of node. Additionally, Kepler, which is the main web wallet for Cosmos, it has this place in the settings where you can put in a link to the LCD, the Light Client daemon, and nobody uses this. The devs haven't really spent much time trying to improve the UX of this because, again, what's the incentive? But alas, this guy kind of has a point. The question may drive me crazy, but it still deserves an answer. People aren't going to do something if the benefit of doing it is less than the cost of doing it. If you want anyone to do anything, and I want people to get the full security of blockchains, the benefit of doing it has to exceed the cost of doing it. So we ask, what's the incentive? Maybe we should instead think about it the other way. Maybe the cost is just too high. Maybe the benefit is small, but the cost is too high. If the benefit's small and the cost is zero, you'll do it. You wouldn't walk up a 10-mile hill for a piece of candy, but if I put a piece of candy in your hand, you'd probably accept it. So imagine you have two Plumbuses, and they both are really fast, and they both have really low fees, and they have the same apps and the same liquidity, and otherwise they're completely the same, but one of them has a trust minimized light client. At least it's something. So I started to spend some time thinking about how do we make the node lighter? How do we make it so incredibly light that everybody will take it, and it's just so easy that it doesn't slow anything down, it doesn't waste your bandwidth, it doesn't make your hardware lag, and it's just like this nice little free piece of candy that gives you more security. Lumina.rs is awesome. This is the demo that is at Modular Summit, and everybody's trying it out, and you can check it out and get an NFT. It's really dope, but it still takes some time to sync. You still have to actually decide to do it. It's not so light that you don't even have to think about it. So it's great that we have this WASM light client that runs in the browser now. Big improvement over Modular Summit last year, where we didn't have a cool demo like this. But I still want it to be lighter. I still want it to sync instantly. And I want it to be just completely effortless, as if I was just putting a piece of candy in your hand. So I started to think about what's the state of the art for really light, really fast syncing light clients. There's this idea that's a few years old now, where you can use recursive ZK proofs to sync the chain. I believe the first place this came up was Plumo by Celo, where every time there's a new block header, they create a recursive proof of all the previous headers, and you can just verify one proof to sync the whole chain. And then Mina took it even further, where they also wrapped up the execution into that as well. So it's not just a consensus light client, it's also recursively verifying the whole consensus and execution history of the chain. And so I built a prototype of that for Celestia. On my GitHub right now, you can find the Celestia recursive sync repo, and this uses SP1 to just verify tendermint and produce a proof, and then also verify the proof from the last header. And if you're in the SP1 chat, you probably saw me begging for the recursion feature for months so I could do this. As soon as they did, I put it together. But that is not all you need to have a trust minimized light client. The Plumo and the Mina ZK recursion powered light clients don't DA sample. So if you are validating consensus and the state transition function, there still is a way that your light node could get fooled and a way that a full node wouldn't be able to be fooled, which is data withholding. And we want to make these things good. We want these things to be properly trust minimized. If you download a Celestia header like this, they're about 61 kilobytes. And if you want to sample the last 2 weeks, you need to have 2 weeks worth of these headers, which is pretty big. That's 879 megabytes, which is 30 to 40 minutes of TikTok usage. And that's not even counting the samples and the sample Merkle proofs. So 30 to 40 minutes of TikTok usage on a bandwidth equivalent on your device, that seems a little bit like not enough, like I'm handing you the piece of candy. That sounds like we're getting to the territory of this is a little bit too clunky to be everywhere. But there's tricks you can do to lower that, and we're going to get into that. So once you can trust a recent header, for example, maybe you're using the recursive ZK proof that I am building, you can sync the rest of the headers backwards. So instead of checking all the signatures, you can just look at the hash of the previous and the hash of the previous and so on. The Comet BFT already does this, and there's also it's also a initiative from the node team, the Celestia node team. This is what a header looks like. It has a bunch of fields in it. Quite a few. You have the consensus hash, next validator's hash, state root, and so on. It's pretty big. These are the things that are, well, along with the signature data, these are the things that are 60 kilobytes-ish. But if you're doing backwards sync, you don't need all that data. You can just look at the hash of the header, the last block ID, which is the hash of the previous, the data root, because you need that to authenticate the samples, as well as verify proofs about rollups. And the tendermint block hash is actually a Merkle proof of the fields in the header. So you just provide Merkle proofs to the 2 fields that we care about, and you can reduce the size by 99%. Which is great. So it's not going to be 800 megabytes, which is 30 to 40 minutes of TikTok usage. It's going to be, you can cut that down by 99%. You still have the samples and the sample Merkle proofs, so it's not going to be quite 99%, but we're probably, especially if you combine it with something like gzip or some other compression algorithm, you can probably get this a lot lower than 30 to 40 minutes of TikTok usage, probably in the single-digit minutes, like maybe less than 10 minutes of TikTok usage, which is much closer to this being completely effortless. Going back to how the recursive sync light client would work, right now, the proving time that I benchmarked on my laptop is 25 minutes, which is a lot slower than the Celestia block time, which is 12 seconds. So you would worry that the proofs would not be able to keep up with the blocks, which is a concern. This is currently solved in the repo by leveraging Comet BFT skipping verification. So just like how the IBC on-chain tendermint light clients allow you to relay headers and skip some of the ones in between by using this heuristic where they say that as long as the validator set doesn't change by 1/3 of stake, you can safely assume that it's legit. Although it does have a few different attacks if you're using skipping verification than a regular one, which you can read about in this article by Anton called Different Types of Evidence Entenderment, where he outlines the different attack vectors against skipping verification versus going one by one. So ideally, we wouldn't have to do that optimization to let the proofs keep up with the blocks. At the moment, that's what I've built. But theoretically, there's a cool way that you can keep up with the chain even though the proof time is slower, which is this. You can use a folding scheme. So the proof time might be slower than one block, but if you're using some sort of proof system that supports folding, you can accumulate a witness of the Tendermint circuit every time there's a new block, and then prove as fast as the proving time without the actual witness that you're proving falling behind with the chain. And there's actually like a pretty good stack, which is pretty mature and ready for this exact thing to be built today. The Proto-Galaxy folding scheme is the state of the art. It's implemented in Berettenberg, and then Noir language exists as a front end for that. So this is a cool thing someone could build if you are in need of a hackathon project. And that's about it. That's all for my talk.
Thanks, Connor, for that. That was great. Some good puns in there. Next up, we have Stephen Lee from Risk Zero, who's going to talk about scaling between the layers.
Oh yeah, there you go. Cool. Hey everyone, my name is Steven. I work at Risk Zero, and today I wanted to talk about ZK scaling between the layers. So first of all, an overview of kind of what scaling looks like today. We're kind of stuck, right? I think in the past decade, we've made a lot of progress. We've gone from Ethereum and EVM with smart contracts to Solana and SVM and more TPS. We've built out rollups like Optimism, Arbitrum, and then in the past year and over the next year, we're seeing like this parallel VM sort of concept with Aptos, Monad, MegaETH, and all those teams. But for all practical purposes, the DevX here still kind of sucks. Developers need to build in EVM and SVM, which despite people's beliefs here, kind of sucks compared to Python. They need to think about block times, finality, consensus, all these things that traditionally, if I'm a developer in Fang, I don't need to think about. And this kind of boils down to the simple fact that blockchains are limited in functionality and performance due to consensus. There's only so much data you can derive consensus around with a set of validators, and this is simply due to the limitations of networking and physics. And what this means is we actually have to do quite a lot of compromises with our blockchain design, and we're just trying to cram as much performance as possible into the limitations that basically we have with networking. So we actually think there's a possible way to close this gap. And really, the main solution here might be using ZK. So the idea I kind of want to talk through today is this idea of a ZK coprocessor. I think we frequently hear the term thrown around, but like what exactly is a coprocessor? To figure that out, I went on Google and searched up what is a coprocessor. A coprocessor is a microprocessor designed to supplement the capabilities of a primary processor. That doesn't really tell us much, but we can make some assumptions here, right? The primary processor in this case might be Ethereum or any base layer or settlement layer. And then how have we been supplementing the capabilities of Ethereum? That has been with rollups, right? So using this definition, I think we can make a somewhat argument that rollups are co-processors as they supplement the performance and functionality of Ethereum. So a new way I kind of want us to think about co-processors is that they are a generalization of the larger scaling frameworks that we adopt. Now, this includes rollups, this includes plasmas and validiums, but all of these concepts are things that were developed before ZK was really like proliferated in protocol design. So what else have we not explored? I think the question I kind of wanted to ask is, can we build a coprocessor without a blockchain? Like, why are we trying to scale blockchains by building other blockchains on top of them? As they still have the limitations of consensus, right? So if we're able to build a coprocessor without a blockchain, it frees the developer from EVM, SVM, MoveVM, etc. It lets them develop without thinking about gas and finality and block times. And most importantly, it lets them build like normal. It lets them build programs like normal, which I think is always the end goal here. So one way we can think about building coprocessors without blockchains is to use ZK, right? ZK allows us to verify the validity of compute without any consensus. You don't need a bunch of validators to agree on the transaction's validity. All you need is a single proof of correctness. So in turn, you can basically use these verifiable off-chain ZK programs as coprocessors. And these programs are written in 100% native Rust. They have unlimited compute with an asterisk, of course, but at its core, it's just a program. It's just the same Rust program that you wrote in college. It doesn't have to deal with any of the complexities that come with on-chain development. So, like, what does this mean in practice, right? Going back to the title of this talk, here are the layers, and here is how we've done development so far, right? You deploy Uniswap on Ethereum, and if you want to deploy it on another chain, you need to redeploy all the contracts. For all practical purposes, the Uniswap on Optimism and the Uniswap on Ethereum are separate siloed applications, right? There's really minimal interoperability, composability between them. It's just two applications deployed in two different areas. But what if we can put it between the chains, right? What if we move the applications off of the chains and stick them somewhere in between? The idea we're kind of thinking about now is, can we take the core compute that Uniswap, for example, uses, that is the swapping logic, the liquidity pool logic, put it in a ZK VM guest program, so that's your ZK coprocessor, and then call it from any chain. So a user from Ethereum or Optimism can request a swap. They'll send these inputs to the coprocessor program, which will actually do the compute, and then the resulting response will be submitted on-chain, where the state balances will update. And this isn't just restricted to like Ethereum and Optimism, right? We can go for chains like Polygon and also go for things that aren't even EVM, like Solana. In all these cases, users can request compute, request the swap, and the ZK coprocessor will do the math and return it back on chain for the state change. What this might look like in more detail is like, take for example, you have account balances A equals 1 and B equals 1, and you're trying to do the math problem, A plus B equals C. Traditionally, you need to submit a transaction on Ethereum, which goes into the mempool, and the validators will agree on it, and then they'll give you a response. But that takes a lot of gas. And if this was a really complex math problem, it'd be really expensive. Instead, the user will submit all these account balances directly to the coprocessor, and this is fully off-chain, like via a REST API. The coprocessor does the math, and then the coprocessor will return the result of this math, as well as the proof attesting to the validity of this math, onto Ethereum. And then Ethereum can conduct the state change. And the real key here is Ethereum never had to do the math, right? It just proves, it just trusts the verifier proof, trusts the ZK proof by verifying it, and never has to spend the gas to do the computation itself. So two real-world examples that we've been working with teams to build out. In the first case, We've been working with order book that thought about building an app chain, right? But app chains kind of suck, and that might be a little controversial here, but they kind of do. They have low liquidity, they have poor interoperability. The UX is totally unintuitive because it requires bridging and like swapping networks. There's long latency because most app chains still have 1 to 2 second block times, which for the sake of an order book is basically not that useful. And they have a huge developer lift. There's multiple teams with millions of dollars of funding that have to go into an app chain, modify the validator logic, modify the consensus to try to push the TPS as high as possible. And there's a lot of projects, trying to do this. But what if we don't use an app chain? What if we don't use a blockchain to run the order book itself? What if we run the order book fully off-chain on a centralized server? The order book itself looks just like Binance and Coinbase, and it runs with sub-second latencies. So the users can send bids, send asks, they can interact with the order book in the same interface they would use to interact with Coinbase. But the real difference here and how it's connected back on-chain is all the bids and asks, as well as the order matching engine and the liquidation engine, are passed through the ZK VM. Subsequently, you're able to basically generate a lagging validity proof of the validity of the order book's execution, and then you're able to post this proof on Ethereum, which lets you update the state balances and allows you to finally withdraw your assets. So at least for the user standpoint, as I mentioned before, the bids and asks are totally free. The latency is sub-second. So they're just trading on any other exchange. And the real difference here is with this proof, they're able to do this directly on-chain, directly via their MetaMask. And at least for this experience, you're able to tap into like Ethereum layer 1 liquidity and deal with none of the issues that app chains normally have to deal with. And with this design, we've actually been working with Hashflow to build this out into a full product. Another problem that folks face is like rollups don't really scale, right? Like a Uniswap V2 swap costs about $1 on Ethereum, which I checked yesterday, so it does fluctuate, and it costs about 5 cents on Optimism and Arbitrum. These are good numbers, but they're not great, and with the performant applications people are trying to build, the gas fees are still kind of high. And then rollups aren't really fast. As I mentioned before, like soft finality can take more than a second, and hard finality, at least for optimistic rollups, takes about 7 days. So we've actually been working with Automata, which is building out like a TE-based coprocessor. And as part of that, they need to verify these SGX attestations on-chain. They implemented this verification logic in EVM, and it takes 8 million gas. And there's basically nothing on the market today where you can run an 8 million gas smart contract in a reasonable cost. No rollups can do that. Maybe something in the future, but they really want to keep the costs like sub-cents. So they came to the coprocessor, right? And instead of running all of this verification logic on-chain, they ran it in a ZK VM. And currently the cost to prove that is under 5 cents, and obviously we're working very hard to drop that number down. And then you take that proof and you can verify that on-chain, which costs only 20K gas with aggregation, or 250K gas, worst case scenario, without any sort of aggregation. So the really exciting thing about all of this is building coprocessors is actually quite easy. Just in the past year, I think ZK VMs have become really popular and really functional and performant. And most importantly, they let you build circuits without any cryptography, without any math skills, but in 100% native Rust. When you build a coprocessor, and at least with our Foundry template, you really need to just work with 3 components. You need to touch your existing smart contract, which sends the inputs and handles the callback. You need to work with a Rust-based ZKVM program, which is where you put the majority of your compute. And then there's a Rust-based serialization file, which basically translates the on-chain data structures to the Rust data structures. But we're actively looking to abstract away that part. But the key here is you don't need to build out all of the components that traditional rollups need, right? You can get really performant custom compute without needing to touch like validator logic, block building, building out a custom VM, RPC, modifying consensus. You don't need to touch any of that in order to scale your application. And we think that will really make this a lot more accessible for the average application developer. So when, I thought about like the impact of this on Web3, we broke it down into like the three main areas that we feel like people are pushing on, right? That being scaling, interoperability, and accessibility. On the scaling side, ZK is getting really fast, right? The cost to prove an Ethereum transaction in the ZK VM is already sub-cent, and it was probably 10 cents just a year ago. And I think by the end of the year, we're gonna get it below 0.1 of a cent. And at least across the standard cryptographic primitives that most developers would use, the RISC-0 ZKVM, and I mean, just generally the rest of the industry as a whole has really been pushing these costs, these proving times, all the way down. So more and more, as we look towards the future, you'll really be able to prove everything and anything. Also, the coprocessor basically allows you to build a single application as a Rust program, and you can call this from any chain, right? So instead of having to refactor or rebuild your program to be run on like Optimism and Solana, you can run it once and build it once in Rust, and users can then call your coprocessor from any chain, right? Whether it be Ethereum or Solana or Optimism, maybe Bitcoin in the future as they keep on pushing BitVM and things like that. All of these are seamlessly connected via ZK. You don't need to think about cross-chain message passing. You don't need to think about bridging or anything like that, because like for the order book, for example, the state, the count balances all live on the coprocessor itself. The state doesn't have to actually live on each individual chain. You don't have to sync all of that up. Everything lives on the coprocessor. And finally, with regards to accessibility, and this is personally what I'm most excited about, building a ZK coprocessor is really accessible from both the DevX side of things and the UX side of things. For the developer, you're just building in Rust. It's 100% native Rust. You have native Rust crates, and you can fork any sort of Rust repo. It doesn't have to be some Rust code that was optimized for Web3, just literally anything. And then for the user side of things, ZK allows us to connect the Web2 interfaces with Web3. Things like Google login, Apple login, even things like KYC. These will actually make it so that interfaces to interact with Web3 applications can be trustlessly bridged with Web2. That is generally, I think, how we'll bring more developers and more users onto crypto. So I think in conclusion, innovations in the ZK space are enabling new architectures, solutions, and possibilities. I really challenge developers to think about the problems they're facing with their application development and maybe understand that not everything needs to be on-chain. Thanks to ZK and verifiability, we can do compute without the constraints of consensus and blockchains and networking. Kind of a funny way I thought about saying this is I want us to reject modernity, reject EVM, reject Solidity, and reject all that on-chain development, and embrace tradition, right? The tradition of Web2 development, the tradition of development that led you to have all those apps on your phones with millions and millions of users. And thanks to ZK, we can basically bridge that gap, right? Bridge the gap between this traditional development and Web3. Cool, thank you.
Thanks, Stephen. Very interesting insights into ZK coprocessors. Next up, we have Ismail from Lagrange, who's going to talk about verifiable databases for smart contracts.
Good afternoon, everyone. My name is Ismail. I'm one of the co-founders of Lagrange Labs. The title of our talk today is Giving a Verifiable Database to Every Smart Contract. So, at a high level, what Lagrange focuses on is ZK coprocessing. It's a term that we've heard a lot of people talk about, but is often poorly defined. In our view, and put simply, the ZK coprocessing is a paradigm to scale blockchains. For the last 10 years, we've been asking the very simple question: how do we scale the computation that we can run on major chains? We've looked at solutions ranging from building Alt-L1s, where we would selectively reduce the security or the liveness guarantees to gain speed. We've scaled horizontally, and we've scaled vertically with rollups, fragmenting state and liquidity and all the accompanying problems that has created. But at the core, ZK coprocessing is a new approach. It's an approach predicated on using off-chain verifiable compute to scale the types of computation an existing smart contract on an existing chain can access. And this is something that we're very excited about, because what it means is that existing DeFi protocols and existing applications on Ethereum, EVM-compatible L2s, and all of the modular execution spaces that are now being developed have access to more scale without ever having to move. So how does Lagrange intend to build this? Well, what we have is a proving network, a network of nodes run by some of the top operators in the space, ranging from Coinbase to OKX to Kraken, whose responsibility it is to generate zero-knowledge proofs in a parallel fashion that we can deliver back on-chain to smart contracts and applications that have requested them. We recently deployed our prover network in production and have so far generated approximately 10,000 queries per week, a total of about 2 million proofs overall, and have scaled quite a bit the computation that we can leverage and we can deliver to Ethereum. And so how do we do this? Well, very simply, we have a network and an architecture with two core components. We have a gateway that allows on-chain applications to request proofs, and a series of provers that, no surprise, compute the proofs. An on-chain application, think a smart contract on Ethereum, think Gearbox, Curve, or a major NFT project that wants to leverage a more intensive form of compute, can simply emit an event and request that proof from our network and verify it back in their contract. So put simply, if they want to do something they can't do on Ethereum today, they don't have to redeploy elsewhere. They can simply request a proof of that computation that they can verify. And so we've heard a few teams today talk about different approaches to ZK coprocessing. We have what I like to call historical data-focused approaches. We have the ZK VM Rust-based approaches. But what Lagrange has, as is evident from the title of this talk, is a data-centric approach. What we focus on is verifiable SQL queries. Queries that you can define over blockchain data the same way you define them over a database and verify within your contract. So the asymptotics of this, since we're obviously specializing in a data-centric approach, are highly performant for accessing large numbers of storage slots, receipt tree data, or transactions. We have about 30 seconds in our asymptotics for accessing 1 million storage slots, and the concrete performance right now is about 1:20 in the current version for computing queries, simple select queries, of course, over 1 million storage slots. So how do we do this? What does Lagrange do to prove general purpose SQL for smart contracts? Well, this is based on some new work that our team recently put out that we're calling Perseus, or from a more technical standpoint, verifiable SQL via decomposition. I like to refer to this as a ZKVM, but for SQL. What we do is we take a statement, a SQL statement, and we parse that into 10 to 20 operations. For example, the select query is parsed into a create, range, project, sort, arithmetic operations that we then can prove in parallel over the data and recursively concatenate back together. What this means is the computation you can define is computation over data in a language designed to support computation and queries over data. You don't have to think about how do I compute over millions of on-chain storage slots in in Solidity. You can simply define them in SQL. And this is what we think of as a fundamental innovation. It's the Dune analytics, but verifiable. And we do this through a number of novel tricks in cryptography that we've been able to pioneer. The first and the principal one being RECL trees, a vector commitment that supports updatability. And so when we think of large computation over data, specifically blockchain data, the concept of updatability is very pertinent. Put simply, the majority of data that every query is touching doesn't actually change. The blockchain data, the state at block B is ostensibly almost identical to the state at block B+1, except for the transactions that executed at B+1. So that means that query-based computation touches very much the same data. So the concept of taking a proof and then updating it lets us scale. And so when we think through the developer's interaction with our coprocessor, we generally think of this as two stages. And you can think of this as two stages on chain, or the same two stages that you would do in Web 2. What you do is you define the data frame or the data on chain that you're interested in, how you want your table to be structured, what you want to be in it, what are the columns, over what block interval, etc. And then you define queries. Queries that you can run from your smart contract and prove and verify back on chain. And so by thinking about it in these two steps, you can really now define your computation in a way that you can think of as a database for your smart contract. And so once you define the storage slots that you care about, maybe the receipts you care about or the transactions you care about, we enter a phase we call pre-processing. Pre-processing, very simply, is taking blockchain data and proving that a large amount of the elements contained within it exist now in an optimized structure. So for example, take all of the data from your contract from block B to B minus K, let's say it's a range of 100,000 blocks or 1 million blocks, and develop a new ZK-optimized, friendly database that is provably equivalent. Provably equivalent is a key term here. What this means is that the data contained in that new structure is identical and is a proof that it is identical to the data on Ethereum or any EVM-compatible chain you might be working on. Once you prove that this new structure is equivalent, and a new optimized structure fast to compute over, we are able to structure computation over it. This is what we call the query phase. The query phase is where your contract can emit an event, our network can receive the event, and we can deliver it back on chain. So the developer flow, very simply, has two steps. First being indexing, second being querying. So from your contract, you can make a simple call to our registry contract to request that your contract is indexed and that there's a database that is created and a proof of the correctness of that database that is created. And once you make this call, you obviously have to fund it, and we will start processing, our network will start processing that contract. Then, whenever you want, you can emit an event and say, hey, answer some query for me over this data that I requested you process. Answer for me, who are the top users who've interacted with my contract over the last 90 days? Tell me how many rewards has user X accumulated between two blocks. Really anything that you would ask in Dune or ask your database, we let you do it from your contract. And we let you do it verifiably. So end-to-end flow can be done on one chain or across multiple chains. All you need to verify these proofs is a block header. So blockchain 1 can simply define its contract, define its database, and the coprocessor can then answer queries over it, as long as the destination chain has a block header of the source chain. So it works single chain using the pre-deploys block.header, or it works multiple cross-chain for some chains like OP when you have access to pre-compiles or pre-deploys to let you access L1 routes. So effectively, you have now a modular and a composable, verifiable database that your contract can request proofs from whenever it needs. So where is this deployed now? Who's using it? The important questions. We are deployed across 4 chains, a number of L2s and Ethereum. And so far, we've integrated with many of the top DeFi protocols, some soon to be announced, and have served 83,000 queries in the last 60 days. We're run by some of the top operators in the space and have integrated with many of the top ecosystems to be able to deliver this functionality in a differentiated way to their users. So, to make it concrete, I want to touch briefly on 2 use cases. The first being reward contracts. Believe it or not, reward contracts are a primitive and an important one within DeFi. You can think of the Sushi Master Chef standards, and you can think of the points programs done by many LRTs. All of these define your reward based on a simple condition. If you've held asset X and provisioned and deposited liquidity into asset X for a period of time, you can receive a reward proportionate to that amount of time. Another common condition is simply, have you provided a concentrated liquidity position in UniV3 continuously over some time? Well, that is something that is intuitive to compute off-chain, intensive to compute on-chain. Why? Because your contract can't actually access this data. 10,000 blocks, 20,000 blocks, reading a single storage slot is 2,100 gas. So accessing that data over a continuous and extended interval is infeasible. So the standards that exist take liberties, some of them cut corners, some of them do it off-chain, none of them do it extensively and securely. With our mechanism, already today in production, you can do this. Now, another very major use case that we target is NFTs. Believe it or not, I like NFTs. And I like to think that NFTs are a core part of crypto culture. But one of the problems is you can't really do much with them, right? You have an NFT on-chain, but how can another on-chain application that wants to give you a differentiated experience because of your ownership of that NFT do anything? How do I reward you with a new token or a new badge if you never sell your NFT, if you hold it since mint? The data is encoded in a mapping, but you can't really query this mapping on-chain. You can look at it off-chain and try to build experiences off-chain, but your on-chain contracts can't really do much. And we've seen now that many of the top NFT projects are launching their own chains and are trying to take their strong IP and build some differentiated experiences using it. But they can't necessarily do this in a way that is trustless, that is verifiable, and that doesn't create agency issues over the issuance of their assets and rewards. With co-processing, we can answer this very simply. You can ask a query, has user X owned a pudgy between a range of blocks? Has user Y owned an Azuki that matches some set of conditions? Which lets projects that are interesting and consumer-facing actually build new features that people want to use. So what's next for us? How can you get involved, and what would I suggest that people here do? So Lagrange launched our prover network very recently in production. We are adding a number of new features over the next 60 days that we expect to really push the bounds of the types of computation and, more importantly, the scale of computation that can be accessed on-chain. We call this next launch our V1, and we really expect that some of the launch partners we have coming with V1 will define what it is to build within this new paradigm. Projects who I hope many of you here are aware of, and who I think will start legitimizing and start bringing eyeballs to what it is to actually build with this paradigm. So I recommend anyone here go on our GitHub, play with the code, run some queries, go on our docs and think of what you can build. And if you have any questions, please contact me, and our team would love to engage with you. Thank you so much.
Thanks, Ismail. Very interesting. Next up, we have Shumo from Nebra, who's going to talk about Nebra.
Hello, how's everyone's afternoon? Good? Great. Okay, before I start my talk, how many of you have written a ZK circuit? Okay, great. And how many of you have written Solidity? Great, great. Let's start the talk. Today I'm going to show you Nebra UPA. The way we view it is that we think this is a ZK broadband that unlocks scaling, privacy, and interoperability. So this is the talk outline. So first I will tell you what is UPA, which is a universal proof aggregator. First I will motivate a little bit why we need this and what is UPA. And it's becoming obvious why UPA is good for both privacy and scaling. And next, I'm going to show you a little bit more about why UPA is also important for interoperability. So first, why UPA? So this is a ZK supply chain at the current stage of blockchain industry. So from the high level, you can think of there is a user, and user will provide some sort of data to the prover, and then the prover will generate the proof, and the proof is getting verified. So this is a very simplistic picture of the ZK supply chain. And of course, the most suitable place to deploy a ZKP verifier is on-chain, because blockchain is kind of like a public permissionless censorship-resistant ledger can give you the truth. So, and then there are two kind of ZKP application scheme. The first is privacy-preserving applications. For example, like private on-chain voting, private token transfer, for example, like a Tornado Cash, or privacy-preserving decentralized identities such as WorldCoin. So in these privacy-preserving applications, the user generates proof on the client side for privacy reasons, and then basically both the user and the prover have to be on the same side or same devices. It could be in your browser, it could be in your phone. And then the user or the client send the proof to the verifier. So the second kind of solution is the scaling solutions, where the user still provide the data, but the prover is run on some beefy machines in Amazon or whatever cloud providers, and then the proof is getting verified on-chain. So you can see in both scenarios, the common interfaces is this like a verifier interface, where the proof is sending on-chain and is getting verified on a blockchain, let's say Ethereum. So that's why we're building UPA. So in our view, we think proofs is going to be the future of all the blockchains. And then it's crucial to scale the proof processing power of all blockchains. We want to upgrade the blockchains from a narrowband ZK to a broadband ZK. To precisely state the problem, you can see verification cost is one of the biggest remaining problems of having more and more proofs. So this is a cost in terms of dollars verify a single proof on chain. For example, today, verify a gross 16 proof costs more than $20, and verify a Hilo 2 KZG proof costs more than $30. And if you want to verify a Stark proof, it will cost you hopping more than $100. So clearly, this is not the future we want to live in. And like Vitalik used to ask this question, do you want to pay $20 to add privacy for your transaction, of buying a coffee? And clearly not, right? Because the coffee itself, in most places, is not worth more than $20. So that's why we're building UPA. So what is UPA? So UPA stands for Universal Proof Aggregator. And there are 3 keywords, right? Universal means these proofs are coming from different circuits. So for example, proof can come from ZK EVM, like Squirrel, Polygon, or could come from coprocessors like Lagrange, where Ishmael just showed you before this talk, or it can come from a privacy-preserving applications such as the WorldCoin. We don't care. So Nibra UPA can aggregate all this proof to a single aggregated proof. And this single aggregated proof is a recursive ZKP proof, basically states that all these previous proofs in these batches, in this current batch, are validated. So now, instead of putting all these different proofs on chain, you just need to prove this single aggregated proof on chain. So all the cost is getting amortized. And essentially, we're building a shared economy of proof processing without hurting decentralization. So if you think about that, basically the more proof, the better economy. Because the more proof you can put a single batch, the better cost you can get. So this is a high-level overview and the properties of the protocol. First, UPA protocol is deployed on-chain, which means the UPA will be deployed on Ethereum, Mainnet, and all the major L2s. So this is a permissionless protocol. The sole interface developer or users need to interact with us is a smart contract. So in the sense that, like, you don't need to sign a contract with us. We are permissionless, can aggregate all the proof you want. And second is a censorship resistant, in the sense that we have a forced inclusion mechanism. So in the sense that we cannot censor you even if we want to. Last but not least, it's going to be progressively decentralizable in the sense that there will be a permissionless way of running the provers so that you can have even better liveness and censorship resistance guarantee. So next, using Nibra UPA is extremely simple. So on the left-hand side is how do you verify a proof today on Ethereum and on all the other blockchains. So you have like proof generation or ZKP client, and this ZKP application client could be, for example, rollup as well. You deploy your own verifier contract on chain, and then you send the proof to your own verifier contract. And using Nibra is almost the same. The only difference here is that you are not using your own verifier contract. You are sending your proof to Nibra UPA. So we actually tried to give the UPA documentation to many, many users. Most of the users finished their protocol integration within 2 days with very, very minimal code changes. So we launched Nibra UPA on testnet about 3 months ago on Sepolia. So the high-level overview of the UPA 1.0 here is that it uses a 2+ layers of recursion using Halo 2 KZG. And we actually have built a pipeline and distributed prover serving architecture to harness the power of this like a ZKP. So this is the underlying distributed system work. So UPA has a 2-layer of aggregation circuit. The first layer we call the UBV. Basically, it's a universal batch verification circuit and a pair with a catch-check circuit, which is used to handle public input. And then both the UBA and catch-check proof is aggregated by the aggregation circuit, and this aggregation circuit will produce a final Halo 2 KZG proof and gonna put it on chain. So here, basically, we are leveraging the parallelization here to improve the latency of the recursive proof generation. So the way we do it is that every single circuit you see in this picture is placed in a GPU machine. And so all these GPU machines are working in parallel in a pipeline way to generate proof so that the latency of generating proof is minimized. So in addition to that, we have a pipeline server farm to overlapping the proving over batches. For example, when the first batch comes, our coordinator will spawn the prover cluster 1. While this prover cluster 1 is still working, if at that time the batch 2 comes, the coordinator will spawn a prover cluster 2. So by overlapping the different batches, we can get the maximum throughput as well. So I'll just highlight a few challenges while building Nibra UPA. So the first and foremost is ZKP engineering. So one of the challenging places here is that how can we build a non-native arithmetics? So basically, if you're doing recursive proving, you are having this disparity between the data sizes of the proof of your input and the proof you are programming in the circuit. So for example, there is a disparity between the finite field sizes. And this causes like a 20x blow up in terms of circle sizes. And we have like many hard works in terms of we call it like a mathematical hacking. Basically, we leverage all this like advanced mathematics, including like a Chinese remainder theorem, like a Montgomery ladders, all these fancy mathematics to build the most performant non-native arithmetic circuit. And second is how do we handle heterogeneous proofs? So for example, in Nibra UPA 1.0, we are supporting 3 major versions of gross-18 proofs with arbitrary size of the public input. And in Nibra UPA 2.0, we will be supporting all the major proof systems incoming. So for us, it's not just about supporting proof systems, it's also about economy. Because the more wider variety of the proof system we support, the more proof we can aggregate as well. And also, like we are deeply careful about how do architecture a system in terms of are we actually using a circuit or we are using a ZK VM. So the short answer here is that circuit is more performant and the VM is more versatile. So in our first generation, we are using a circuit first approach because our observation is that more than 70% of the proof on chain today is just a gross-18 proof, right? So this is the majority of the amount of users we want to support. And we're moving to a VM-based architecture, which means we're actually using both ZK VM and precompiles so that we can achieve best of both worlds in the sense that it's both flexible and performant. So clearly, basically for building the Nibra UPA, our value proposition here is that because we can make ZKP proof 10 times and more cheaper, this is a huge unlock for the entire ZK industry in the sense that for both privacy and scaling applications, like you will be much, much cheaper to use. So for example, for privacy preserving applications, lower the cost of their ZKP proof from $20 to $2 on Ethereum layer 1, and from $2 to 20 cents on all the major L2s is a huge unlock. So you can acquire your users much more cost efficient. And for the infrastructures, for example, if you are running a ZK-based app chain, you are actually paying about like 15K proof, 15K for proof verification per month, every month, and we can down the cost to 1.5K. So next, I'm going to talk a little bit about the UPA for interoperability. The whole idea here is that we can use proof aggregation to bring native interoperability to ROPs. The idea here is that by using proof aggregation, we can make the cross-ROP transaction the first-class citizen and to be part of a settlement. So for example, right, so this is a high-level architecture of how Nibra can bring the native interoperability to all the ROPs. So this is a new development we're building. We call it Nibra OS. So we kind of like a low-key launched that in our own event, Proof Day, about 2 weeks ago. About two days ago. But we will have more information disclosed incoming. So the whole idea here is that first, you can make cross-ROP transactions. Basically, you can think of as the transaction bundles as a first-class citizen. And then users don't send these transaction bundles directly to the rollup. You can send to the coordination module. And the coordination module will basically ask all the rollup sequencers to say, hey, are you going to promise to include these cross-rollup transactions in the next epoch? If everyone said yes, so there is a safety module to generate the inclusion proofs for these transactions. So basically, during the settlement of this rollup state root, the proof aggregation module is going to aggregate both the validity proof from all the different rollups together with this like a meta transaction inclusion proof. So basically, this proof aggregation module can hold all this rollup as a hostage, so that making sure if they committed to include these cross rollup transactions in the next epoch, they have to. Otherwise, their state root is not getting settled. And in the future, we can put more fancy type of intent safety proofs as part of a proof aggregation. So for example, let's say if you not just want to do a cross rollup swap of your asset, you want to having a price guarantee. So for example, you want to swap this Arbitrum OP token with like this ARB token at a certain price guarantees. So we can do that natively in the settlement layer so that you can have safety guarantees without relying, for example, all these like cross-chain liquidity providers. And so this is a high-level picture of how does a proof aggregation can enable interoperability. So here is my claim. I do think native interoperability is an ecosystem-wide unlock. So here, this is a list of the advantages we can have if you have native interoperability. First, it will fix the security leakage of cross-rollup transactions. So it's actually well known today, despite from the L1 to L2 transactions on rollup is secure, all the cross-rollup transactions, because we don't have proof aggregation, it still requires unsafe cross-chain bridges with liquidity providers. And here, most of the times, the liquidity providers are taking the risk of the settlement. So for example, despite optimistic rollup takes 7 days for settlement, right? So as a normal user, you can do your cross-chain transaction very quickly because all this risk is taken by all these liquidity providers. But in some sense, there's no free lunch here. Because these liquidity providers are taking the risk, right? All this risk is priced in with your cross rollup transaction cost. So now, basically, we're saying if you have native interoperability, these security costs will be much, much cheaper for your cross rollup transactions. And second, like I said before, you could have enforceable cross rollup intent, which means for all these cross rollup transactions, you can have native interoperability and also you can have intent safety guarantee, which means you can have user express their preferences of how this transaction getting done, and we as a proof aggregation settlement layer can enforce that. Next is that it will actually provide better developer experiences for both chain abstraction and wallet builders. And like I said before, it will actually provide better capital efficiency for cross-rollup market makers. And also as a result, right, so today, if you are building a new app chain, you have a huge amount of burden of bootstrap liquidities. And now, because you can frictionlessly tapping the cross-chain liquidity by having native interoperability, it will actually give you less liquidity requirement to start a new chain. And next, we do think it can enable new use cases. For example, like a pure asset chains or like a pure DEX chains, like a Unichain, to fix up abstraction leakage. So in general, right, so we think native interoperability means lower user friction and better UX in general. So I would like to conclude my talk here. So to conclude, right, basically I show you what we're building in Nibar UPA and how can we use Nibar UPA to bring, to lower the cost and then to enable better privacy, scalability, and native interoperability. And so we are building this Nibar OS, this native interoperability for all the Ethereum-based ZK rollups, if you want to get a white paper, scan my Telegram. I'm happy to give you the preview of the white paper before we publish that. And with that, thanks a lot. That's the end of my talk. Yeah, thank you.
Thank you very much, Shumo. And actually, do we have any questions for Shumo? Because we're 10 minutes ahead of the schedule, and actually our moderator is on the other side giving a speech. So if you have any questions for Shumo, we're happy to answer them.
Who's running you say you had a scaling mechanism for aggregating the proofs. Who's running that?
So currently we have like a distribution system, like a kind of like a server farm running that. It's so these are run by like 3 major data center, ZK data centers. One is like a Rockway, one is Snarkify, and we're looking for others. So basically it's like a replicated data center. And we're moving to more like a permissionless, like a prover network architecture. But we're probably gonna not building our own prover network. So it's more like a permissionless, permissionless prover architecture, so that all the other people who are running prover network can tap in. Yeah, that's a high level. Yeah, thanks.
Any other questions?
Okay.
Okay,
Cool,
thank you
thanks.
very much.
Yeah.
Okay, so we're going to take a 5-minute break because, like I said, our moderator is on the other stage. So see you back in 5 minutes. 1, 2, 3. Okay. We're coming back. And with a slight change of a program, so we're gonna have a fireside with Henry from Penumbra, and the interviewer is gonna be Connor from Celestia.
Hello? Oh, we haven't started yet. We'll wait till it starts.
All right. These lights are very bright. The hat is a good choice because you can.
Yeah, it helps to see. It's very bright. I'm gonna go grab one.
Yeah, that'd be great.
Yeah.
You've heard about blue check regulation. What about blue cap regulation? Oh dear. What a disaster.
Are we getting started? Okay. Welcome to the Fireside Chat. I'm Connor from Celestia.
I'm Henry from Penumbra, and we are here to shill privacy.
Yep, we're going to relentlessly shill privacy, and we're going to talk about shielded pools and things of that sort. Let's see. Penumbra's on mainnet now. How many days has it been?
I think this is day 7. So at the moment, there's a proposed phased mainnet for Penumbra, and right now we're in phase 0. So there's an initial proposed network, there's validators, there's blocks are being produced, but that network has a lot of the core features that would actually make Penumbra useful disabled. And those can be enabled through on-chain governance votes, but basically this allows there to be a period where there's a bit of a shakeout. So one of the key things that is a little bit different about the Penumbra launch, we have this kind of joke internally of like Penumbra is built different. And you know, there's the funny sense of that, but there's also a very literal sense. None of the infrastructure for the network is being run by any of the entities that develop the software. And that means that there's this kind of like chaos period of seeing how that decentralization happens. A lot of other chains, you know, they'll launch and there will be some like, here's the official RPC, here's the official front end, whatever. And by creating some like official service, you're basically kind of cutting off the opportunity for any of those things to emerge organically through the community. So right now, there's kind of this like messy period of people, you know, deciding to host RPCs and posting those on the forum, and people chasing down URLs and manually typing them in. And as that period kind of comes to a close, we'll be able to see, okay, here are the resources that have come out of the community, and we'll be able to kind of streamline that process and direct users to it. So once that happens, we're anticipating that there will be a governance vote to enable IBC and to enable the DEX. And at that point, the battle station will be fully operational.
Cool. So I tried out the Penumbra CLI, and one thing that I noticed is that, well, there's a few things that I noticed right away. The most obvious first impression of it is that fire emoji warning message that gets printed every time you run it that says, this is dangerous, you're about to lose money, which is, I thought that was pretty cool because...
That was for testnets.
Oh, that was just for testnets. Okay, so on mainnet, you're not about to lose money.
Probably, I mean, it's the same software, right? But when we put that in, like, so part of the Penumbra backstory is that I really wanted to lean into this ethos of like build in public, build in view of the community. I think there's a lot of projects where like they go off, they build a thing, they just like spend all the time in some Slack, and then all of the like tacit knowledge of why all the technical decisions were made is just like locked in some like corporate Slack instance that gets data retented. And there's this kind of like, oh, well, we'll make a thing and then we'll throw it over the wall and then maybe people will run it. And for Penumbra, we took a very different approach. Basically, as soon as we had like one end-to-end transaction flow that kind of worked, we just like yeeted it out and called it a testnet. That was like testnet 1. And then every time there was some catastrophic failure of the testnet, we would like blow the whole thing away and start over. We went through like 75, 78 testnets, I think. And like people would like make fun of us on Twitter being like, oh, just one more Penumbra testnet, bro. But it was a really good forcing function for like, can this software actually be deployed? And in the very early days, it was like like the software was so bad that we wanted to put in a warning of like, we actually do mean it.
Well, I just thought it was like a warning that was saying that you're using cryptocurrency. I thought it was like a very basic warning that was saying like, you're using cryptocurrency. There's an option to reset your directory in here, and you may delete your private key, which is fair. Kind of like how all the web wallets, they all force you to copy your seed phrase, and then they quiz you on your seed phrase because they assume that you're an idiot, which they should because so many people are.
Well, maybe we'll leave the warning in. But yeah, I mean, I think a thing that's pretty cool about it is that, one thing that I'll talk about unprompted is another design decision that we made very, very early on for Penumbra was to not put any keys whatsoever in the full node software. So one problem that happens with privacy chains especially is you have to have some way for each user to manage the state of like, what is the stuff in my wallet? If you imagine you have a private chain, you can't just go and query an RPC to say, what's my account balance? Because by design, that's supposed to be private. And so there's some process that your wallet has to have to synchronize and learn about the state that's relevant to it. And in Zcash, which I previously worked on, this was done by embedding that wallet into the full node. But once that was done, like that became kind of that became the sort of default thing, and it removed a lot of the pressure or the forcing function to really make that work well. And so the Zcash mobile wallet story, or anything other than using a full node, was kind of several years delayed, because there was this thing that kind of worked for the sort of some of the use cases. And one of the things that we did when developing Penumbra was starting from the very beginning of thinking of, there's going to be a client device, and that should be separate from the node. And maybe a user is like querying their own full node because they're running their own node. That's great, good for them. But we want to design a client sync protocol that will actually work without knowledge of all the data that's in a full node. And we ended up co-designing that with the protocol that is on-chain. And effectively, every time we added a new protocol feature, we would also have some explicit modeling of like, okay, and how does this reach all the way out to the client device and then back? We can't just assume like, oh, someone will build an indexer that will fill in all the information after the fact and kind of paper over our protocol design flaws. We really have to have this kind of end-to-end conception of protocol design where like there's a user device that doesn't have access to a full node. What information does that need to have? How does that get synchronized? And how do we make that efficient?
So there are not that many actions that you can take with the CLI. So if you ever use the Osmosis CLI and you go to the transaction subcommand and you look at all the kinds of transactions you can send, there's like 100. And even though Penumbra does a bunch of things, multi-asset shielded pool, DEX, governance, it seems like there's not that many different kinds of transaction types. Is that because you had to intentionally minimize the actions and keep it simple because each action is a circuit?
No, so that is more of an artifact of the CLI. So the way that Penumbra transactions work is each transaction is a bundle of actions that are going to all be applied together or not at all. And you can stack together those actions to accomplish whatever functionality you want. So for example, suppose I want to send you funds. I'm going to make a transaction that will have some spend actions that spend notes that I have, release the value into the transaction, and I'll have an output action to send a note to you, and I'll have an output action for whatever change I have. And so you could classify that as like a send transaction, but that's not really an inherent property of the transaction. That just happens to be like one way that you could assemble the actions. And so the reason that we have sort of relatively fewer things in the CLI is actually just because when we built the CLI, we tried to orient it around like specific things that you might want to do. But there's a bunch of interesting emergent behaviors that you could have if you like manually compose different actions together that are just not exposed. And one really cool example of that is something you can do with the DEX. So Penumbra has a DEX. The model for the DEX is that all of the liquidity positions and the trades that are made against the DEX are public, but you can't see who is doing them because it's just funds come out of the shielded pool, interact with this thing, and then return. And the DEX operates on a batched execution model. So there's not any kind of ordering games for the Penumbra DEX. That part of MEV is just gone. And instead, everything gets executed in a batch in phases. And one kind of interesting emergent behavior that you can get by kind of customizing action stacking is it's actually possible. We didn't explicitly design for this, but it turned out to be the case. You can actually do block-scoped JIT liquidity on Penumbra. And the way that you would do that is you create a transaction where in the same transaction, you have an open position action, and then you have a closed position action that will close the same position that you just opened. And because those two actions are actually going to get queued for execution at the end of the block, the effect of that is that you can create a position that has some fixed price liquidity, and that will be live for exactly that block's DEX execution and then close. So if you want to do, say, like arbitrage against a centralized exchange, you can wait up until however long you think it's going to take you to make all the proofs. That'll be a few hundred milliseconds. You can get a quote from whatever centralized exchange you want, and then you can create a transaction that says, like, I'm going to offer exactly this much liquidity at some spread around that price. And it will auto-close at the end of the block. And so I don't have to worry about, like, is there some MEV game of, like, can I cancel my order fast enough? And I think it's a really interesting example because this behavior was not something that we ever explicitly designed for, but rather it was the kind of composition of a bunch of independent features that we made, like you can compose arbitrary actions, and you have a batched execution model for the DEX. It just kind of worked out. So I think that what we're going to see post-launch, and as there's more and more activity on the chain, is more creative ways to build and structure transactions.
This DEX is super interesting. The fact that it is ordering agnostic is like, this is like something that Ethereum people talk about like it's sci-fi, and it's on mainnet about to be enabled. I wonder, so this 12-second batch auctions, that seems like something that the really fast market makers wouldn't want, but it seems like something maybe the more passive LPs would very much want. What do you think about that?
So for Penumbra, the block time is actually 5 seconds. Oh. So you can submit, you can locally in your browser prove a Penumbra transaction, submit it to the network, and get absolute finality of its inclusion in less time than it would take to get a single Ethereum block. Cool. They should make Ethereum faster, in my opinion.
Well, okay, but it's still the 5-second resolution.
No, I'll get there. I'm just trying to back you up on your campaign to make Ethereum faster.
Okay.
To the question about is that batch time too slow? Although the DEX execution is only happening every 5 seconds, there's not necessarily a limit on how soon someone or how long someone has to wait in order to interact with it. So if we consider that arbitraging or providing liquidity based on prices from a centralized exchange, the relevant latency there isn't the 5 seconds between the blocks, but it's however long it takes that market maker to prepare a transaction that they can submit just in time for the next block to occur. Because they don't have to, when that first auction finishes, they don't have to immediately make their quote for 5 seconds into the future. They can wait until, let's say, 500 milliseconds into the future and then submit, as long as they have some kind of fast path to a proposer.
Oh, okay. Okay, cool. Nice. And at one point, there was something about flow encryption. You wanted to hide the order flow from the proposers. Is that still on the roadmap?
So it's on our roadmap, but we did cut that scope out of V1, both because the feature that is required to make that work, which is vote extensions for Tendermint, was quite delayed in shipping. But also because we realized that Penumbra is already 3 projects worth of scope already, and so maybe we should just try and ship one thing and then keep iterating on it. But our thought is that being able to do trading strategies without allowing people to inspect the entire history is already a huge leap forward. And definitely it's something that I'd be interested in exploring for a V2. But I would say that at this point, Penumbra is going to is on mainnet. It's going to be live, and we'll be able to see what actually is useful, right? So at that point, the protocol design decision making isn't just up to me personally or other people on the Penumbra Labs team or whatever, but a kind of community driven process to form consensus around features. And so we'll kind of see okay, what do people actually want to have?
What kinds of actions can governance do? What kind of proposals can get executed by governance?
Yeah, so the governance design for Penumbra is basically modeled off of that of the Cosmos SDK. So we didn't really want to innovate too much because there's already a lot of work for the project, but it is a little bit different. So we have the same basic structure of there's a delegated voting system, so validators can vote, their delegators can override their votes. The main type of proposal is signaling proposals, where you can sort of iteratively build shelling points around particular ideas by having signaling on text. Another type of signaling proposal is for helping coordinate chain upgrades. So if the community wants to sort of change the consensus rules, there's a way to coordinate, if we were going to do this change, this is when we would do it, and we can agree about what code we might or might not want to run. Importantly, though, that upgrade process is not like directly enacted by the governance. It just allows the software to coordinate a halt, and then validators can choose to do an upgrade or not. So that's kind of the main thrust of governance. There is also a community pool, which is similar to the way that a community pool works on a Cosmos SDK chain, but that pool is initially frozen, and there would need to be a governance proposal, sort of like a meta proposal, to do a chain parameter change to enable it. Oh yeah, there's a parameter change mechanism. So there's an explicit list of like certain parameters for the chain that can be enabled by governance, and that allows like turning on and off various features.
What the heck is going on with the liquid delegation staking stuff?
Oh, this is super cool. So yeah, we had to invent a new kind of proof of stake along the way. That's kind of, like I was saying about we've already got 3 projects worth of stuff. We should chill. All right.
At least.
So one of the very early decisions for Penumbra, which is kind of a tying ourselves to the mast moment, was we decided that Penumbra is only going to have shielded accounts. There's not going to be any transparent accounts on Penumbra. There's no transparent addresses. We're not going to do this optional privacy thing. We're going to build shielded transactions, and that's going to force us to actually make all the shielded stuff work, which was correct, but it turned out to be kind of brutal. But one of the problems that comes up is okay, it's a proof of stake chain. How are you going to build a private staking system? And if you don't know who all of the delegators are, how can you pay out staking rewards? So what we built to get around that was an alternate version of proof of stake that doesn't actually have staking rewards. Instead, each validator has their own validator-specific liquid staking token, which we call a delegation token. And this represents basically fractions of that validator's delegation pool. And when someone does a delegation to stake funds, rather than saying oh, they have these tokens, and now we're going to attach this extra state to these specific tokens and say they're bonded, we say when someone delegates, they're going to do a protocol native exchange of the native unencumbered staking token to this validator-specific delegation token. And the exchange rate between those 2 tokens prices in all of the cumulative staking rewards that have occurred since Genesis. And the effect of that is that now if you, when you delegate, basically you're pre-debiting yourself for all of the staking rewards you didn't earn because you haven't been staking. But now your delegation is on the exact same footing as every other member of the delegation pool. And so when you unstake at some later point, the difference in those exchange rates is actually going to be the auto-compounded effect of what would have been a staking reward exactly over the time interval that you held that token, but the chain never needs to track that on an individualized basis. So you can economically replicate the effect of a staking reward, but it's much, much simpler for the chain because it doesn't actually have to keep track of which delegations are where and how long they've been. It's all just bundled into this single token state. And it also makes it substantially easier and safer for a third party later to build some kind of pooled liquid staking token. So for example, if Stride wanted to make like a STUM token, then all they would have to do is just implement a pooling mechanism that is going to pool these native LSTs across different validators. They don't have to build some kind of multi-sig, and it really dramatically reduces the amount of risk to the chain that's imposed by somebody building a pooled liquid staking design.
Okay, because that's what I was going to ask next. I was going to say, are we about to see people take these delegation tokens and IBC bridge them to Mars protocol and then start trying to borrow against them? But you answered that.
That would be cool.
That would be cool. But you said they might get abstracted into like a Stride STM or something like that.
Yeah, I think it depends on how efficient the rest of the ecosystem is at managing liquidity between these different things, right? So if you have 100 validators and then there's 100 of these different delegation tokens, those will all have like totally known, exchange rates relative to each other. And unless you're like really specifically pricing like slashing risk between different validators, you would be able to kind of auto-relate between them. But it might be simpler for the rest of the ecosystem to coalesce around like one pooled representation. But maybe there's others. But a cool thing is that unlike a system where the liquid staking has to be kind of bolted on, if people don't like the choices of whatever contract is deciding how to pool different validator stake, they can just exit. And that's a really cool benefit.
There's a web prover. How's that going?
It's gone really well. So another design decision that we made up front was we want to try to build like a web-first user experience and try and make that work. And it was really interesting. We were able to feed a lot of lessons from how awful is it to try to build a web interface back into the core protocol design and iterate that way. But right now, for the web prover, we have the Rust code that does the ZK proving. It's compiled to WASM, and we use web workers to parallelize the proving across each action in the transaction. This is unfortunately still like about 20 times slower than the native Rust code. But since our native Rust code was like really fast to start with, it kind of evens out. And the other thing that we did at a kind of high level of the cryptographic design was we made it so that when you sign a penumbra transaction, you don't actually sign over the proofs. You only sign over the effects that those proofs are going to have. And what that does is it lets us start optimistically creating all of the proofs in advance of the user actually clicking confirm. So if a user is using a penumbra front end, they do I want to do send X to Y, I hit submit, and this pops up the approval dialog. That approval dialog can be showing the user, okay, here's exactly what the transaction is going to do, and you can double check it in this like trusted way. And while they're looking at it, it can already be starting to do the proving. And what that means is as long as the proving time is faster than the time that it takes for a user to review the approval dialog, it is effectively infinitely fast.
It is really amazing how all the little details like that have been thought through, and how much like an Apple product, the whole UX was thought through all the way down to the lowest level protocol decisions.
Thanks. We do our best. Another kind of subtle example of that is the way that we made the penumbra addresses work. We ended up like refining this so that it would work seamlessly with IBC. So one of the goals that we had in the design of penumbra was, as much as possible, we should align the privacy boundary of the system with the chain boundary, right? And the thinking is, when you're building a blockchain or a crypto product, in some sense, in some fundamental and inescapable sense, like the cryptography is the product. And if the actual cryptographic properties of the system don't match what the user is expecting, this is going to lead to disaster. And that doesn't mean that every user has to be expected to like understand all of the cryptography, but it does mean that you need to make sure that whatever you build is actually aligned with what an intuitive understanding of the properties of the system could be, right? In the same way that, for instance, with Signal, like as a user, you don't actually have to understand, hey, here's how this like triple ratchet thing works, but it works. And in order to make this kind of alignment of where's the privacy boundary for penumbra with IBC transfers, because that's the kind of explicit action that a user is going to take. I have funds over here, I'm going to send them to penumbra, and we want that to be the place that the privacy happens. We needed a way to make penumbra's shielded pool work really seamlessly with the way that IBC transfers work. So an ICS-20 transfer for IBC, the data of that transfer is an amount, a denomination, a source address, and a destination address. And the reason that you need to put a source address on the sending chain, in addition to the destination address for the receiving chain, is that it's possible that that transfer could time out. And for a normal transparent transfer on a Cosmos chain, right? Handling a timeout is very easy. You just like send the funds back to the account that sent them. But from a privacy perspective, it would really suck if every time you had to do a withdrawal from penumbra, you have to specify, here's the long-term, like kind of linkable account that I'm sending the funds to, or I have to like, I can get better privacy, but like expose myself to loss of funds. Like this would suck. So instead what we did was we made it so that every penumbra address actually includes some encrypted metadata about what the internal meaning of that address is. And you can have many, many penumbra addresses that are all part of the same wallet and grouped into logical accounts. And using this like embedded encrypted metadata tag, we can actually encode into the address in a secret way so that only the user can see. This address is actually some like randomized IBC deposit address for some numbered account that the user has. And that means that when someone is creating a withdrawal or deposit, IBC withdrawal transaction, their software can auto-fill in a freshly generated new penumbra address into the sender or receiver field. And their wallet software will later be able to like look at that address and inspect and understand like which account it was being sent to, even though that's not publicly revealed to anyone.
So how was the experience of trying to get IBC to work with a different kind of Merkle tree than the SDK?
There's like a meme that we made of like the Vietnam dog Chihuahua, and we like overlaid like our Merkle proof format onto it because that was it was a negative experience, let me say.
See, I had a really hard time just trying to get Rollkit to work with IBC, and Rollkit uses the SDK, or it can be. I was using the SDK to try to make it work.
Yeah, I think, so there's kind of an interesting thing here, which is there's like IBC, the protocol like as designed, and then there's IBC, the protocol as implemented. And as designed, it's a super, super flexible and generic general purpose system. as implemented, it's like mostly that. But also there's a bunch of kind of implicitly specified behavior that like really you have to do some spelunking through the IBC Go implementation to figure out. And I remember having a pretty like, there's like one conversation that I had like 2 or 3 years ago with Zeki, where I'd gotten COVID and we were like stuck in this quagmire of like, it wasn't working, and I'm like doing the like phone call to get the like moral support or founder therapy or whatever. I'm like, yeah, this just feels like a total quagmire, and I don't know how we can like make the IBC stuff work, and da-da-da. And Zaki's response was like, yeah, that's what I've heard from like basically every team that has tried to work with this stuff, but you know, you're pretty good at like figuring out all that cursed bullshit, so my hope was that like you could go and like fix it and then tell everybody else, like, here's how to do it properly. And that was like a moment where like one part of my soul just like died and left my body. And then we've had others since then, but now it's like mainnet, so I can like, hopefully there's some left. Yeah.
Man, you hate to be told that you're like humanity's last hope to do something.
Yeah. But we did, I mean, the thing that sucks is like he was right, and like we did actually end up fixing it and like built a whole IBC stack, so it worked out. But yeah, we'll see how it goes. But it's been really helpful for us to have done this process of like building everything in public, having running code basically all the time. One thing that we know works because we've exercised it on testnets is like if you have a Penumbra testnet somewhere and you're doing relaying, you can just go to like faucet.circle.com and get your like testnet USDC, and then immediately deposit it into Penumbra and transact with it just like any other shielded asset, and just like works. And I think that's a thing that's kind of underappreciated about IBC is as a networking protocol, there's a lot of like spooky emergent behaviors that you only really see when you try to do stuff for real. So if anybody is building stuff that is supposed to integrate with IBC, my recommendation would be, as much as possible, just like see if you can get a test deployment and just actually start exercising it, because there's no substitute for just like seeing what the code works.
Yeah, we're starting to run out of time, but it is absolutely amazing the ridiculous amount of work that has gone into this thing over the last 3 years, and the culmination of it hitting mainnet. It's also worth talking about how this thing has not just attracted hype, but it has attracted a real community of enthusiasts. The infra that's being spun up in these early days is mostly just by fans of the project. The Discord is real people. There's, of course, a bunch of bots and farmers like everything, but there's actual real humans talking about this thing in the chat, which feels very organic and refreshing. So I highly recommend everybody try out Penumbra. This thing it came from the future.
Soon.
Can we answer questions? Should I?
Did you rewrite the whole IBC stack? Oh, sorry. Thank you. Did you rewrite the IBC stack yourself, or did you?
Yeah, we rewrote the whole IBC stack in Rust, and then
so you didn't use IBC Rust.
We ended up. Unfortunately, the state model for Penumbra is like a little bit different from what that library was aimed at, and so we had to kind of have our own. Originally, it was like a fork, and then we rewrote most of it. But we now have our own IBC implementation. We actually share it with Astria. So the like Astria stack is actually just like the Penumbra stack, which is great. But there's a common IBC implementation between those two projects, but it's separate from the informal IBCRS effort. Cool.
Thanks, everyone.
Thank you very much. And now we're going to have a 10-minute break. So we're back at 4:20, and we're going to hear from O1 Labs, Pluto, Celestia Labs, and we're going to have a panel about ZK applications. So see you in 10 minutes. 1, 2, 3. Okay. We're going to resume in 1 minute. So if you can take your seats. All right, let's start. So I'm going to introduce to the stage Brendan from O1 Labs, who's going to talk about one proof to rule them all, Mina's proof of everything. Round of applause.
Hello. Cool. Yeah. So thanks for the intro. I'm Brandon. I'm a founding engineer of O1 Labs. Now I'm the CEO. We incubated Mina, and we still build stuff for Mina. It's the one proof to rule them all. You might think this is Lord of the Rings themed, but it's not. It's children's storybook illustrations of Stranger Things, the TV show, themed. So let me tell a story. Blockchains are supposed to be decentralized. That's a thing. I would say, like, historically, like, it's working pretty well, but there's been a struggle to balance scalability and decentralization. If you have a ton of activity, then the chain grows really fast, and if the chain grows, then it's harder to sync to and limits who can participate. And if you take shortcuts, like checkpointing, you kind of sacrifice security assumptions, and like lots of things happen. And then like ZK, the superhero, comes in and is one way to help with these issues. And I think, like, a lot of people here or watching this probably are aware of the thing that people talk about all the time, which is ZK rollups. And that's, like, one way to deal with this. Here's my diagram of a ZK rollup. If we have a lot of transactions, rather than applying them to a base layer directly, we can prove that the application is valid of a bunch of these things, make a proof. We can combine proofs together, and then we can take our transaction proof and post it to a layer one. And it goes into a block, and then we're happy. So this helps because we can prove transactions without recomputing them. We don't need to store them for too long in some cases. So there's kind of tricks that you can do to get more scalable. But what I've observed anyway is a lot of these projects, like all of them, they seem to be launching in a way that's sort of incrementally decentralized. So these projects are optimizing for getting something out the door and performance at the cost of some aspects of scalability and certainly decentralization. And that's fair and useful. And like, if you're on top of a base layer, then you in some ways inherit security, and there's all these nice arguments. And I don't want to get into a fight with anyone. But I just want to highlight that Mina is different, but I want to sort of show it in this lens. With Mina, we always have kept kind of this like purism form of scalability and decentralization as we've been building it and releasing it and upgrading it. And like just now we're starting to tug the threads of like performance, because that's obviously important too. So the point is, like, Mina is different, and we end up in this upside down world. There's the Stranger Things. Okay, if we think about like Mina compared to ZK rollups, let's start at the bottom right of my beautiful diagram. We have a bunch of transactions. We create transaction proofs. Then we combine these transaction proofs together. But instead of just taking the transaction proof and being done, we put it into a proof of the blockchain. So the blockchain is actually a bunch of proofs. So it starts with an initial proof, and then it expands and grows without growing by just sort of incrementally proving the next block. And in that block, we include the transaction proof of some aggregated bunch of transactions. So it's kind of like another layer of proving. And I think, I don't know, this is interesting because like we designed this a long time ago. Mainnet launched also a bunch of years ago. And I'm not just going to spend this talk talking about things that are like years and years old. But I think it's interesting because like when we were building Mina, it's kind of ZK rollup-y like, but we didn't even consider centralizing sequencer approvers. And that's the decentralization of those things is what people are talking about these days. So, for decentralized sequencing, like you do consensus. And in Mina, we do it in a snark because it gets tiny. And decentralized proving, like you do a proof marketplace. People are talking about that now. And we have a basic one in Mina, and it's been functioning for a while. And it's, it's cool. So I don't know, I saw this tweet, it went viral recently, saying that like L2s have a long way to go before we can consider them decentralized. And, basically all of these things, Mina does them, which is cool. And you can kind of view it like a little bit like a ZK rollup, but it also kind of rolls up more. So instead of just stopping at the transactions, like we keep rolling up blocks. And so you can think of it like it's one single proof of everything that has ever happened in the Mina world. So it's a proof of everything. And this proof of everything has been sort of aggregating more and more things for a few years on the L1. And I'm happy to say, like, we never had any downtime, no emergencies, like everything kind of was stable and working. So it's a nice, strong foundation. But it's been going for a few years, just with fixed function primitives. So like inside the Mina's proof of everything until recently, it was just payments, stake delegations, things like that. But obviously we wanted to do more. And that sort of led us to work on this big upgrade to the network that we just recently shipped about a month ago, which is the Berkeley upgrade. And what this does is it makes the proof of everything able to aggregate arbitrary compute. So smart contracts, things that people want to do. And this is cool, I think. And the way this works, like on Mina, we have a compute model that's more sort of off-chain, so you can do it client-side. There's predictable gas. There's affordances for composing smart contract calls, even though you're off-chain. There's facilities to deal with races and things in a nice way. And on this platform, we have an SDK, which is a TypeScript framework called O1JS, formerly known as Snarky.js. There's cool stuff in it. There's recursive functions that map to recursive proofs, custom gates, cool libraries. This platform that we've been working on for a while, like it's here now. I'm not good at like celebrating things that I work on, like it's that kind of bragging type of thing. But I want to try and be proud of Mina. It's the first general purpose programmable ZK platform, like an L1 or an L2, that you can actually use to do real ZK things and build applications that like have privacy and do interesting things. So that's cool. And I'm also like really proud of the recursion API we have. Kobe, the king of ZK awesomeness, recently tweeted that he appreciated the O1JS recursion API. And I want to just show it because it's like so easy to explain. And if you haven't seen it before, maybe you'll get excited to play with it. So it's called ZK Program. So we're going to build a simple recursive proof that starts at 0 and incrementally adds 1. So it's a really simple, thing that we're proving, but I just want to illustrate like how little scaffolding there is. So cool. So we're going to output a number that's a field element, so public output field. And then we have some methods. So there's a base case. The base case takes no private inputs, but this is where you'd put in some private inputs if you needed that. And then there's a method. It takes no public inputs, but it returns a public output. So 0, that's where we're starting. And then in the recursive case, we'll call it step, but you can call it whatever you want, and you can have more of these. We have one private input, and that is this recursive proof that we're building. So you say self-proof to refer to that. And then in the method, we take the one private input, which is the self-proof. We verify it, and then we return the proofs. It says public input, but it should be public output. So the last proof's public output, and we add 1. And that's it. And now we have a recursive proof that you can use in a smart contract on Mina. So, you should try it and play. And even if you're just learning about like recursion in ZK and you really want to like get your head around it, I truly think that this is a good place to play around and learn that stuff. And people are using this, using the platform, using the tools to build verifiable applications today. There's people building game engines, L2s on Mina, DeFi experiments like decentralized science, voting, and it's still early. We just launched mainnet, so it's so there's like lots of room to play with stuff, and I think because this is really like the first production platform, but in this space also like one of the really early platforms for really working with ZK. It's kind of a brand new space to play around with, and I'm just excited to see what people can come up with. Like, I don't even know what you're going to build. But anyway, this is Modular Summit. So how does this fit in a modular world? And I want to talk about that. So if we think about Mina as this proof of everything, and we track its timeline, the initial mainnet release, and since then it's been sort of aggregating fixed function compute in Mina, like payments and delegations. Then there was a transition point very recently where we enabled arbitrary compute, and it's on mainnet and it's live and you can play with it. And what this does is it expands the scope of what the proof of everything can consume to any sort of arbitrary computation you want in the Mina universe. But ideally, and sort of where we're working towards now, and where we want all of you to sort of help us get there, is to make the proof of everything on Mina a proof of everything on everywhere. So so what does that mean? It means not just stuff directly on Mina, but like things connecting elsewhere and everywhere. And I'll go into more detail, but it means more bridges, it means more adapters to different proof systems, it means embedding a ZK VM. All these things are sort of in progress in the ecosystem. It means more Web 2 sort of injections, so like ZK email, ZK TLS, ZK OAuth, all things that are sort of in progress. It means getting data from the real world, like from government IDs. People are working on that. And in this world, you can view Mina as a place where proofs go to live and play with each other and compose on top of each other and combine and mix and match. And they can go off of Mina to another chain, like an EVM chain, through a bridge. And we just announced a partnership with Aligned Layer to accelerate that. You can access DA from Celestia soon. There's an integration that Geometry is working on. A lot of people are building L2s, ZK L2s to settle onto Mina because this recursion is so easy. It's just like a really great place to build those things. And other chains can even go back into Mina. So you can get these strange feedback loops. And as we're building more and more of this infrastructure, we can start to imagine like really weird and crazy things. And this is, you know, some fuzzy imagination, so bear with me, but okay. So I'll go one by one here. So Ethereum, why is Ethereum cool? A lot of reasons, but one reason it's cool is people can build these smart contracts and they're kind of out in the open, programmable, and anyone can build on top of them. And what we got was these, or what we have and what's continuing to grow is this like really interesting space where contracts build on top of each other in ways that the original authors didn't understand. It's this like power of composability. But what we don't see on Ethereum directly, or other kind of blockchains, is this kind of same ability to compose things and like mix and match and move things around, but with large data from Web 2 world. So you know, there's some projects now that like help you make proofs about data and like post them to Ethereum, let's say. But Mina is a place where we can make proofs about the Web 2 world, or with like huge, enormous data that we sort of compute on, and sort of combine them in a really nice and easy way using the ZK app layer that we built. You know, you can imagine like scaling any kind of verifiable computation that is like enormously complex through recursion. And you know, I think our platform's one of the best places to do it because it's just so easy to use, both from a like software development kit level and at the platform level. It's always first class in the system. And you can use this to do a bunch of things, but one thing that's kind of cool, I think, is like, you can imagine this huge computation graph where you know, anyone can kind of explore parts of it, and you can kind of prove your way down. But like really, you shouldn't have to run that more than once. Like once someone runs it, like it should be done, you know? So like imagine we're like proving this computation graph, and you know, we can do this in an incremental way. So we can like pause somewhere and resume it. But the really cool thing is you can imagine that you can share the graph. So other people can sort of force different edges of the computation graph. And maybe you can you know, have access through authorization based on your identity or things, you know, interesting ZK things. And you know, you can build things like shared insurance pool where like, but you keep your privacy, or I don't know, tons of weird, interesting out there ideas. So all that is like kind of out there and weird, and like I don't even have the best exposition of it yet. But like the point is, we're really trying to make like an internet of true things. So like when you prove something, it's true. You know, like if you have a proof and the proof verifies, then that thing is true against whatever you're proving. So and that's cool, but what's cooler is when you can connect it together and make an internet. So come build stuff, join our developer grant programs. You can deploy apps on DevNet that upgrades all the time. You can deploy on mainnet now. You can help us shape this internet of true things. And that is it, and I'm perfectly on time. I like that.
Thank you very much, Brendan. And next on the stage, we have Tracy from Pluto, who's going to speak about signal versus noise, why AI broke the internet, and how cryptography is going to fix it. Round of applause for Tracy.
Hello, hello, hello. Quiet room today. Nice to meet all of you. I'm told this works. Cool. Okay, so first I'll introduce myself. Nice to meet everyone. My name's Tracy. I'm the founder of Pluto. Oh, this is a very large timer. Wow. I'm the founder of Pluto, and as I like to put it, Pluto's building tools for a better internet. I used to work in consumer tech, and I started focusing on crypto a few years ago because I saw some of the challenges that we had introduced into the internet in our work. And now I'm a bit more focused on defensive tech, anonymity, and individual freedom online. So today, I'm going to talk a bit about Pluto. The first thing is that we've been trying to think bigger than blockchains. We're tired of thinking about block space. I don't want to talk about MEV. I don't want to talk about bridging or account abstraction. We're trying to think about how this microcosm that we created in crypto becomes the macrocosm. Like, how do we actually do something useful instead of meme coins? I think everyone's been a bit nihilistic this week, just thinking about how all this infrastructure we've created has been used to propagate meme coins. It's hard to wake up and go to work with hype when that's the best thing that you have as a use case. So I just refuse to think about it, and I'm trying to think about what's better. So let's have a look at some of the problems the internet's facing today. We'll go through 4 big areas that I think are challenges. That's user sovereignty and privacy, spam, fraud, and misinformation. And then I'll talk about our best ideas on how to fix them. All right, the challenges. Real ID, fake ID. So today's KYC and identity solutions, things like Stripe, Stripe Identity, Jumio, Persona, they're all built on the back of valid identities. And generative models have reached a point of quality that constructing such an ID is possible and fast. So is this a real ID or is this a fake ID? It's a fake ID. So there remains some safeguards here, and this is generated in like 2 seconds. So you can just spin up another one of these, like 2 seconds flat. There remains some safeguards. If you look at this thing, there's like a number somewhere on here. It's like DL, the license ID number. And actually there's this system called LexisNexis that the government works with that like stores these numbers, and so you need a valid number to pass the check. But it's not really hard to get that like 7-digit number these days because of so many data leaks. And once you do that, the only other like block that Jumio has is that they expect you to physically hold up the thing and be able to move it around. But now that you can just make a fake one, those checks are no longer secure either. All right, number 2, real person, fake person. So text generated from LLMs, we already know, is at this point indistinguishable from text written by a human. Soon the same will be true for voice and video. The cost and sophistication required to make that type of material is rapidly declining. Real media, fake media. Generative AI produces increasingly realistic video, audio, and images, so we can no longer trust our own human judgment to determine the correctness of this information. So imagine this scenario. You watch a video on Twitter and you think to yourself, damn, that can't be real. Did Biden really do that? And then you attempt to investigate. You're like, I'm a smart internet user. Let me go to Google, pop this in. What does CNBC say? Ultimately, you try quite hard and you conclude that you do not know if it's real information or fake information. How many of you have actually had that experience? Okay, that's like 50%. Not quite 90, I was expecting 90. This is a challenge. If our best internet users, who are our most sophisticated users, literally can't figure out if the internet's lying to them, it's a pretty tricky future. All right, my attention, your attention. So, internet businesses are misaligned with their users. They are literally incentivized to produce harm to users so that they can earn the most revenue. This startling fact, youth suicide rates rose 62% from 2007 to 2021. An interesting correlation with that date range is the rise of Facebook and Instagram. This is a pretty dystopian reality that we've constructed. The internet was started as a utopian place of interoperability and user sovereignty, But now we've entered an era of kings and peasants on the internet. The power to exit and interoperate is missing. So just a review of the landscape. We have surveillance and walled gardens that users cannot exit, and the systems actively exploit them. We have fraud, we have spam, we have misinformation. So what are our best solutions today? I touched on these a little bit, but I'll go in a bit more detail. So for fraud, they employ many techniques today. They use deep neural nets based on videos of users to try and determine if it's a real person with a valid ID. So you'll be asked to hold up your license in front of the camera, and there's literally a neural net like monitoring how you move it, the sheen on the license, your eyes, where they're looking, and trying to determine if you're a real person. And this is about as good as it gets in terms of what we can do with fraud in the computers of today without cryptography. Spam and misinformation. So our best techniques for spam are account gating. Charge $8 to make an account. That raises the floor, but it's not the best solution. If you really want to spread misinformation and spam, you're willing to pay $8. We also have CAPTCHA. CAPTCHA's broken. We also have content moderation. This is a room full of, well, probably Philippine people who are trying to moderate all of this content, and it's an infamously horrible job. For misinformation, we have community notes, which has been reasonably successful, Google Fact Check, and a few other things. Cool, but this, I also don't want this to be all doom and gloom, so we'll get into some solutions. All right, let's talk surveillance and interoperability. So this is one of my favorite meme coins. Thanks, Jomi. We have some progress on this. We have private messaging like Signal and Telegram, which have become prolific, and I think that's an underestimated awesome reality. It wasn't obvious 10 years ago that we would have end-to-end encrypted messaging. We also have enclaves in our phones. You can attest to arbitrary code on your Apple and Android device. And we have blockchains. This is a blockchain conference after all. As we're well aware, blockchains have their challenges and limitations, but they have carved a path for user sovereignty, privacy, and the power to exit. So is there a problem? Yes. User surveillance rampant. Fraud prevention is robust, but the rate is increasing, and spam and misinformation are difficult. Let's talk about emerging solutions. So what about fraud and spam? So we've seen some progress here. We have proof of humanity, right? This is built by WorldCoin. It's a first principles approach, and it's really powerful technology. They built a hardware device that can scan your eyes and collect user identifying info. It's a little bit scary because people do worry about the privacy concerns of scanning your retinas, but ultimately they have invested really heavily in making sure that that data cannot be leaked and is not of value without direct access to the hardware. There's also signed identity documents, right? So passports now have an NFC chip that have your signed data in it. And you can also compose attestations. You could take this data out of a signed identity document and other sources, compose it together, and make some form of identity. That's promising. We also have some techniques for misinformation. There's attested sensors, the idea of your voice being recorded or your picture being taken and having an attestation to it. There's verifiable modification of images. So you may have an image on one site, needs some edits and ported to another site. You could imagine a green check mark for content correctness around the internet or content authenticity and provenance. And there's this idea of perceptual hashing. So that's monitoring or measuring content similarity between different images. All of these are useful for just tracking the provenance of information and propagating it forward. And then emerging techniques for exit. So this is what Pluto's been focused on. It's cryptography tools for users of Web 2 systems. And if these tools are powerful enough, it gives users the ability to exit these walled gardens and evade surveillance. So how can the internet thrive? We need the best part of blockchains to apply to the entire internet, not just blockchains. That means we need to give users the power to exit systems, giving them sovereignty and privacy. We need to solve the Sybil problem with robust privacy-preserving digital identity. We need to build a chain of trust for content provenance. This gives you authenticity. And we need to create shared protocols for information and user quality. This gives you interoperability. These are the things we wanted out of the internet before it started falling apart. So what is Pluto? Pluto is building web proofs. They're like a bridge, not a blockchain bridge, but a tool for data portability between data sources on the internet. They are privacy preserving and authenticated. This screen keeps going out, so I'm like forced to go back here. They give users information sovereignty and the power to exit these systems. If you can prove a fact that's in a central database, you can extract it from that database and take it somewhere else. And they also give you the power to create new markets. If you can prove that valuable data in that database was transferred to a counterparty, you can use that proof to create a market on-chain, or even with another web proof on the other side to create, with standard financial rails, a market. So one idea we're exploring is the ability to sell your Twitter account without trusting a counterparty. But that's just the start. You can have on and off ramps without KYC. You can sell domains without a counterparty. You can sell a tweet. You can sell any valuable digital information in the Web 2 world. So how does this work? Well, we hijack the tools of the existing internet. Specifically TLS. TLS is a protocol that powers 80% of internet traffic, and we can't get rid of it. Without TLS and PKI, the internet does not work. You can't input your credit card without PKI. It's fundamental. And if we mix that protocol with some novel cryptography, we can create a proof that you received some data from a server, and the client who received the data cannot lie about the exact data. And you can use this proof to transport information from one Web 2 system to another. It effectively transforms a web server into something like a blockchain. The only then trust remaining in that system is, did Google put the right data in the database? Did Twitter put the right data in the database? Now, there are some limitations there, but it's a start. So what does Pluto believe? We believe that cryptography tools chart the course to a thriving internet. And we have a master plan. Our master plan is to nerd snipe people on web proofs. Use a web proof, bring data on chain, create a new market, create a new application. That's what we're here for. We can use that to break walled gardens in the internet. And we can create novel markets for exiting those systems and monetize that capability. And using that money, we can R&D more cryptography, and web proofs start to break internet market structures, and more cryptography will finish the job. MPC allows for collaboration, FHE for offline collaboration, and in doing so, you can change the internet economics. And if you change the internet's economics, you change the internet. So thank you all for listening. I'm available for some questions. I've got a few minutes left. Scan this if you want to learn more. Do we do questions?
One of the examples that you gave was like selling a Twitter account or selling a tweet. Actually, how does that actually work?
Right. So to sell a Twitter account, you essentially need to prove you have access to it, and then you need to give that access to somebody else, and then they need to prove that they have changed the email and they now have access to it in order to unlock the payment funds.
But like each one of those are little mini web proofs?
Exactly. We actually need both web proofs and email proofs in order to make this happen, but that is how it works.
Is it using anything like ZK email in part? Like
Exactly,
sort
yeah.
of?
So ZK email is focused on verifying authenticity of email data, and we do that for web data. And it's a little subtle, but you don't always get all the data you have in Twitter via email, but you get some important data, like when you reset your password and other things like this. So we need ZK email for that, and we'll actually use their open source code for that. And then you also sometimes need data directly from like Twitter's API to get like finer grained information, and we use Pluto's web proofs for that.
Is there any other questions?
Wouldn't that create a secondary market for proliferate hacks, essentially, if you have a secondary market for accounts?
Yeah. I mean, I think there's already a secondary market for exploited Twitter accounts. But I think you can also create a secondary market for non-exploited Twitter accounts, which doesn't exist on the internet today. I mean, you can try. I actually tried to buy a Twitter account, and the guy like flaked because he was like, "I'm not sure if I trust you." And I was like, "I'll build a product for that."
Is there still parts, though, of closed systems that you can't get inside? Like you sort of mentioned using the Twitter API and emails, but like, like with banking or something, would you actually be able to do anything there?
Yeah, totally. You can prove a bank balance. You can prove the financial history in your Chase account. It's like any data that can be displayed to the user can be extracted with a web proof. So if you go to chase.com, you log in, you view your history for the last month, you're viewing that information, and a web proof allows you to also collect a proof that you viewed that information. I mean, there are some things like maybe like internal data in a Google weather database that you don't have access to that we can't make web proofs for. We need some way to actually like access it through an API, but otherwise it's pretty flexible. And there are some limits in terms of performance. I don't want to overpromise. Like if you download a gigabyte of data, that's going to be hard for us to prove.
Thanks. Like following that, like on the Twitter example. So, like before, you said that it's sort of like breaking the walls, like and being able to extract the data from like Web2 providers. But if you consider this as a sort of like hostile thing, like from the point of like Twitter, for instance, and it's sort of like the same thing with like web scrapers, right? So you always like depend on particular, like outputs. Yeah. Right, so it's going to be like endless race, right? Like eventually.
Yeah, you need some structure to the API for sure, but it's a cypherpunk tool. I mean, end users can use it without an intermediate server. So, there's sort of a piece of GitHub code that maintains how to extract the data from the Twitter API or the Twitter page. We tend to not focus on scraping. We actually try to use APIs, and there's a lot of good APIs available, and those are more constant. They change sometimes, but it's a bit painful for Twitter to change those types of things. But the remediation would be a user puts up a ticket and adjusts it to the new form of the API.
Gotcha. Sorry, like another question. So I just like wondering, like in general, so how your approach like different from like TLS Notary or? We
actually use TLS Notary.
Okay.
But we also built an alternative to TLS Notary that's a bit more performant, or like 10x more performant. It has some trade-offs as well. So we're kind of pursuing two paths right now. One is improving TLS Notary as much as we can and improving its performance. And PSE is working a lot on that. We're working with them. And then in parallel, we've built another technology for it that uses this proxy-based approach. It's more centralized in some of these things, but it allows you to experiment and try it out before the cryptography is fully ready.
Yeah, I had a similar question I was going to ask. TLS Notary, I think, publishes a warning saying that there's potential, I think, for man-in-the-middle attacks. Is that something you believe you've kind of inherited as well? Or
so TLS Notary, the only way to man-in-the-middle TLS Notary, it's very detailed and subtle, but if you use TLS Notary through a mobile app, it is impossible to man-in-the-middle because it's actually not it's not in the middle of the connection between the client and the server. It actually sits and interacts purely with the client. So there's no man-in-the-middle concern. However, TLS Notary has a configuration where you can use it in a web browser. And due to some subtleties of the networking layer, you actually have to proxy the traffic while you're in a web browser. And in this setting, there is some risk of man-in-the-middle attack. However, TLS Notary largely alleviates that by the way that it validates the TLS traffic. So the only attack I know of in the web browser setting would be to spoof an IP address and successfully route it to the receiver port of the proxy machine, which is almost impossible because of the way internet routing works and because of the way TCP/IP works. There's some minuscule risk, though. The proxy is much more vulnerable to that. So that's like the centralized system. We run it in AWS. You won't be able to route a packet to it. But if you were to decentralize that, you could actually attack that one. But Notary is pretty strong. All right, is that everyone? Cool, thanks for taking the time. I'll be around if you have any questions.
Thanks so much, Tracy. Next up, we have Neshq from Celestia, who's going to talk about ZK accounts.
Perfect. Hi, my name is Neshq. I'm a protocol research engineer at Celestia, and today I'll be talking about ZK accounts. I'll start off with this diagram. I believe we can define blockchains in these constructions. So you find most of them either on the top side and some of them on the left. Let's take Solana, for example, right? It does everything. It executes the whole thing. And you can maybe see some conversion to move to the right part, right? We have ZK compression. Maybe we will have roll-ups on top of Solana and only verify. Then, of course, you have Ethereum, right? And Ethereum's roadmap is really the layer 2 roadmap where we're moving further and further into the direction and putting computation off-chain. And you can have something like Bitcoin. And I would say Bitcoin is more on the left. You have scripts. There's some expressivity. But there's current proposals. There's the BitVM. There's also maybe potential other ways to move to the right, like OPCAT, where you add enough expressivity to create rollups. And if you want to think about Celestia, you have to extend the graph, right? We are really on the far left because you can't do much on Celestia, right? You can transfer tokens, you can read and write blobs, and you can stake. That's really what there is to do. And what ZK accounts really enables is, to have that left curve mindset, but really push towards the right. And how it makes it, it's basically what will happen is that Celestia can teleport to the end game. We have now the holy grail, at least on that dimension, that people would strive for. To some background, this was proposed a year ago by Mustafa to have the ZK snark as the verification key, right? You have an account, and the verification key is the ZK snark. And we got a spec from Succinct and have been working in the working group on creating, working more on the spec, thinking about interoperability and all the other questions that concern the ZK account. And it can get, political or questions arise, right? As if we do not have a execution environment, a virtual machine, the option is to enshrine a proof system. Now, which one do we do? And this is, of course, a topic of conversation that you can be a part of as the community. And we have to remind ourselves of the core values that we bring into here, right? And especially these three, where one, the user is a first-class citizen, which means that what we get by adding ZK accounts is increasing that trust minimization because you do not have to trust intermediaries, let's say, for bridging. Another thing is we have to keep in mind credible neutrality to the execution environment, which says that any application should be, we should be able to deploy without enshrining any specific execution environment. And I think the most critical part is to keep the state bloat minimal and not add any overhead to the state machine. So what is a ZK account, right? You can think of it as just another account. Currently, we have our account, and we can transact with it using our private key. We have a user. And mapped to that is a public key. And we can verify a transaction that we sign over with the private key using a signature against the public key. Very simple. And to be, have a metaphor, you can think of ZK accounts as being another account where the user of the private key would be a program, and the public key would be the verification key against that program, right? If I want to prove or verify some state transition function, I would do that against the verification key. And I would do that with the ZK snark. And now we can look at the code and options and how to build that. But I am sorry, this is not the talk for this. I will instead give you all the things that you can build with ZK accounts. Okay, so 3 things that we can do, right? Transfers. We can do transfers. I can send TIA from an account to a ZK account. And if you think about it, transferring TIA back from a ZK account to an account is trust minimized bridging, right? You verify that something was true, and against that key, you are allowed to, in other terms, withdraw from the ZK account. So one thing that you can do is put in any state machine into a ZK account, and you have a rollup, right? This is trust minimized bridging between an account and a rollup. Currently, this is not great, right? If you want to have TIA on a rollup, you would have to use IBC, which is enabled at Celestia, go through a Comet BFT chain, and then to a rollup. And you add a path dependency for one and a intermediary. And if the chain is not trust minimized, the Comet BFT chain doesn't allow end user verification, you are basically not following the core values. And one thing that could be interesting that as a food for thought, which is, you have to discuss, but if you are connected to IBC, is there a way to transfer those tokens through Celestia to the ZK account? And can we do that in a way without, for example, let's say removing the token filter, or, well, that's basically the point of discussion. Okay, what are other things, right? We can do staking. In a delegated proof of stake system, what you will see is, no matter if you want it or not, you will get liquid staking, right? And this is how staking would look like from a point of perspective of a ZK account to a validator. But how would you do liquid staking today is you would have to bridge out using IBC, then bridge back into a multi-sig, which is the most expressive thing that is, in the future there will be also interchain accounts, and then stake using that multi-sig. Of course, now you have 2 trust assumptions, the Comet BFT chain and the multi-sig, and you will basically get minted the TIA on the account. And how you can change that is putting just, let's say, a liquid staking module into the ZK account. And now what you have is trust minimized liquid staking. And, we can go to the final boss and look at restaking, and the flow is just similar, right? You put into your restaking module, that communicates with the liquid staking. It stakes, it goes back, the receipts flow, and in the end you would get the staked tier, some representation of the LRT, and you can loop that how many times CT allows you to do. And I'm not saying that you should do this, but you can do it at least in a trust minimized way. And what we were talking about right now is all server-side proving, right? You have your transactions, you have your state, you give it to the server, and it creates a proof. With that proof, you can do things like deposits and withdrawals. But what if you actually care about the client side, right? What if you want to use the ZK part of the ZK snark? And one interesting thing, right, the talk before, what if we, let's say at ZKmail, right, I have some private data, and only when I got the email, I can actually send TIA to another account, right? Or use the presentation before, and if I am allowed to open a website, this gives me the proof that I have some, let's say, proof of ownership. But you can go a step further and think of it like, oh wait, ZK account is an abstraction over an account. So ZK accounts are also account abstraction, right? And one example could be a key store rollup. You can add all kinds of things that you would want in a key store rollup, right? Key rotation, social recovery, spending policies, or you can prove that you're OFAC compliant. And that is, I think, very powerful in the context of layer 2 fragmentation, right? You have so many rollups, and on each of them you have your own account, and they're all maybe using a different account, different private key or the same one. But if you can rotate the keys on a ZK account, why not let that ZK account talk to the rollups, right? And if you rotate the keys on one account, you can rotate the keys in the whole ecosystem. And I think this is very powerful and could unlock really frictionless communication where the user, doesn't really see it as multiple chains. Okay, the third thing that you can do is posting blobs, right? And I was doing the presentation and I was, starting to come up with more and more things that you could validate over the blob. And I think it's still very unexplored, but one very obvious thing that you should do is maybe, let's say, a shared sequencer is posting blobs to Celestia. Currently, they have a problem of who is actually paying for the blobs. Like, there's some relayer, but who owns the keys of the relayer? You can all abstract that away and just say, hey, if that Tendermint Lite client says the consensus was valid, then you can spend blobs that they were specified, or have some blob faucet where you fund it and anyone can post blobs using that account when they certify some rule or ordering rules. There are many ideas, and you can think of it as solving the Woods attack, an attack where you basically spam your namespace and add additional prover cost to the prover, and this whole fully circumvents that. And the last thing that I wanted to add is, okay, we went from server-side proving, we went to client-side proving, and let's just expand, right? I think you've seen this diagram many times, right, under different flavors. but it is, I have many proofs, and I aggregate it, and then I post one proof. And this is just one thing, right? This could be prover aggregation. This could be intent matching, solving, any type of aggregation that really lets the developer be lazy and don't have to think about how they should communicate with that with other rollups, because they just plug in and communicate. So as Mustafa said yesterday, lazy bridging is a lifestyle. And this is where I want to, revamp and take a step back, where we as a community and in the working group, like we were proposing this ZK account primitive, and it is a very small primitive, right? This is a small change. It does not increase state bloat. It increases the trust minimization of the end user, and it really unlocks so many things, because you can now, with a small primitive, have profound value in having all of those additional functions. And yeah, with that, I want to thank you. This is my talk, and yeah, if you have any questions, please ask them.
Thank you. I got two questions. So first, I think we could mention briefly the state, but there's going to be a state or an ability to use outputs of previous transactions, a second which proven systems if if it's already settled or it's not settled.
Could you repeat that question? Sorry.
So the second question is which proven systems do you
Oh, the proof system that we're
yeah,
considering, yeah, the most spicy question is one is Gross 16 and the other Plonky, and there's questions, right? You could say, going back to Vitalik's tweet, Gross 16 is bad because it has a trusted setup on each circuit, which is not the same trusted setup as other proof systems. But it created the opinion from, I got that from Uma, a very interesting Schelling point where you decided on one proof system, and all of the development, because it is somewhat enshrined in Ethereum, was actually built towards that, and new funding for the whole ZK community was there to actually enable this. So I see there are downsides, but I think there are also a lot of positives to keep some Schelling point around a account, some specific proof system, to really focus development and funding in that direction.
Thanks. And regarding the state, any insights?
Yeah. So if you go back to that slide with that many code examples, there are different ways how you can manage withdrawals. And one of the things that you don't want to do is basically prevent double withdrawals. You have one ZK proof that is correct, and you are withdrawing many times from it. And there are various options. We haven't decided on which one yet, but it basically it will involve some kind of nonce. And one additional, I think you will get a 32-byte field of state, which can be then also represented as a state root or the additional computation missing the public input. Yeah. Okay.
I have a question as well. Why not have more than one verification system? What's the cost?
Yeah, just let's all. Every time a new verification system I think that the cost would be the selling point, right? If you develop prover infrastructure and all the optimization, it always goes around and what is the last rep that we have to do? And having a limited set of proving systems, I think, would improve the computation and time for something to be valid for the whole ecosystem. So I'm not opposed to adding multiple, but I would be opposed to add some virtual machine that could encapsulate anything. Okay. Thank you so much again.
Thanks, NashQ. That was great. Next up, we have a panel led by Anna talking about ZK applications.
Some water. I'm number 5. Hey everyone, how are you feeling? We are almost at the end of this 3rd Modular Summit. How are you doing? Feeling good? Still have a bit of energy? I'm really excited about this panel. I feel like I've been sort of looking forward to it all day. When putting together this program, Yaz was kind of saying there was an attempt to have more of a focus on applications. I don't know if it was successful, but that was sort of the push. And with today's panel, the plan is to actually talk about ZK applications. But even still in the ZK space, I feel like we're probably going to end up talking about some of the infrastructure just leading up to the applications. But we're getting closer. A few years ago, we were really talking about the proving systems only. Then it was some implementations of those proving systems. Then it's scaling solutions. Then it's co-processors. You're still in infrastructure. You're getting closer, but you're not quite at the user. But today I have 3 guests with me that I feel are working much, much closer to the user. And actually maybe in your case, directly with the user, so a true application. Let's start off with a couple intros. Ayush, why don't we start with you?
Yeah. I'm Ayush. I work on ZK email primarily. So the idea is that you can make proofs about any email you've sent or received and use that to either trigger blockchain transactions via emails directly or use it to prove any identity information that you already have in your inbox.
Cool. I'm Tracy. I'm the co-founder of Pluto, and we're making web proofs, which is a proof of internet data that you can use for a variety of things we'll talk about.
Hi, I'm Florent. I'm working on proof of passport. And what we're doing is making it really easy for users to scan the data that's in the NFC chips of their government-issued ID, whether it's ID cards, whether it's purely digital ID, whether it's passports, and making sure that they can do selective proofs of specific things with it without disclosing all of their private data if they want to be compliant or just prove that they are real human beings.
And maybe just to make a slight distinction between these projects. So in your case, you're actually working with an end user. So you have an application.
Yeah.
So yours is a true ZK application.
Yeah, I guess so.
Okay. Wow, yeah, we have one.
A use case.
But the
use case has emerged.
The other two, tell me if I'm wrong, but I think of what you're doing is just before that application. The web proofs, a developer would be using these, right?
Yes, but they live in your web app, and we'll probably build some applications. I don't want to spoil things.
Okay. So you might go forward to the user.
I know, it's crazy.
Well, I would say we have, I think you sort of need both. We have this library, it's in 8 lines, you can define a new type of proof, or you can, in 3 lines of the SDK, you can trigger a transaction from an email wallet. But it's also, I think, to know what to build, we also have to be building the applications or work very closely with people who are building the applications. So in our case, I think we saw ZK P2P at one of the ZK hacks take some of the ZK email tech and just run. Yep. And that even deployed itself on mainnet using ZK email tech, which was really cool. And then on the core ZK email team side, to give ourselves kind of product feedback, we also have I guess you could kind of say this is a user-facing application, but it's like 2FA and account recovery on existing wallets with emails. And so it's kind of like an add-on to any existing wallet, but we are going to see, as the moment we launch on mainnet, probably next month, we'll see users start actually making these proofs for wallets.
Okay. I'm trying to come up with like a slight definition though of what category, like at what level are these projects that you're building, you two? It's almost like just under the application.
It's like middleware. I don't know.
Yeah,
it's like
I always feel bad when I call something middleware.
I know, it's a horrible. It's an SDK. It's an API.
It's got like a weird.
The reason is it's like not a pure protocol, right? So we can't just ignore all the realities of how like user experience and DevX experience works and just like write pure Rust code and ship it. We actually have to like get into the meaty bits of how web apps and like mobile apps work.
Yeah.
So that starts to get to like middleware.
I see.
I see it as like there's kind of, like some sort of dev tooling layer between the user or the application developer and the ZK stack. So they don't need to think about CIRCOM or ZK or constraints. They just define the parameters of their proof, and we figure all that out for them.
Very cool. Let's talk a little bit about ZK applications. So in your case, you're doing proof of passport, and like I think that's firmly in like the ID type application. And I feel like there are other variations of that. So the one you're doing is working with, I guess, the NFC chip in a passport, in a physical passport. There are others that do identity based on like on-chain activity. You had mentioned like Stripe. So this is like, I guess, photo KYC, or is it just because you have an account or you have a bank account? Like, how does that?
Yeah, I guess there's a lot of identity information stored in different places, and passports is one, and central databases like Stripe or like even Coinbase KYC is like an example of identity data. I mean, usually it depends on some sort of identity document in order to get that data into Coinbase, but then you can kind of transport it out of that with a proof.
Although I'm just realizing actually those aren't ZK examples, those are just regular ID examples. But ZK...
Yeah, those are just standard ID, but the ability to port it around and have authenticity is where ZK comes into the picture there.
But there were also previously like ZK ID, which were like, I mean, this is a project I always bring up, like Sysmo. I just thought that was so cool, the badges and stuff, and like ZKPs to accounts that were unattached to activity that had happened on other accounts. You're currently in the ID space. Are there any other sort of like ZK ID variations that you've seen?
Yeah, so we're actually mostly working on passports, but now there's a few teams. Well, there's a few teams working on passports, and there's also
I think I know it's you and two others.
Yeah, there's like the Rarimo Freedom Tools people. There's like ZK Passport. There's also a lot of teams like just prototyping like ID stuff. So there's one doing like the Taiwanese digital identity. There's like Mina Wallet doing it with the My Number cards in Japan, which are really nice because they can like sign transactions, do a bunch of things. There's like different ID systems, and my take on all of this is that like trust and like identity online have been extremely hard to make work basically since the beginning of like the internet in the 90s, because like data is really like simple to, I guess, transmit and send and store, but trust is much harder to transmit because it relies on these like very human like interactions and networks. And this is why basically like every like web of trust like system that has tried to do like under collateralized lending or something has pretty much like not worked because it's like very easy to attack. But I think the key thing that's happening right now is that ZK is becoming just practical enough that we can like take all of the sources of identity that are not purely on-chain, right? And I think this is the mistake that Sysmo made. Like personally, like they just focused on the on-chain stuff, but like now we can take like ID cards, passports. Okay, they are not perfect. Like I guess countries can cheat and like mint an arbitrary number of passports, right? But they're not doing it right now. So right now we can use it to like bootstrap those networks, and then maybe later we have like other problems of like, oh, the like countries are cheating or something. But when that's the case, half of the work is already done because we can like bootstrap those like very like reliable like trust systems, and I guess like signatures is like the kind of perfect way to like do it, because you can directly prove them in ZK. And like for other things, you've got like TLS notary style designs and like other designs that you can use to like port this data in Web3.
It has felt like there's sort of a disconnect between some of the ZK ID stuff and the stuff that people actually use for IDing things. And still, even in the examples you gave, I feel like there's one missing. And I'm curious if anyone else does this, but like whenever I'm trying to verify whether something is real, I actually just go on Twitter to see if that company released that link, or that somebody I know from that team has like clearly put it, and I will not even always trust that one tweet, because you know that could be compromised too. But I'm using, it's so weird if you think about it, like that's my attempt to get that, you know, authenticity stamp. It's quite weak, but yeah, I'm thinking like this bringing together of all these different senses for identity will be really exciting. And ZK does seem to be the only thing so far that can really do it.
Yeah, I think building on what Florence said, I think ZK lets you have portability of trust without a custodian. So in the past, you had to kind of trust somebody else to go get information from one place, move it to another, and you needed a custodian in the middle. And now you can just carry forward the provenance of that trust, which is a powerful primitive.
Do either of your products do that though? Like, would you say, like that thing I just described, where like you go to Twitter to see if it was tweeted?
Oh, I see.
Like a verification, like.
Yeah, I think like we could make a proof of a tweet having happened, and I guess you could carry that around. You could bring it to a different website or to a blockchain. That's a little bit less about the authenticity of that tweet, though. It's more just like taking for granted that it was truth when it was tweeted. Yeah.
Okay. Yeah, I think similarly on proving data from a place like Twitter. I think when you want to get that Web 2 data onto Web 3, the ideal world is somehow Twitter has made a digital signature attesting this is what happened. And then you can wrap that digital signature in any ZK proof and prove it on chain. And a lot of the trouble we've had is that these signatures are quite elusive. Like most platforms don't really sign most things. Some social media platforms like Blue Sky or Farcaster have really been like signature maxis, like every post is signed, every action is signed. And that's like huge because those are immediately interoperable with not just on-chain tools, but any tool that connects to on-chain tools. And so that's like quite powerful, and you can really build really interesting systems on top of that. And in the Twitter example, for instance, they send some interesting emails, which you can directly hijack the signature off of and make proof. So for instance, they can tell you, oh, here's what's in your feed today, or they can tell you, hey, this is your username. And so you can get some of those directly, but for the others, you need to trust like a notary or a proxy or something like that, which is still better than what we have today, which is nothing at all.
Yeah, this is like exactly the limitation with web data today, is none of this stuff is signed. So you have to come up with some clever scheme in order to emulate signatures, which I admit is like a shitty solution because you have a collusion problem. Collusion, like literally I was laying awake last night thinking about this collusion problem because it literally keeps me awake, and trying to devise clever schemes to avoid it. But I think the perfect solution would be like all the web servers just emit signed data, right?
Yeah.
There's a spec called SXG, which is about signed exchanges, I think it's called, but about signed web data. I'm like somewhat pessimistic this happens at scale in the next few years, but maybe we can kind of encourage the adoption of it and also show the demand for it by using a tool that may have collusion risk to start building use cases that are interesting, like the Twitter account escrow I talked about a little bit earlier and other things.
Yeah. Tracy, you just gave a presentation earlier today, so I think we have a better sense for web proofs and how that's built. You had a bunch of people asking you questions, also kind of figuring that out. But we didn't hear from you about how ZK email works a little bit deeper. And I think it would be good, especially because I have these other use cases I want to kind of bounce off you guys. So I think it's important for us to understand exactly what that's doing, because that is sort of one of those workarounds you talked about, where it's like we don't have access into the companies, but the only thing we have from them are the emails that they're sending out, and then we can do stuff with that.
Yeah, it's a great question. So the core idea behind ZK email is that we hijack the signature on every sent email. So for instance, since 2017, there's been this DKIM standard in play in which all sent emails, the sending mail server signs with an RSA key. And so the idea is that, say, Venmo sends you an email. in order to land in your Gmail inbox and get verified, Venmo needs to sign it with their RSA private key, and then sign the from, the to, the subject, and the hash of the body. And then you can verify that, and specifically Gmail mail server does when you receive that email to check, oh, does this key that signed it match the key that Venmo posted on DNS? And so what we can do is we can wrap that entire thing inside a ZK proof, and then we also build regex inside a ZK proof, and we threw regex on top of that, and now you can parse out any data you want in that email and make just that data public. And so the idea is that, yeah, it's a little bit like cheeky. Like we're taking this data that was never really meant to be proven, that was never really meant to be outside of your own inbox, and we're kind of hijacking and say, hey, we can prove like your email domain, or we can prove your username, or we can prove
you
your
have
bank
an
statement
account
or something like that. Yeah.
And the example you had given there was ZK P2P, where it's like a Venmo account, and you're using the literal. This took a while to sort of realize what it really was, but it's like the literal emails that Venmo, the company, is sending the user, is what you're using. It's awesome.
It was really cool. I mean, we didn't even communicate with ZK P2P by the time they had built the first version of their product, and then we were like, oh wow, yeah, this is great. I'm so glad someone did this. And it's really lucky. It's like it just happens to be the case that Venmo provides these really nice emails, which they have the sender, the receiver, and the amount, which is exactly what you need to prove that a transaction happened on chain.
Yeah, that's so cool. I want to now, so we've covered ID somewhat, but I want to now think of some other cases. So traditionally, ZK applications were used for payments, or the ZK application was payments. And we gave one example, which is kind of like a modern version of that, which is the ZK P2P example. Are there other ZK payment systems, other than like Zcash and the kind of more traditional ones, that can use your tools? Or can you envision sort of other ways that you could create ZK payment applications?
I mean, I guess one thing that's interesting it's not just payments, it's like the intersection of payments and ID, is that now that we have all of those like reliable sources of identities, we can do stuff like, for instance, instead of having to KYC into all of those different payment providers and banks and everything, maybe I can just like show that I have like signed data from the government from my passport or ID card that shows that I can do this transaction. Like for instance, I do like locally a proof that I'm not on the OFAC list at the time when I send the transaction. And so even if the OFAC list is updated every time, I can just like prove that again. And this is actually all doable in circuits, which is like really cool. One of the things we're working on, I'm very excited by. And like, I guess what's interesting is like a lot of like payment systems from like Zcash to Tornado, and like those are basically all the same designs, right, in the end. Also the same idea as Semaphore. It's like basically just proving like you are included in a big Merkle tree in a snark. Like they were not really like suitable for anything that could like combine with the traditional financial system, because they were so like obfuscated. And so I think it's one of the things that made like some actors kind of think that, oh, like ZK is necessarily dangerous because it's like this privacy preserving thing. But if we can show that you can have the privacy preserving properties for what you want, like I don't want to disclose all of my data to like many different companies every time I KYC, because it's just like obviously not secure, there's going to be leaks. It's like sure in the long term, but like just use it still to like have enough like I guess compliance or just like rules so that we can be interoperable with the rest of the financial system, which has those rules. Then we can unlock a huge thing that's like a way bigger bridge between like I guess the crypto world and the rest of the world, and that can like allow us not to be that I guess isolated from like the rest of the economics.
Yeah, doing that while preserving and sort of the values of like a blockchain, that you have privacy and these types of things. It feels super powerful. Like the regulation probably it's like would need to change for this to ultimately work in the best way possible. But because my understanding of it right now is like KYC has to originate on the place where you're going to like do the money transmission. And so if you try to like prove that KYC or bring it across from a different system, you can't really use it to be KYC'd in a new system. So I talked to a couple companies about this, like, could you build a KYC flow purely with ZK KYC? And they were like, no, it won't meet our regulation, but hopefully someday.
Yeah, I think also one underrated payment ZK overlap is actually UX. Like you don't usually think of ZK as having very sleek UX. It's like, oh, the proof takes some time to generate. But it turns out that some of the things we stumbled upon are actually you can improve the UX of payments with, for instance, ZK email. Like for instance, you send a transaction, if it's over $1,000, then your multi-sig automatically has an email signer and it says, hey, are you sure you want to do this transaction of $1,000 over email? And you confirm, and then now the transaction goes through. And so this was like one of the cool things we built where it's like, oh, this actually improves the UX of payments and improves security in a way that one wouldn't really necessarily expect ZK to do.
Oh, that's fascinating. As you guys are talking about KYC, sorry, I started to just laugh at this is a little side tangent. I think Amin did a talk about like how KYC is evil. And I don't know if I fully agree with exactly the thing in there. I think there's reasons and there's times where you understand why KYC exists. But if you have ever done KYC for a lot of different jurisdictions or companies, and I'm assuming some of you guys have, it's almost like no matter what you did on the other one, you're going to have to do something new on this one. First, it's a picture. Then it's you and the passport. Then it's you tapping your head, turning around,
rubbing your belly.
Make it like on one knee, like picture of your house, making sure you're with you and a dog. Like it just gets weirder and the questions get stranger. And I guess that's why, even though the dream is, and I don't know if everyone knows how the ZK KYC would potentially work, but it's like you show your data once, you show the passport is valid, you show it's not on list, you kind of like prepare all those things, you wrap them up into a proof, and then all people need to see is that the proof verifies. So like the thing has been checked and now it verifies. That's the dream. But it's true that these systems are so freaking different every time.
Yeah, I think people have daydreamed a little bit about like a one password, you know, you like have all your passwords, but instead you have all your proof material sort of stored in this thing, and you go to a website and you need the KYC and you click a button, proof material gets pulled into the website, none of your privacy is leaked, the website checks it, it's like, that looks good to me, and you're through.
Yeah.
That's like a pure UX win for actual users.
If it worked that way.
It's technically possible. It's just a distribution problem.
It will happen.
You think so?
Yes.
I like this.
I think it will happen.
Optimism.
The question is, who does it? Does Apple do it in Apple Wallet, or do other
True.
people do it?
If Apple, maybe if one of the big ones does it. So we've talked a little bit about ID. We've now done KYC, which is kind of related. We've talked a little bit about payments. I now want to just like share if you know other kinds of uses for like ZK, and now because now you know the purpose of this panel was really like the application level, like maybe it's ideas that you have, things you want to build, or things that have already been built using your system, or maybe it's like other applications that you would use yours with.
I think so we were very curious about this precise question, and so we ran this residency where Florent and I were at during May called like Signature Singularity, where we were exploring what are all the signatures we can find in the wild. Wow. Can we make a bunch of proofs of them, and can we build them into user apps where everybody at the end of the month has to be able to try your app, like it has to be user friendly.
Yeah.
And there were a bunch of really weird signatures we didn't expect. So there was, Florent mentioned some of the ID ones earlier, like the Mina card. There was also one interesting one around app attest. So it turns out that, for instance, Apple signs that your app executed correctly on the iPhone. And so you can prove, oh yeah, I actually queried the location API and I actually returned this value. And then I queried the camera API and then returned this face. And okay, if somebody goes through all the process of jailbreaking their phone, maybe they can get past it. But overall, it's like for 99% of users, this is kind of like a very user-friendly way for them to interact with ZK, and it's a very nice way to get kind of proof of app execution onto a ZK proof and interoperating with other things. So that was a really interesting exploration. There's also one line of research which like Cursive is kind of leading, which is I thought was very curious, which is that ZK provides truth, but what do you do with that truth? And so the whole shtick is maybe ZK alone is interesting, but what if you combine ZK with 2PC, FHE, and you build really interactive social experiences that are really fast, and you use lots of advanced cryptography. And we actually saw some of this stuff at ZK11 in Athens, where the attendees put things about themselves in the app, and you could tap somebody else's NFC and overlap with PSI, which is like this other crazy cryptographic primitive, like the things you have in common without sharing it to a server.
That's so cool. Nice. Any other? First of all, I don't know, is there a write-up of all of those ideas that you had?
Yeah, there's a ton. So if you go to demo.sigsing.com, like demo.sigsing.com, we have like an hour and a half demo video where each of like maybe 15 teams presents like, here's some crazy signature we found, here's something to proof, and here's a QR code that you can literally try right now.
That's so cool. I'm gonna kind of mark that also because we have an upcoming hackathon, ZK Hack Montreal, just in case anyone wants to check it out. But we're always looking for really cool use cases, so it might be fun for people coming to that to check it out before.
Yeah, I think it's useful both as like a inspiration, like, whoa, I didn't know you could do this. What if we built this thing on top of it? And also like, here's a bunch of open source code like that now I can use to adapt to this new signature I found, or that I can make a little bit more efficient by making it in this proof system. And I think it's a really cool start of like a brainstorming tree, I think.
Very cool. Okay, Tracy, I want to hear some of these weird
All right,
app ideas
so
you have.
I've been thinking about traditional payment rails a little bit, like credit cards and debit cards, and potentially attaching to the back end like proof of a transaction happening there. So there's this smart young guy, I know his name's Sofian. He's been brainstorming some ideas around the Stripe API and using that with credit cards. But we had actually like both had ideas around, can I create a credit card and on demand have someone else fund it for me and have sort of anonymous payments. So like I could anonymously buy something and the company that I'm purchasing from, the e-commerce store, won't learn how it was funded. And I could maybe even fund it with like money from Zcash. So that's a cool one. And I think he's developing some other really clever ideas around gamifying that. So that's one I've been excited about lately.
I want to add to that, I don't think things like Gnosis Pay have ZK in them, but I wonder if they could. Do you know what I'm talking about with that? Gnosis
yeah,
Pay,
that's like a debit card for expenses or something.
It's a Visa, it's a credit card, but it's attached to like a Gnosis account. So it's a like, you know how like crypto.com used to do?
Right.
Like you could pay with Bitcoin, but they live in their, like it's custodial. In this case, it's like non-custodial that.
Yeah, I've actually been meaning to like dig into the ACH rails that and the debit credit rails that underlie
that's what
this.
They're using, yeah.
I used to actually work at Stripe and I would work on these things.
Yeah.
And Visa uses SFTP actually to like register payment completions. So you like upload this multi-megabyte file to an SFTP server owned by Visa. And I've been like brainstorming, like, could I like somehow scheme a way to like prove I SFTP'd this? Unfortunately, like you have to have this deep relationship with Visa in order to do that. But maybe there's other rails globally that like this could happen with.
I think they built a relationship with Visa too. I think that was like, it's a fully accepted
yeah, those types of
card.
things are, they're very official, but I think the money movement in those systems is pretty fixed. So if you could find rails that are more flexible, it could be less fixed.
I mean, one interesting note is also like the first version of the Gnosis Pay card, like a long time ago, actually was making a digital signature. It was saying like, hey, like this is your private key on the card, and the private key is going to sign some stuff, and Visa is going to pick that up. And I think for UX reasons, they ended up switching to their current version, which is a little bit more UI friendly. But I think also Florent did a bunch of exploration with credit cards.
Yeah, so me and Ayush, we like experimented a bit with like actually getting like normal credit cards to sign things. And the fun thing is that they actually like sign transactions in some way. We couldn't get like down to the like lowest levels of like actually modifying what they do, but I'm like 100% sure it's possible. It's just like digging a lot in the EMV spec and everything, and I think it's like a very
I'm familiar with this.
Yeah, I think it's like a very low fruit for like hackathons and everything, because it's like a very fun stuff, and you could actually use it to do like kind of ZK P2P type system. Like it's always kind of it's kind of like using things that were not like meant for this. So like it might not work in every case, but I think it's still interesting to like prototype and basically have a system in which you can like peer-to-peer on-ramp or off-ramp using like someone that has registered as a Visa merchant and like just signing things with your card and proving that you send it and everything.
I really like this. It's like
we're
brainstorming it right now.
The on-ramping counterparty is the merchant, like the merchant acquirer.
Yeah.
This is a cool idea.
Well, you have to register with Visa, but once this is done, you can like sign things with your phone. Like you can emulate a terminal on your phone, so you can just sign with your phone and your card.
That's awesome.
That's cool. Okay, so that was one example, Tracy, that you gave, which was like revisiting payments. Anything else? You had the Twitter, selling Twitter.
Yeah, I mean, that's like a general big idea I've been pursuing. We're not quite there yet, but basically selling valuable Web 2 assets. So you might have a Twitter account that is of financial value. There might also be actions you can take on Twitter that are of financial value, but this is true on many websites. And being able to like actually create a system that without a counterparty or an escrow can exchange those with an anonymous person on the internet, it's something I want to actualize.
Does that need a blockchain, kind of? Would it be something like
So
you would create
I've actually
a
been
proof?
thinking of it as a non-blockchain centric market where you have like two legs to the journey. You sort of have like the leg onto the blockchain for the first proof and the leg off the blockchain for like money into your Venmo. So like I think the ideal user experience is I go to sell my Twitter, I like enter a few things, I create a few proofs, maybe it's like 20 proofs, but a few proofs, and then I get money in my Venmo account.
It's funny that you go to Venmo. Why not just get paid
like
on
Revolut,
the blockchain?
like wherever you want.
Why regular money? Why not just buy it with
Nobody
crypto?
uses blockchains.
Oh, yeah, you're right. Oh, what am I thinking?
I mean,
true.
I'm not all doom and gloom, but like, you know, it's facilitated by a blockchain, but the
But
users
here-
don't have to on-ramp and
It's just-
like learn
to
how
me,
wallets work and this
It's just
stuff.
funny though that you like go through a blockchain to get to the payments when like blockchains were kind of meant.
Yeah, it
to
ends up
be
being the
payment.
custodian. It's the person who can
immutable.
check these. It's the mechanism that can check these proofs.
Yeah. Okay, so that was another one. I want to keep going in that direction though, because there's some very interesting things. Like, okay, so Tracy, when you were talking about being able to like prove the balance in a bank account,
Right.
I guess this would be like getting access to things, getting accreditation of some kind because you can prove something in your
Yeah,
life.
I
I guess
think-
it's still in the KYC bucket.
Yeah,
Or
there's,
something.
There's like interesting social consequences. Like I don't know if this is interesting, but like private group chats where you have to be a millionaire to get in there, or like, you know, in order to
Yikes.
post on Reddit, I have to like. Reddit about GameStop stock, right? I have to like prove I own, prove I've got millions of GameStop, and then I'm like the authority, even though I'm anonymous,
Dude,
right?
that's such a good idea. Like if you
Yeah.
like all that noise out there for like people who often don't have
Right.
any skin in anything and they actually don't even know what they're talking about. Like the person hasn't even read the book or seen the movie or bought that thing and they're
Right.
shitting
It's
on
like
it.
demonstrating some authority. Yeah.
Huh. Wow. That's really neat.
Yeah, I guess another interesting thing is like Sybil resistance in general. So for instance, because of like the big bot problem in Twitter, there was like all of this talk about like, for instance, Musk creating this like blue check thing in which you can pay, and like a lot of bots ending up like just paying it. And so now like the replies on the every tweet are like just way worse than before all of this was even like instantiated. And yeah, like I'm not so sure it's like it would be so easy to like Sybil attack this kind of systems if you had to actually use like attestations like ID cards or like passports or like even other like Web 2 like data attestations, like the fact that you have like Google, Twitter accounts that are all like connected by the same email. You can do like snacks of this using ZK-JWTs and like aggregating all of those like sources of data. And yeah, I think it's like very interesting to think about like what social medias could be like if like verifiable trust and attestations were built into them directly.
I think there's also, I mean, two use cases that we've been thinking about. One is this kind of, I think it's like maybe a little bit clickbaity the way people talk about like AI and crypto, but I think there's two very interesting like verticals here, which are, in my opinion, changed quite a bit by ZK. One is how you sell training data to these like kind of AI companies. Currently, some central middle company like Facebook or whatever sells all your data directly. But if users can prove they own the data, they own the username, and then they group together in these like data DAOs like Vana is doing, and then you sell that directly to the buyer of that data, then you can split it on amongst the users in kind of this like data guild like format. And I think that's like requires ownership proofs with ZK to be able to do this, which is I think one cool thing that's unlocked. It's kind of on the training side of AI, and then on the like inference side of AI, there's often these models. It's very hard to tell like whether something came from a model or from reality. And I think you talked about the KYC checks, and those get way worse. Like now you can have a model generate yourself holding up 3 fingers and dancing on a ball, and it works totally fine. And so if you want to get around that, I think it's actually good that now the AIs can do that, because now you have to trust cryptography. There's no way around it. And so you have to build these rails, or else you're not going to be able to tell like truth from fake things anymore. And I mean, Tracy mentioned this in the talk, but there's this whole line of research around perceptual hashing, where now if you can make, like let's say you have some image and Canon signs some perceptual hash, or OpenAI signs a perceptual hash, like, hey, I generated this image and it looks roughly like this. And now you see some image floating around online, and you say, hey, here's an image I found, the perceptual hash looks like it matches. You can do that in FHE and prove that you found that match in ZK, and say, hey, this image that I saw that's cropped and compressed on WhatsApp actually came from OpenAI, or actually came from the New York Times, or actually came from Canon. And so there's a lot of these really weird, like kind of out there use cases that only crop up when AI is strong enough that it actually like changes dynamics of how humans interact.
Yeah, although that example, because like we know we've done experiments around the more basic form of that, which is like the ZKPs to prove provenance through transformations, but it's dependent on the first thing having a signature, and it's dependent on whatever tool you're using to make the changes having this like ZKP creation. And so it's like if you took then like a screenshot of the thing and did something to it, it loses it. So and I even know some teams doing it, and I really want to see that in the world. I think it should be in the world, but at the moment it still feels like an experiment. Like, I don't know how it gets really, really believed or used. I don't know how it gets like authority.
I think the Proteus approach of using perceptual hashes is really strong there, because the perceptual hash is robust to screenshots transformation.
What is that perceptual hash? What is this?
You can think of this as like an intermediate embedding that an AI model generates or something. Is like, oh, here's like 160 bits that describe, something of the form. There's some edges here, and there's a cat on that tree or something like that. And that is, even if you compress, crop, change, whatever, you can still map it back to, oh, this is kind of the core information that was in the image. And this means you don't have to do proof of transformation. You don't need Instagram to implement this into their editing app. And you don't need a signature to come from the original OpenAI source. You can say, someone else can be like, hey, I am the trusted, I look at New York Times every single morning, and I sign every image, and I put it up here. And as long as you trust I did my job in the morning, it's good enough. And so now you've removed both those requirements. You don't need the original signer to sign, although it is nice. And you don't need the image editing app to include it, which in my opinion is never going to happen. Like, it's so heavy and it's so difficult. You need to have a way to reverse engineer these images without doing the transformation.
So in this case, though, you're proving that it is AI. You're not proving...
Or not AI. Like, you can prove, oh, I can prove the New York Times put this on the homepage.
Okay.
And then it's like, yep, that image, maybe it's AI, maybe it's not, but at least the New York Times attested to it at this point in time. And you can prove that even with a web proof.
Interesting.
Yeah, one thought that came to mind is like, while Ayush was going through this, is like the more adversarial the environment becomes, which I think AI is making the internet an increasingly adversarial environment, the more important cryptography becomes. And I think this is a trend really I'm thinking a lot about. Over the next 10 years, I think the environment's going to continue to get adversarial, and the defensive tech we can use to counteract that is really cryptography.
Wow. I've also had that thought. I didn't know exactly how that looks, but it seems like cryptography, even blockchain, but ZK seems like it's like the humanness, hopefully preserved somehow against this wave of other stuff.
Yeah, they can do fake like images of everything, but they can break D-log. Right now, at least they cannot break like discrete log and like all of what we use, which is cool.
Yeah, for now.
For now.
If cryptography is lost, is all lost?
I mean, that's the ultimate DAC tech, like it's the ultimate defense system we have.
Is it the ASI? It's the artificial superintelligence. So before that, hopefully we can still hide behind the cryptography. We have 15 seconds left on the clock. What should we do?
Audience question?
Is there an audience question?
I don't have a question, but this is the best fucking panel I attended for years.
I think so too. I just said that. I like this.
Like,
here's to the real ones in the room. Thank you.
It's not just discussion how cool my project is or how cool my project is. It's just about things that people actually touch within like next 5, 10, whatever, 20 years, and it's awesome. Thank you.
Thanks for that. Cool. Any other questions? Comments?
So, the way that all of your approaches are going about things, you're not like, the data provider is not expecting these tools to be used this way. But why not like GDPR to get data from the big tech companies and maybe put it in a Merkle tree and...
Yeah, you can use a web proof to pull a zip of your Google GDPR data and unzip it and prove that it contains some information. I think that's GDPR is in a weird way an enabler of some of this.
That's interesting. Anyone else? Oh.
Hey. So what do you guys think is the best way to have cyber resistance for like airdrops or on social media? Like, is it just about like if you prove you have a Reddit account with an Amazon account and you bought stuff, that adds up a certain amount of points, and then a passport would like for example would add the most points? Like what's your idea on that?
So I think that like all of the recent airdrops have kind of shown that like airdrops cannot continue like going the way they are right now, because it's like basically a lot of just like people just civil attacking them, and like it's really hard for them to actually understand how they can like incentivize real activity on what they're doing. So a really interesting approach is what Gitcoin Passport has been doing, and they started doing it originally for Gitcoin quadratic funding grant rounds, right? And so they have this system in which you can like connect all of your accounts, basically like Google, Twitter accounts and everything, and you can like have this scoring system, and if your score passes a certain threshold, then you like get access to like you pass as a real human, and it's actually quite good. Like we tried to like basically break it by like creating accounts, and it's actually like quite hard, so I think it's like interesting. My guess is that we have to go further than that. Like, for instance, they're not matching like attributes in between like multiple things. So you can actually like just connect accounts that have different emails, different names. You could actually match them, and you could actually match them in ZK so that you don't even have to reveal to Gitcoin Passport itself like the link between your accounts. You could do like this kind of thing like way more generally with like other attestations that have just like recently been prototyped in ZK, like IDs and everything. And I think it's like really the way to go for civil resistance.
That really was what SISMO was too. Sorry, every time you say it, I'm just like, SISMO, why? It was such a cool project. I don't know if you guys know it.
I've been thinking about this a bit too. I think you probably also just want a model to estimate the quality of an account at the end of the day. So one of my like brainstorms is every transaction comes with a proof, and that proof it's similar. There's a tool called Stripe Radar, which like checks for fraud with credit card transactions, but it's the same kind of thing for like blockchain transactions. You bundle up a bunch of this information in your magical 1Password that has all your proof data, and you run it through a basic scoring classification model, and maybe the app developer who builds that app could even like layer in new factors on demand when they like see a new attack come through or an emerging threat happens.
Wow.
And be like, oh, actually I need a little bit more information because someone's been breaking our system lately. They can stick this in and it'll just pick it up, include it in the proof, and your transaction settles with its proof.
That's such a good idea. But yeah, what you were trying to prove with that, and I guess your question was sort of like finding a way to prove like real, genuine activity of a user instead of these silly kind of like, farming, just tons of accounts doing dumb things. Yeah. Huh. Anything else we should talk about? I think if not, then we can wrap up our panel, our last panel on this stage for Modular Summit 3.0. For some of us, it's also the last event and thing that we're doing at all. So this has been a really crazy week. Agni, who is from the ZKV team, and Cohen, thank you guys for hosting the stage. Why don't we give them a quick round of applause. Thank you guys for coming to this last panel. Thanks for watching all of the talks on the ZK track. This was done by the ZKV company project. We're a validator. running on 12 networks. So if you, and on Celestia. So you can also find us there if you want to delegate to us. Cool. All right, I think that wraps us up. Thanks.
Hello. One final note. Thanks everyone for joining. We're going to have Giselle on the screen here, and I think the roast as well. So if you don't want to go to the other space, you can stay here and watch it here on the screens.